Hello, hello. Hi, everyone. I'm
Hey
seeing a lot.
everybody.
I'm seeing a lot of people in the chat. This is so exciting. You are here at Azure Developers Python Day. My name's Dawn Wages.
And I'm Jay Gordon.
Nice to meet you all. And we got a lot planned for you all today. Um, Jay, why are you
Yeah.
excited for Azure Developers Python Day?
You know, I've come to see the Python community as being one of the strongest of all the developer communities that I've experienced over the course of my career heading into year 25. And in the 25 years, Python has always been, seems like on the cutting edge of doing new things with different technologies, going back to like when I remember people just building basic Python applications. I've worked at different companies where Python was how our applications were served. Everything was through Python. And in the modern, you're seeing things like LangChain. You're seeing the way people are using Python to build things like applications, RAG-based applications to use AI, all this stuff. You all are killing it, and we're here to celebrate you all killing it.
You're killing it supporting Python developers. I've been really excited to see all the stuff coming out from Cosmos DB
We are
for
trying.
Python devs. I mean, I'm going to be honest, I did not immediately think NoSQL DBs for Python use cases, but I'm a traditional web dev. I usually use relational databases, but this has been a really cool upskilling for me. And we'll have some more sessions this today, right, on some Cosmos DB. We got Theo Van Cray and a couple of other friends bringing Cosmos DB up too.
Yeah, Theo will be giving you some real entry level stuff, getting
Okay,
you
cool.
in, making sure that you understand what Cosmos DB is. So it's a getting started with Python and Azure Cosmos DB session. I think you're going to all really benefit from it. And I want to make sure you know that if you want to try Azure Cosmos DB for free, right down there, no credit card, go there, get working. I'm going to put it in the chat for y'all as well. But yeah, we're always trying to reach out to developer communities, and Python community has been so great for us. We've got a really useful SDK so that you can work with that to build applications that are Python.
Yeah. Yeah.
But yeah, I'm super excited for today. And Dawn, I know you and the rest of the people that work in the DevDiv organization, the people who work in cloud advocacy, you're all always reaching out and trying to put together amazing content. It looks like you've got a great schedule today.
We're trying. I think we do a really great job. If you're interested in learning about the schedule, great. Azure Day details are right there. You can find, you might be looking at us directly at YouTube. You might be looking at us from that link already. There is a link for the schedule, the correct schedule. I mean, the correct schedules, I think most places now, but that's definitely the correct schedule as things change right under that video. So make sure you check that out. There's also a book of news. We don't typically do a Python book of news, but for people who are familiar with the Ignite or the Build brand, there is a book of news of all the things that have come out recently. So we've added some things to the book of news there too, so you can find that as well. As for more content, I host a YouTube series every month. We're starting back up in 2025. But I've been talking a lot. This is a developer conference. Let's get some code
Where's
on the
the
screen.
code? Where's the code? Give me that code.
Where's
And
the
speaking of,
code?
I've got so much code for you all to try. I know we've got the AI Learn plan. You can start building with AI using Python. There's some really great examples there. I know you've got a developer hub that's got so much for people to try. And hey, I know I'm the Azure Cosmos DB person, and I want to make sure that you all know we've got an Azure Cosmos DB samples gallery. Mark Brown, who is my lead and works on our team, spent a lot of time curating some really great examples for you to start working with Cosmos DB, SDK information. There's so much stuff, even some really great GitHub repos with some samples of even AI apps. I can share some more links as we go through the day, but you got code for me, don't you?
Yeah, I mean, we were talking about code. We have some more code. This is a similar gallery. I think we're just picking a pattern that works with these having galleries available for people to start. There's Cosmos DB all through these as well. I know all today is not necessarily AI. You'll get a lot of AI, but you'll also get a 45-minute session from Renee on starting your applications. You'll get deploying Django applications with I saw Kenya shout out in there. We've got some Kenyan MVPs in the chat. So they're going to be really, really great. And if you just want to get into some code while we're talking, this Azure Samples repo for AI that we announced at Ignite is a really great place to start.
And I think the session that Sarah's got coming up later is Sarah Kaiser,
Yes.
that dev containers and code spaces. I want to hear so much more about dev containers. I feel like it's a great thing, and code spaces has made development so much easier for people. I love going into GitHub repos now and hitting period and just being like, all right, let's tear in.
100%. So I'm viewing on GitHub, and I can even show you some of the dev container. Right screen, wrong screen. I'll put it in the app. Well, in these repos, you have dev containers in each of these, which is a self-contained. I'll let Sarah do it, but there's a self-contained Docker container, and it allows you to develop in the same environment that you're working and experimenting in. So hopefully we get a lot of new people joining and starting dev containers after Sarah's talk. She's the expert on it. And I always appreciate learning from her, Dr. Sarah Kaiser. Great.
We've got we've got also on the other end of things, if we want to talk about AI talks, James Padella from the Cosmos DB team. He's got a really, really great building scalable Gen AI apps session. So, you can go from the getting started, maybe getting a bit more advanced, like, working with securing Python apps that Joylyn is going to be giving us later. We've got so many amazing sessions, things that I can't wait, especially that transforming AI development with VS Code. I mean, who doesn't love VS Code at this point? It's so many things to so many people.
When I visit conferences, I lead with VS Code. It's how you get the conversation starting off real good. People love VS Code.
Yeah.
I'm a super fan too. I have some friends over at JetBrains. We have some friendly tete-a-tete, but I am a VS Code girly.
Yeah. I ran into Burke Holland at Ignite, and Burke has always been my VS Code hero. He does so many amazing things. If you haven't seen any of his videos and stuff like that, I recommend check out what he's doing with VS Code. It's spectacular.
Cool. All right. I'm looking through these show notes, making sure we're getting through all the housekeeping. We are keeping our chat here on this YouTube channel right now. But if you want to keep in contact with us later, we have a Python exclusive Discord for Microsoft employees, friends, other developers who are working on Python and want to chat with us. That's aka.ms/python-discord. So I just really wanted to make sure we say that. And we'll also give that link again later on in the day, and it should be in the show notes. But we want you to come back. You want to see all the good stuff that we're working on. So the Discord is a really great and casual, cool place to do that.
I love going in that Discord. Actually, I recommended it to a coworker just yesterday. I said, one of the cool things about it is you kind of just hang and watch what people are up to. And if there is some assistance you can give it. If you need assistance, you can ask. I know I believe Aaron Powell is part of the big group of people that are running that. It's always fun to kind of drop in and see what people are up to. But I heard we've got another Aaron on the way. Is that right?
We do. Aaron Stark will be joining us soon, and he'll be talking about it's one of the best primers for the day. That's one of the reasons why we put it at the start of the day. Microsoft has so much learn content. Truly, I don't even get to explore all of the learn content that we're putting out on a regular basis. And we showed the Azure Learn Plan. There are different tools also on how you can learn and structure your journey on learning Azure or Python. We have whole sections where you're literally just learning Python and none of the Microsoft tools as well. And so it's really this open door to a lot of information, and Aaron's going to help us navigate that in a few minutes. I also wanted to make sure that I shout out everyone in the chat, and I see all of the different places that people are coming from, and let you know that close to you, the AI tour might be hitting you. So good amount of AI today, AI. So if you like AI, Microsoft does have an AI tour. We're hitting up major cities all of 2025. I think
they just, left Toronto like a couple of days ago.
NYC's coming up soon. That's in your backyard.
Yeah, New York City. I'm here in Brooklyn, New York. It is a easy commute to the Jacob Javits Center, where I believe things will be. We'll be heading over there. And if you want more information on the tour, right down there, aka.ms/AI tour. Really looking forward to y'all being there. I can't wait to meet some people and see what interesting things we got to share.
Awesome. Well, if anyone wants to put in the chat the things that they're excited about learning, we can make sure to ask all the questions that you're looking forward to. But let's bring up our friend Aaron to give us more about Microsoft Learn.
Hi there, everybody. Thank you so much for having me. Can everyone hear me?
Yeah, you're doing great.
Perfect. I actually have a deck I can walk us through today as well, if that works for us. Okay.
Yeah, perfect. Well, I'll hop off the screen and let everybody enjoy your presentation.
See you on the other side, Aaron.
Thanks, Jay. Perfect. Well, hello, everybody. My name is Aaron Stark. I am with the Azure Skilling team. Just very excited to be here. Thank you so much, Dawn and team, for letting me come through and hopefully be able to share with everybody.
Yeah, I just got back on screen so I can help you share. Sorry, I didn't help you do that before.
No worries.
You're getting some backstage content, audience. That's okay. But if you want to hit the present button at the bottom, and then I'll bring it up on screen for you.
Perfect.
And while that's going on, I want to give a shout out to a few people. AWM Builds calling in from Boston. We got our Kenya Data Platform user group all the way from Kenya. We've got Doug Starnes who's watching. All these people taking part in the chat. Make sure you take part in the chat too. That's how we're going to hear from you.
Hey, Memphis, Tennessee, I see ya. San Diego, I love your city. Great stuff. I'll see you later.
Awesome. Let's see. I think it might just be easier to share with everybody the plan. Making sure that's going through here. Perfect. So yes, like I mentioned, my name is Aaron Stark, and so I'm with the Azure Skilling team, and it's really excited to take everybody through our plans today. And first and foremost, this will mostly be about Python, how GitHub Copilot comes into that, and what actual Microsoft plans are. And we really see this as transforming the way we think about skilling and how developers can really build their expertise across different Azure technologies and Azure services. So whether you're just starting with Python or looking to sharpen your skills, today we're going to explore 2 different curated collections that have multiple different learning paths, different learning modules, videos, and other resources that talk about the cutting edge AI tools that have been designed and launched to help you master all the key concepts and hopefully apply them in real world scenarios for Python. So I'll take this moment here to give a little bit more context information, but what you'll see on the screen is our official plan that has Python infused throughout. So this is going to be build AI apps with Azure services and our best practices. That is really looking at how AI app development, the database, and integration of AI services coming together for this application. But before we get into all of that, I really want to take a moment to explain what Microsoft plans are and the role that they play in what we think of for skilling developers and skilling our customers. So plans are a really, really valuable resources, or excuse me, very, very valuable resource because it brings in a lot of our different learn modalities that exists on our Learn platform, from videos, interactive content, challenges, as well as some virtual hands-on content and documentation into one place. So these plans are really designed to help guide developers and teams toward achieving their specific learning or skilling outcomes with built-in milestones. So on the right, you'll see these learning outcomes for this specific plan, which cover designing and building a cloud-native AI app, doing that with a database, as well as that integration of those AI services. So being able to have those milestones, being able to share this with your peers or your team, and also having automated different reminders to make sure that you are being kept on track is really one of the biggest highlights. Additionally, plans offer this curated official skilling experience that's really tailored to developers to help individuals and teams reach their learning goals. So with a lot of self-paced features and those automated nudges, we hope and have seen that developers and learners who want to stay on track, build their skills faster, or measure their progress have found a lot of success with this modality in using our official plans on Microsoft Learn. So shifting gears a little bit, outside of plans, we offer this as a modality across multiple different Azure technologies and services. If it comes to security, more depth in AI, as well as developer focused languages. But with the specific focus on Python for today, we definitely want to dive in a little bit more onto the intelligent apps portion. So just to give a little bit more clarity, what we mean when we say intelligent apps and why Python plays such a crucial role in it is applications that really leverage data and AI to provide engaging and personalized experiences. When we think of that, it is coming to three different areas around NLP, so natural language integration, as well as data-driven personalization and rapid feature delivery. So I'll give you guys like a little sneak peek, but when you start your plan on Learn, this is what the overall experience will look like. And given the fact that we're talking about intelligent apps, really looking into what does that mean for the cloud native platform? How is that coming to life through the infrastructure with AKS, as well as using Python to make sure that we have that data-driven personalization as well as the integration through AI. So you'll see here a bunch of different modules that link to the specific learning across each task that's involved with the different milestone. So factor in the databases and APIs. And then as we get further and further down the learn plan, you'll also see that there's additional learn paths that have a set of modules. So these are going to go a little bit deeper. They're going to cover they're going to cover the use case of AI apps with the database and PostSQL, as well as additional ones on actually how to put all of that together to build an AI Copilot. So this plan really covers that end-to-end integration when we think of apps, AI, data, and how Python is infused throughout to really make sure that our apps are coming alive and developers that are using Python as their primary language, whether more on the ML side or to build AI models and solutions, have a place to refine their skills and deep dive into maybe some different topics that they hadn't been seen before. So additionally on here, I also want to add how the trends we're seeing with skilling and with the emergence of AI and what that means for Python is robust, to say the least. Specifically in recent months, we've had the opportunity to observe a significant shift from developers and organizations that are adopting AI through applications built with Python. So companies are definitely leveraging Python and the ecosystem of Python to create intelligent apps or AI-empowered apps that really bring in their customers and create different experiences in meaningful ways. And so the trend that we saw here that we're continuing seeing push through the end of this year. We only foresee that to get stronger in 2025 and the focus to become even more prevalent on that intersection of AI and app development with Python. So as a team, we're looking to embrace all the new challenges that come with that and really looking into some of what those new use cases could be. A couple of the high-level things that we're seeing on the skilling side is really that focus again on intelligent apps with Python through personalization and product discovery. So building out applications or solutions that are AI-powered, built with Python, but tailoring the user experience to individual preferences. And anything that is heavy on the personalization side is going to be deep into data, really leveraging the Azure tech stack across data to make sure that that integration is tight. The next piece we're going to see a lot of is the content integration, or excuse me, content generation and marketing. So automating a lot of content creation and optimizing marketing strategies through the use of AI and Gen AI specifically is something that has already been prevalent, but I think we're going to see a lot more of the refinement come through on what that looks like from the consumer side. The next piece is going to be service and support. So I know that there's a lot of developers, individual and also developers that work in different organizations, looking at how enhancing customer support with these AI-driven chatbots and different kind of virtual assistants are going to be one of the main focal points moving forward in FY25 as well. And then lastly, we're, as a company and Azure definitely are really excited about this shift into agentic behavior, really looking into building out custom Copilots and custom Copilot agents, really that are focused on that development of AI assistants, helping all users and developers to accomplish tasks more efficiently. So a lot of these innovations are going to be powered by Python's versatility and the efficiency that's provided by tools like GitHub Copilot, which accelerates development by offering a lot of these intelligent code suggestions. So shifting gears slightly, there is another skilling plan that is very similar, or the format is similar to what we just went through for intelligent apps. However, for this skilling plan, the focus is all going to be on accelerating app development by using GitHub Copilot. So again, Python is a huge part of this, infused throughout the different milestones and the different modules, learn paths and modalities on here as well. But when we think about those use cases that we've seen that have been very big for 2024 and thinking about what that shift might be for next year in 2025, we're also seeing that skilling is going to, what we believe, be a major vehicle in pushing all of this forward. So the shifts from AI into more agentic, really doubling down on this world of intelligent apps, skilling being critical for this landscape, especially with the rapid pace of how new technologies are emerging every few months. Keeping up requires continuous learning and adaptation. So these plans are kind of the brainchild of where that's come from. But as we think of the entirety of the tech stack and how Python comes to life, GitHub Copilot has been a major driver factor of that as well. We like to think of GitHub Copilot as an AI-paired programmer. That's also kind of where the Copilot name came from. So really marrying those two ideas together. But more importantly, GitHub Copilot helps you write code faster by suggesting different code snippets and functions as you type, hopefully reducing errors through coding by providing more accurate syntax and helping along with best practices as you bring your different apps to life. And then lastly, really GitHub Copilot being able to help you learn on the go. So exposing you to different libraries, code samples, and coding patterns, the integration of GitHub Copilot into your workflow ultimately would help you focus more on solving these more complex problems versus the more routine coding tasks. So with all of this, our team, Azure Skilling, have really taken it upon to try to make a deeper investment in when we think about these learning plans, how we want to enhance the learning experience. So hopefully in 2025, there will be some new things live that will be more interactive, more keeping up with the different technologies that are coming out, And lastly, really trying to bring that technical depth to a lot of what we do. And you'll see here briefly kind of go over this, and these links will also be provided, but GitHub Copilot plan is going to have the interactive modules that I had mentioned, as well as a lot of different articles and additional videos that my team has spent the time curating and helping just understand the technology as well as the integration into Azure. I think that's a big piece that sometimes you don't hear about when we think of different services and tools and how they all come together to help build on Azure. But really that integrated toolkit between Python, GitHub Copilot will help accelerate the incredible work and the awesome different application solutions that can be built on Azure. So with that, these are the two plans I wanted to bring today. Thank you so much for joining me on this short but fun journey exploring how Python, GitHub Copilot, and Microsoft Plans all come together to help you build intelligent applications, as well as offer a hub of resources to help you learn on any and all of these different technologies together. So I encourage you to check these out at your convenience, and that I'll hand it back to Don.
Dawn, you've suffered the suffering of our current world.
I said such a wonderful and authentic thank you, and you missed it, but I'll say it again. Thank you so much. One of the things I really love, actually, and it might have been planned or just serendipitous, but I actually really love seeing the page that I'm going to navigate to, that you're sending me to. So the fact that we actually saw the plans in front of us, people know what they're going to get into. I appreciate you, and I always really appreciate joining in and learning more from the Microsoft Learn team. Your coworkers are lovely. You're lovely.
And the content is so important. I remember around the time I was in advocacy for a while, and I wanted to be able to have some of the same skills that our developers and users had. So I wanted to pass AZ 900. So what did I do? I went to Learn. I took all the AZ 900 Learn content, and look at me now. I got my AZ 900s.
Absolutely. Well, thank you again so much, Jay and Don.
Bye.
Great having you. Thank you so much. Well, Dawn, that was a great way to kick things off. And I know we got a lot more fun stuff coming up. Very, very interesting. And I'm going to let you introduce our next speaker.
Oh, I get to do the honors. That's fantastic. It's cool. One of my favorite people on the planet. They've been a repeat guest on the Python Pulse. You can find the Python Pulse. I don't even know if we have a link for it, but I just throw it up there, aka.ms/python-pulse-playlist. We'll put it up on the thing later. That wasn't really fair for me and our producer. I just am so excited to talk to Dr. Sarah Kaiser, who is going to be giving us more info on dev containers and code spaces and optimizing your development environment to do really cool things.
Hey, everybody.
Hey,
great to see you. I feel like I have to join the, you've got like the Batman thing going on. I've got my holiday Christmas sweater or holiday festive sweter. I love collecting these. And
I'm always festive. That's just how I live my life.
But yeah, I never have very many opportunities to wear them. So I am super excited that I had a good reason today.
Today's the day. What we're going to do upon Sarah's request is if you have questions, put them in the chat and we'll be bringing them up as Sarah is talking. And that means that Sarah's going to go to the 30-minute mark. And so I'll put a little banner at the bottom of the screen so we don't mess up the recording as well when we're getting close to the end of the 30-minute mark as well. All right. So we'll get out of your way.
Awesome. Can everybody see my screen? If you could,
you're all good.
Is that yes? I'm gonna assume so. Anyway, so yeah, I am really excited to talk about one of my favorite things today, which is dev containers and code spaces, and kind of share some of the ways, since we're going to be seeing all kinds of really cool demos for all kinds of different projects for deploying on Azure. Just a really nice tool you can kind of have in your back pocket to help you both do the development process, learn new projects, and just kind of make your life as a developer easier. So to kind of introduce myself, I am a developer advocate here at Microsoft, specifically for kind of scientific Python sorts of things. I've been a Pythonista for like 15 or so years, and initially learned Python because I wanted to be lazy and not be in my lab when I was trying to run my physics experiments. So I have Python has been my best friend and development buddy for a long time. When I am not working on Python stuff, though, I do hang out a lot with my dog and play here in Seattle, and like playing Final Fantasy things. So let me know if you play Final Fantasy 14. But one of my kind of, when I am working with somebody on a new project, or I'm approaching a new maybe open source project, like kind of the worst feeling in the world is you start working on the project and you can't stand something up. Like the worst thing I hear or say myself is, it doesn't work on my machine. Put in chat, what is your least favorite thing to hear? Maybe the internet is down. But mine is, it doesn't work on my machine. And that's just like a really like frustrating, but like also generally solvable sort of friction when you're trying to work on different projects. So I'm going to show you today what dev containers are, what Codespaces is, and how you can kind of use both of these tools together to hopefully alleviate these situations where you're trying to stand up a project or you're trying to deploy something and just the environment variables aren't working or whatever, and you just can't get it. You're frustrated and you want to go get some coffee or something. So yeah, as Dawn mentioned, questions are great, and if you just put them in chat, and Dawn will help kind of manage that. And if you have further questions, I'm on Discord all the time, so please feel free to put questions there or on Mastodon. So I've said a lot of things about dev containers. We've mentioned it. Dawn even showed you some cool stuff in the intro. But what are they? So containers are generally a concept that is kind of permeated a lot of development. Often we think of them as like Docker containers, and they're ways of separating kind of and describing where and how our code runs. So those are great. But a lot of times as a developer, that isn't isn't necessarily the full picture, because you might have, how your application runs, but then there's all of the tooling for doing the deployment or doing the security authentication. Even how does your IDE or your editor interact with not working in your local machine, but working in a container? So there is still kind of a lot of things that aren't captured in just like having a Docker container. Don't get me wrong, that's a very good place to start. But dev containers are basically kind of a yes and. It takes the concept of a container for your code in the form of a Docker container and extends that to kind of include a description of how do I need to set up everything that interacts with my container. So the development container, often shortened to dev containers. So this is actually an open source spec that was originally kind of developed in collaboration with some of the VS Code team and GitHub folks. It's been open sourced and is open spec that you can participate in, check out all the repos, file feedback and stuff on the actual spec. And you can find all that at containers.dev. But kind of to give you a flavor of like what do we mean when we say other things in addition to the code container? It's things like, since it did originally kind of spin out of the VS Code project, you know, one thing, it's like all the settings for your VS Code. So maybe you have some extensions that really work well for your project that you want to have set up. Maybe you have you know, everything from color themes to setting up environment variables or choosing Python interpreters, setting up that as default. All of those can be set and supported with VS Code. But the cool thing is, because this is an open spec, this has kind of been of interest to a lot of other sorts of developer tools. So there is kind of initial support for dev containers in JetBrains products, in PyCharm. There is a bunch of kind of DevPod, DevBox sorts of companies that will like run development environments in the cloud for you that are also adopting this spec. So it really kind of starts, you know, I work with a lot of folks. I use VS Code. It's my favorite IDE. I've been using it for a long time. But you know, I work with folks who PyCharm is their favorite place to be, and so it's really, you know, there can be friction between, you know, like how I have my IDE set up. I'm working with somebody who's using a different IDE, and maybe our extensions don't like interact with things the same way. Maybe they keep making Git commit conflicts, line endings, things like that. But now, if I am able to configure a dev container, that configuration can apply to both places. So we can have the same experience with our project, contributing and developing and deploying, no matter kind of what our preference for where we develop is. So as I kind of mentioned, the big local editor sort of experience is mainly in VS Code and kind of in progress with JetBrains, but you can use them locally. So if I have Docker on my machine, I can basically install the dev containers extension in VS Code. And if my project has one of these dev container configs, which I'll show you how relatively simple they can be, you know, I can work locally, and my whole project is, you know, nicely isolated with all the benefits that Docker generally provides, or the, you know, kind of concept of containerization provides. But if I'm working with somebody that also has Docker on their machine, I know that, and VS Code, I know that they can have the same experience without having to play, well, what extensions do you have installed, or how does this work? But if, say, my laptop isn't happy with me today or something, and I'm just having a lot of trouble running things locally, I can do things in code spaces. So we'll talk a bit about this service, but it's a GitHub hosted version of a container VS Code editor, so that all you need is a browser to be working on your projects. And pretty much I do almost, I would say most of my development now is actually in code spaces, because I can have then different machines I'm working on that have different hardware than even my laptop. And as I showed with the logos on the previous slide, other cloud hosting services like DevPod, DevBox sorts of things also can interpret these configuration files, the dev container files. And if it's a setting or something that is relevant for those platforms, they can interpret it. So just to kind of give you an idea of what do I mean when I say a dev container file.
Quick question, Sarah,
Oh
from
yeah,
from the chat.
definitely.
How can VS Code profiles be downloaded? I saw the Python profile in one of the URLs above.
Oh yeah. So there's I think the way that profile is shared from the website, VS, I think you can render it actually in the browser as a preview. So if you click the link, it actually pulls up like a VS Code window in a browser tab. That's a preview of what that profile has installed in it, the color themes, all kinds of stuff. And then there should be the panel that shows up on the left should give you the option to like check everything, check all, and then add to my VS Code. There should be a button in a panel on the left. If there isn't, we can I can try and troubleshoot that at the end. But yeah, profiles are also, I have a bit about it at the end, but profiles are also a good way to kind of address having people have the same sort of setup for a project. But that mainly only works if you're all working in VS Code, which does work in most cases. And that is also something that I really like using myself, because then I can have my presentation mode for VS Code. I can have my web development mode for VS Code, things like that. Hopefully that answers the question. If not, please write back.
I think so. That was solid.
Cool. Yeah, I really like the preview that it shows you beforehand, so you're not just like randomly downloading a thing and then opening once it's on your machine, already opening it and then like, well, I guess I didn't like that. Anyway, so coming back to our dev container config files, but they're just JSON files. So at a bare minimum, all it adds to your project, if, as you probably reasonably could be as a maintainer, is this a lot of things to maintain, to add? I mean, we're all familiar with another config file, but this one's JSON, so it can be relatively simple. There's three main parts to it. There is the image part, which basically describes the Docker piece of our dev container. You can specify a Docker file. You can specify either via having a Docker file in your repo, or you can just point to, there's all kinds of actually also dev container templates, which point to pre-built Docker images for, say, like Python development or Go development, things like that. So you can kind of start with templates. You can have your own Docker file, or you can even have a Docker Compose file. So there's some really great examples across some of the Azure samples and docs on Microsoft Learn that have pretty complicated, multi-part, service Azure deployments that you can actually spin up locally, with a Postgres server, with different front ends and sorts of things, all with that Docker Compose, all either locally or deploying to Azure from this dev container. The second main part of dev container files are features. So those are kind of like an easy way if you need to add something on to your Docker file or what describes where your code runs. This is very helpful if you're starting with like a template. So like sometimes I do Python and Rust development. So I might start with a Python like default template for my dev container, and then I'll add on the Rust SDK as a feature. So that's literally just kind of one line. There's a great community. All these features are basically contributed to the containers.dev project. You can look at all of the source, but they're basically also little Docker files that build a piece and then add on. So it's great if you need to, like, say, add the Azure CLI to your project. You just add a line, and then when you spin up your dev container, it has the Azure CLI set up, or AZD, or whatever other tooling you need. Sometimes this can slow down your launch build times, but I mean, you would have to, if you needed it, you would have to install it anyway, and you can mitigate some of the slowdown by doing pre-builds for stuff. So we'll talk about that later. And the last piece of dev container files are the kind of settings component. So these are keyed to the different platforms. So like you can have a VS Code settings section, you can have a or like a PyCharm settings section, you can have a DevPod settings section. So if there's things that, the different editors, like features that they have or components that they have that you need to set up, you can configure it all that way. So yeah, I have an example here of one of our templates for, so if you wanted to set up a dev container, my kind of default install of choice is Miniconda, since I'm often doing kind of scientific-y sorts of things. So this is my Docker file. It's only technically 4 lines, split out a little bit for readability, but I'm starting from a pre-built dev containers community image from Anaconda. Then I'm adding Mamba to speed up some of my package resolutions and having it look to see if I have my environment file in this, and see if I have an environment file in my project and install it. So, if you have, it's pretty easy to add to existing projects, especially if you do have a container, or have some sort of Docker setup. Maybe you have that for your CI or something like that. You can just point to that file. You don't have to necessarily modify it. But honestly, the templates are great. And there's a great kind of selection exploration. If you have the remote development extension pack installed for Visual Studio Code, it can basically walk you through everything that is in the containers.dev project in your command palette, and it's honestly a pretty nice experience, and it just writes the JSON for you. So you get something ready to go out of the box in probably like 10 seconds. So now that you kind of have an idea a little bit of what a dev container is, let's talk about how we might use them, or kind of in like kind of a active scenario. So I want to work on developing and deploying something to Azure. And it can be managing contributions. I work a lot on open source projects. So, if I even just want to like add a small contribution to something, I would probably have to clone the project, build it, set everything up locally, and try to make sure all tests pass, stuff like that. Usually, I mean, that can be a huge friction point for projects to get contributors. So what I tend to do now, and if you like contributing to open source, a great option you might like to try is actually setting up a dev container when you're, say, working on a bug or something like that. So, here's an example of an issue I wrote for a project where I just, I was trying to run their sample app. It wasn't really working. And I was able to basically make a dev container so that someone else could repro the issue that I was having. We didn't have to play the game of like, can you put the details of your machine, or, what version is this? What version is this? Nope, I've given you the pretty much a complete description of how to reproduce. So all of this works especially well because of GitHub code spaces. So this is a very fast way to host dev containers in the cloud, and pretty much all GitHub accounts get some free allotment. I think it's around 60 hours right now of compute. So you can, whether if you're walking up to a project and you want to start contributing, you can spin up the project in code spaces. So I'll show you an example here in just a second, but it's literally just kind of an option when you go to code and getting the setup for your project. But you can use it wherever. Sometimes I have trouble with having too many browser tabs open on my laptop. I don't have enough RAM to run a lot of things with Docker. So I just use a big GPU machine to actually run my code space. And then I can do a lot of like Olama stuff or machine learning sorts of things without like locking up my laptop in the airport. So yeah, here's an example. Like I can choose the size of my machine. You can also choose now even GPU options. But there's also, if your project does have a dev container already committed, you can, if you are going through in your maintainer and you're doing reviews, you can actually just directly from the PR open a code space that has all of the changes on that PR checked out and up to date. So that has been a huge time saver too, because if somebody tags me for review on something, I'm there in basically one click. So that's enough talking about it. Let's actually do it. I am going to look at one of our more popular Azure samples right now for setting up a AI RAG chat chat bot experience. So if you go to aka.ms/ragchat, I happen to have it open here. So this is the repo. It's Azure Search OpenAI. So there's a bunch of different kind of AI Azure components that are combined here. It kind of looks like, you can see it gives you an interface like this. But if you wanted to work on developing this, and I wanted to deploy it, AZD is a great tool, and we have an AZD template set up for this project. So you could deploy it with AZD, but maybe I can't get this working locally on my machine. I would go here, and you can see I have, this would be kind of what you would normally be used to on GitHub. But if you go to the code spaces option here, oh no, 1 second, I gotta get the lights back on. I did not move enough.
We all like a little spooky once in a while.
Halloween was like too many weeks ago. Goodness. Okay.
Yeah, that would have been perfect on Halloween, but unfortunately we're all past. So, but please continue.
Yes, we're back. Sorry about that. So yeah, I can either just straight up hit the plus here and start my code space, or I can click the triple dots here and actually configure the options. Oops, not configure the options. I meant to click the one above it. New with options. So here, maybe I want to start working on a different branch to start with. You can have multiple dev container configurations per project. So what is really helpful in this sort of scenario is if you have someone just wants to drive by and try out your project, or just wants to have the quick usable sort of setup, you can have a dev container for that. But you can also have a dev container, say you have this big database sort of combo application, and you have a bunch of additional tooling you need if you're doing dev. You can have a different dev container for that contributor or developer sort of experience for the project. I can choose the region I deploy, and I can choose a bunch of different size options here. So to make sure this goes quickly, I will choose the GPU one. It's not necessary, but I want to make sure demos go quickly. So you can see here, now I have this window that looks like VS Code, but I'm actually just in my browser tab. So this is the same, Jay was mentioning earlier, if you go to any GitHub repo and hit the period key, then you get the same sort of web VS Code sort of experience. But I can watch, it's currently trying to connect to and build my code space. So we'll give it a minute, but so we'll come back to the slides. Oops, come back to the slides. But yeah, so if I am working on setting up a new project or wanting to deploy it, I can have all my deploy scripts. I can have all of the authentication and things set up in this dev container, so that I can just share that and hopefully make it easier for people to work with me and contribute to my projects. So you may also want to kind of get spun up on a new project. There's so many of these new cool AI samples that a lot of the folks on my team are working on, that, I feel like every week I need to read a digest or have a live stream to see all the new stuff. So I want to get spun up on something quickly, and I can go to, well, we just saw the icons when I deployed that one. You saw it said pre-build ready. So this is something that you can do on code spaces with your dev containers. You can have all of the Docker steps, everything kind of happen preemptively. You can change the triggers for when it happens. You could do it on a schedule. You could do it only when certain configurations change. But then it's really kind of the time limit or how long it takes to spin something up is basically just network bandwidth. So downloading the pieces of the image that you need to spin up. It can, as the slide notes here, can potentially add cost just because now you're storing a bunch of effectively images for machines that you've built. But honestly, it's there's a lot of nice tools and kind of the admin panels for your projects on GitHub, so you can kind of manage that and be in control. So this was actually something we set up for one of my favorite Python projects, NumPy. I worked with the maintainers on NumPy to set up, because they did a lot of sprints where they were trying to scale up a lot of people on their projects. You know, they're really big about encouraging new contributors. And so like with a lot of things, if somebody gets stuck installing or setting up or whatever, it's a really easy way for people to kind of lose interest or get lost. So being able to share for their sprints or any of their like kind of community events a URL to a code space that people can just, as long as they have internet and a browser, they can actually get started contributing. And it just really has lowered a lot of kind of barriers to learning and entry for folks trying to learn and deploy things. So you can also, if you go to github.com/codespaces, that's kind of your main portal page where you can see all of the code spaces that you've spun up or are using. You also don't have to have a project or a repo tied to them. So maybe you're just like, I have this idea for something, I really want to get started, or you have a friend who's like, I want to start learning Python. I don't have Python installed. I signed up for GitHub though, and so you can then have somebody just spin up a Jupyter notebook or Jupyter lab, because the other thing with code spaces is you don't necessarily have to use a VS Code interface. You can actually use, if you, as a Pythonista, prefer Jupyter notebooks, you can have a Jupyter lab interface, which I think is really awesome. And somebody had asked about profiles earlier. This was my bonus tip, but profiles are an amazing feature in VS Code that, if short of dev containers, you want to have easy ways to share how you've set up your VS Code for a project. You click on the gear down here, and then you'll see profiles, and you can choose different, like I have ones for presenting where all the font sizes are made bigger and things like that. So yeah, I think we're pretty close to the end. I'm just gonna check back on our.
You're fantastic on time. Like, we're right hitting exactly the end.
I'm gonna go back and try. I have one that I actually already created, so I think I'm just having network fun times. We can see cuddly orbit is. You can see if you create a bunch of different ones already. It should just stand up here. Please. Okay, we'll check it out one more time. But yeah, long story short, dev containers are a really neat extension of what we normally think of as containers for code, that include a lot of the infrastructure development, developer tooling, things around your actual code, which really makes it easier to contribute to new projects, learn new projects by just removing that kind of initial barrier of getting the project working. Then you get to do the fun part, which is you start breaking things. Yeah, so I would encourage you, if you have not, whenever you're looking at our samples on Learn and whatnot, a lot of them do have dev containers. If they don't, maybe try contributing one or add them to your favorite project. So yeah.
Awesome. Thanks so much, Sarah. And we had a couple more questions coming in at the end about live share and things like that, but we're low on time. So will you be hanging out in the YouTube chat, or should people reach out to you on Discord, or both? I don't know.
I'll try to answer the questions in YouTube chat real quick as soon as I'm
awesome. We have some questions on live share.
Thanks everybody. Sarah. Have fun deploying stuff on Azure.
Well, that was great. And we've got so many more to come to everybody. But want to remind you all, if you're watching, let us know where you're watching from. If you have questions, drop them in the chat. We'd love to hear from you. And if you'd like to see, there's a ton of information about today right down there. You can find the Python Developer Hub, and since I'm the Cosmos DB person, you can also find the samples gallery there. But we've got another speaker, and I'm going to hand it off to you.
Yeah, we're going to be speaking with Darhas Parthena, who is the CTO of Quantsite. We met at through conference networking, things like that. And I'm so glad we did. The impact of Quantsite is huge. But we're jumping into what you have shown us for today. Will you be sharing some slides? Oh, and you're on mute. I did that just a moment ago.
Yes, I have some slides to share. I can present.
Awesome. If you want to hit that present button at the bottom, and then I'll throw it up on screen.
And while we're waiting, just want to remind you all, you can join on Discord at akams/python-discord and keep the conversation, talk with other people here after the show. Anyway, have a great talk.
Out the way.
Okay. Thank you for the invitation to speak here. My name is Darhas Parthena. I'm the CTO at Quantsite. Quantsite is a company that has a mission to support the Python open source ecosystem. So we actually hire a lot of the maintainers and contributors to a lot of the tools you guys use, like Jupyter and NumPy and Pandas, and etc. Today, I'm going to talk about Jupyter and getting Jupyter installed on Azure. And first of all, why would you even want to do that? Before that, I'm going to kind of give a slight detour. So I've been in Python open source since about 2008, and I had to use Python before the cloud existed. I've been in research for a long time and then in the industry for about 6 years, and I love building tools that let people get work done. And today's talk is basically about that. How do you get stuff to the point where people can get stuff done? So you want to use Jupyter. We've talked about Jupyter. Jupyter's basically the primary IDE for research and data science and AI. If you want to do real coding, switch to VS Code. But when you're kind of experimenting, you want to use Jupyter. There's actually lots of great ways to use Jupyter in the cloud. In Azure, I did a quick Google. You've got Codespaces, which you just heard a lot about. You've got Azure Data Studio, ML Studio. There's lots of SaaS vendors like Saturn Cloud, Data Layer, Coil, Databricks, Domino Data Lab. These all give you sort of one-click Jupyter notebook access in the cloud. Or you can install everything yourself. And today we're going to talk about the last one, roll your own. Let's install Jupyter, and specifically Jupyter Hub. And let's talk a little bit about that. Why would an organization want to roll their own Jupyter platform? These are some of the things we've heard. Quantsite's a consulting company, so we go to a lot of places, and sometimes they don't want vendor lock-in. Sometimes the various platforms out there were built by different organizations, and they don't align well with what the organization needs. They want to integrate it with other tools inside, or there's security or privacy concerns, and a lot of times it's also cost. Some of these platforms are pretty expensive, above your basic cloud costs. If you want to roll your own, we're going to go into some of the issues with that. Why did we, Quantsite, start building the tools we've built? We went into clients who needed us to solve hard problems in machine learning or build new algorithms or analyze their data. And every time we went in, they didn't have a good way to handle Python, or they didn't have scalable compute. They couldn't do really big data sets. They're like, oh, here's all the data. We don't have a place for you to do any analytics. And this was like 3-4 years ago, and some of the cloud tools weren't as mature as they were today. So essentially, we needed Jupyter and scalable tools like Dask and Ray in the cloud, and we didn't have them. So let's do this. Jupyter Hub is a really good open source framework that lets you deploy a collaborative Jupyter environment actually on many platforms. It can be installed on an HPC system or on Kubernetes. It's designed to be very flexible and installed in many locations. And it's got instructions on how to install it on Azure. And it's really good. It's like quite a lot of information. It kind of assumes you know about Kubernetes and how to set up all your bits. But it's excellent. If you're a good DevOps person, you should be able to go in there and work your way through the instructions. But once you install it, then you're like, oh, we actually need to manage our Python environments, like you were talking about previously in Codespaces. How do you manage all your things? People want better collaboration tools. They want monitoring and login, single sign-on, access controls, MLOps tooling, workflow tooling, and suddenly you're not just deploying Jupyter Hub, you're deploying a whole set of tools, and you're making choices. Should I use MLflow or should I use something else? Should I use Argo or should I use Prefect? You get into this paralysis of, okay, which ones do I deploy and how do I integrate everything together and how do I make everything work together? Very soon, I'm going to go into this detour. I'll give you guys a few seconds to guess what this is. Okay, this is the high-level dependencies of PyTorch, okay? And this is how many other libraries PyTorch depends on. This is actually not going all the way to the bottom. And this is just one library in the machine learning AI stack. Most organizational IT departments are not equipped to handle rapidly changing Python environments. The solution, which most organizations come with, is like, let's use containers. And that's not the full solution because it ignores a whole bunch of stuff and it causes roadblocks in the organization. What we've seen is most platforms that are container-based, the containers don't change often. They assume that the containers are going to be fairly static. But most of the researchers and data scientists and engineers actually trying to solve problems in organizations, they update their Python environments often multiple times a day. And that process of an end user data scientist who needs stuff deployed and getting it into the platform has a lot of friction. In some organizations, it's 6 months, or more to get the latest version of Pandas, the latest version of PyTorch. One large bank, which I will not name, it took them a year to change the Pandas version in their container. And so we started hitting these issues as well. And so you start thinking about deploying this. You're no longer deploying Jupyter or Jupyter Hub. You're deploying a full data science platform, and it is overwhelming. Smaller organizations just throw their hands up and say this is way too complicated. Larger organizations, their IT departments are typically more used to deploying Oracle, deploying the stable, unchanging thing. And they sort of get overwhelmed by all the different pieces that have to kind of go together. So I came from government research labs where we had access to big HPC systems, and I could use a lot of compute. When I moved to the industry, I got really annoyed about how difficult it was to deploy everything I needed in the cloud. The inspiration for some of the work I'm talking about today is something that was done at the beginning of AWS, which was Star Cluster, and it was developed at MIT. And basically, you added some environment variables, credentials, and you said Star Cluster, start my cluster. And it would deal with setting, launching an EC2 instance and all that, and it would drop you into a Linux desktop with all your tools installed. And you didn't need to know how to use the cloud, but you could take advantage of it. That's sort of the inspiration of what we started building. We started building an open source platform called Nabari. And the way to think of Nabari is it is an opinionated distribution of Jupyter Hub. It takes all the pieces you need to have a data science platform. We've made choices for you. We made, okay, this is a pretty good, MLflow is really good. Let's just use MLflow. So it's got a bunch of opinions baked into it, but it's also just a reference architecture and it's plugin based. So you can kind of, you use whatever pieces you want, but if you don't have any opinions, we'll give you something out the box that works pretty good. It can be deployed on Azure in about 30 minutes. I thought about doing a live thing, but it was a bit too risky, so I'm not going to do that. It's infrastructure as code, and it's tested on, we test it on Azure weekly. So we have automated CI that tests deployments on Azure weekly, because things change in the cloud, and stuff that worked a while back may not necessarily work because changes in Kubernetes versions and all that kind of stuff. So that's why the testing part is very important. It's all built out of open source components and frameworks, and basically you could build this yourself from root principles, but it would take you a while to get all the integrations working. Who uses it? We have a lot of small organizations who don't really have cloud or Kubernetes knowledge. They can install it and use it and maintain it without a problem. And we also have the enterprise folks who are, have a large Kubernetes team and, know how to use Azure all the way, but they're not familiar with the data science tools and the Python tooling. And so those are the two groups that typically use it. We've had a lot of universities use it for teaching as well. And I'm going to go into a quick demo to kind of motivate you into some of the things we give you. So this is a live instance of Nabari. I'm going to just start Jupyter Hub and Jupyter Lab, and then you've got different instance types. You've got your let me make this a bit bigger actually. We've got like GPU instances, A100s. I'm just going to spin up a small instance right now, just because some of the larger instances take a few minutes. This is going to start up a Jupyter server on this instance type, and in a few seconds, I should get my Jupyter. Okay, and so this lands me into kind of the Jupyter window we're all sort of familiar with. And let me go back here. And we just do some niceties. We integrate various plugins like Jupyter AI and Dask and other things that will make life easier for people. We implement shared folders that based on which access groups you're in, you'll have access to, like, I'm in the analyst group, so I have access to an analyst shared folder. Then we do we can start notebooks, we can start a terminal, we can start a code server instance, we can download examples. And these are all the different software environments I have in the system. And that actually becomes a large part of this, because most people, when they set up a Jupyter Hub system, deploying a new software environment involves creating a new container, pushing it to a registry, and then adding it to the system. What we've done is we've built a environment management solution, which lets you have your own personal environments. I have an environment for AI work, and these environments also are versioned. Like if I look down here, if I look at this environment, this one has versions which I can go back and forward on. And up here are my personal environments, which I can access. But down here, you can have environments that are controlled by someone else. Like, so if you're a department lead, maybe you can create an environment and share it with your group, but people using the environment won't be able to change it. And if I want to create a new environment, I just click new, gives me an interface to add packages. And when I do create packages, it automatically stores all the artifacts, a Docker image, downloadable archive, a log file. So it forces reproducibility and best practices behind the scenes, even though you're not thinking about it as an end user. Then some other things which are nice, if we have a notebook, let me just pick a notebook. So if I pick some random notebook, like this Dask stress test or something, I can kind of click a create job, and I can either run it now or on a schedule, and then hit create. It'll create a job, schedule it on Argo workflows, and give me the results back to my folder. So a lot of little conveniences that a data scientist would actually use, and then a lot of collaboration tools integrated as well. So if I go back to the main window, these are dashboards that my colleague has shared with me. So if I click on this, my colleague Pavitra has shared this climatology dashboard with me. And so you can make a dashboard with Streamlit or Panel or any of the other tools like Plotly or anything. And then you can click Deploy App, and you can kind of give the name, select which framework you're using, like Bokeh, Streamlit, stuff like that. Add environment variables, decide who you want to give access to, whether you want to give access to a group or an individual person, whether it should be available for people in the public or private to your organization. And once you do all that, you can share it as this. So that's a really quick demo. There's lots of other features in Nabari that I'm not going to go into right now, but I'm going to, hopefully that's kind of showing you why you might want to use this. But with that, I'm going to kind of keep going. Now you've seen that, how do you actually get it installed? This is a high-level architecture diagram showing you all the stuff that needs to be deployed on Azure to get it working. I'm not going to go into this. There's auto scaling, there's all the different tools, but at a high level, Nabari has this idea of a DevOps or non-DevOps approach. So this is kind of the same idea I talked about Star Cluster. Hopefully, if we've done our job, you should be able to grab your Azure credentials and not really know anything much more about the cloud and deploy this and maintain this, okay? And so we start off with a YAML configuration file. We use that to create some Terraform stages. We kind of plug along, and then it deploys your platform. At a high level, we have these commands in the system. We have a Nabari init that will create your basic YAML file. And then we do a Nabari deploy that takes that YAML, validates it, renders it into Terraform deployment scripts, and then pushes everything to Azure. Now, going through some of the details, we're first going to set up the service principal, and so we'll create an app, and then we'll create a secret for the app, and then we'll grant that service principal permissions to manage resources on your Azure subscription. This is what you'll do in Azure, and then locally you'll install Nabari on your laptop. You do pip install, conda install, prefix, a pixie install, whatever you need. Just install it's a pure Python package, and it'll install. Then little bit of local setup, you just make a folder, and then we usually tell people to run the guided init, and this is a small wizard that runs on the command line that asks you a bunch of questions. And essentially, we'll run the guided init. It'll ask you whether, where you're deploying. It'll ask for some of the secrets and environment variables, which zone you want to deploy in, what the project name is, a few other questions. And then at the end of that, it's going to spit out a config file. And this config file is based on some default instance sizes and things that we've built and you might want to go in and modify which instance sizes, what the min-max node numbers are for each node group and things like that. There's also some extra work if you're including GPU nodes or other things. We can also, in the guided init, it'll ask you whether you want certain services deployed. Do you want MLflow deployed or not? Or do you want, so you can kind of pick and choose what you want. Eventually, you'll end up with a configuration file. And then it's actually, that's it. You hit Nabari deploy with that configuration file, and you wait 30 minutes, and you see lots of messages stream past. And with that, you should have a fully functional data science platform, which your organization can use in the cloud. And we usually put the config in GitHub or GitLab, and then the way we maintain the system is we just do pull requests on that Git repo, and then when you do the pull request on the Git repo, it automatically redeploys via Terraform using either GitHub Actions or if you're using GitLab runners. So the whole point of it is it's not about just you got a defined configuration that you can easily deploy with one command, and then maintaining that is maintaining one YAML file. And so we're trying to reduce both the initial deployment cost and the long-term maintenance cost of the platform by making it as simple as we can. And hopefully you shouldn't need to know anything about Kubernetes. So some specific things we had to do for Azure. Again, so essentially we can deploy on any Kubernetes, but for Azure, some specific things we had to do is we hit, each cloud has its issues, and we hit a couple of things. One is storage account names have to be globally unique. And people typically, when they deploy the platform, they call the project Nabari, and then that conflicts with other things which are called Nabari because of this globally unique thing. So we actually just add a little random postfix to the names to avoid that conflict. The other thing which was very useful is we actually use Azure Workflow Identity to relate the Kubernetes service accounts to the managed identity. And this lets us inject credentials easily. So something like for example, MLflow needs to know how to access blob storage. And so this gives us a way to do that. So those are couple of things. Over time, we've got lots of bug fixes and security things and everything else that we've worked into the code base for Azure specifically. And that's one of the reasons we keep testing weekly, because we keep finding these things, get the security scans, fix the Docker images, all that kind of stuff. You can try this yourself. If you go to the website, we have a how-to for Azure, and you should be able to, hopefully just copy your credentials, sign up for Azure, follow the steps here, and you should be able to deploy Nabari. And if you can't, let us know in GitHub, and we'll fix the documentation, because the point is you shouldn't be a cloud developer to be able to deploy this. And with that, I think I'll close and take any questions if there are any. I think you're on mute, Dawn.
I know I have some questions, but I'll leave it to the chat first before I jump into my own. We got a lot of comments about scalability, the simplicity. I enjoy not having to know anything about Kubernetes, music to my ears. And we also got a message, a note, one of the core developers, Adam Lewis. We've developed other open source tools while working on Nabari, Conda Store for managing Python environments across teams, and JHub apps for sharing dashboards.
Yeah,
Awesome.
So I'll go through a couple of those things. While we were building this, we started realizing problems with Jupyter Lab, and other things that didn't work well in a collaborative setting. And so that's why some of these other tools, like Conda Store was a new tool we built, because managing environments in the cloud and managing environments, most tools for environment management are focused on a single developer. Mm-hmm. And we realized that you need to actually go above that and work out how are you going to manage environments across an organization, which means we need namespaces. Some environments have to be not editable. Other environments have to, allow people to quickly manage them. And we need to be able to capture everything in a reproducible manner. We realized that we gave the ability to people to create hundreds of environments across an organization, or even thousands. And most of the platforms are only used to handling one or two. And so Jupyter Lab assumes you only have one environment. So we actually had to build this new interface. This is not the same as the regular Jupyter interface, where it lets you launch notebooks. If I click notebook, it actually, let me go here. It actually gives me this new thing that lets me search through environments. So if I can look for my environments, you can see these, or if I can look for admin environments, I can see, So there's a whole new interface on how to manage environments for Jupyter, because Jupyter was never designed to manage hundreds of environments. And then we use this for the SciPy tutorials this year. And so for SciPy, we needed a way for people to easily download tutorials and examples and things like that. So we built this new Jupyter extension. So there's a lot of open source extensions for Jupyter and for environment management, which have come out of this Nabari work. they're part of Nebari, but they're also independent tools that you can use in your existing Jupyter Labs or your existing Jupyter Hubs. So part of the ethos of Nebari is sort of like, this is a distribution of open source tools, but you can pick the individual tools and mix and match them yourself.
I love the flexibility. And we do have an energy of a big tent here of just kind of loving open source, understanding there's competitors in the space, but really loving that our users also appreciate flexibility. So I love that you've been able to take the time to speak with us today and share some of that. Let's see, more questions. And we're almost on time. We probably have a question for one more.
Yeah, if anybody in the chat has a question, let's drop it in ASAP. But we're just about out of questions at this point. But I did want to say, you know, the open source community provides us with so much. So thank you. Thank you. That's the best and most simple way I can put it. Thank you.
We did have a number of us at SciPy last year as well. So hopefully you all crossed paths.
Yep, we'll be at SciPy and PyCon this year. So.
Yeah. Oh yeah, Microsoft will be at PyCon too. I was supposed to mention that. So I hope everyone watching will join us, and I'll see you there, Darheads.
Thank you.
Go there to find out more about it. PyCon 2025. I know you all always put together so much great stuff to share. But speaking of, Dawn, I know that you have to take a break for a little while, and you're going to have me, your host, for a bit. While I will not say that I am the Python expert Dawn is, I still am here to make sure you all have a great time. So we've got someone really, really wonderful that's going to come up next. So we're going to talk a little bit about LangChain and Azure SQL, and to join us, we have David Mori. Did I pronounce that right?
That's fine. Thanks a lot for having me, Jay.
I try. Well, it's great having you. It's really wonderful to bring in people. I know you're a principal program manager here, and you've got a lot to talk about. LangChain is such a huge part nowadays of building AI apps.
That's right.
I'm going to go ahead and I'm going to bring up your screen.
Yeah, perfect.
And then I want to give you the opportunity to share with everybody. So I'm just going to back out. Remember, everybody, if you have questions, we would love to hear from you. Drop them in the chat. We'll do it we'll do it at the end of the session, but I will want to hear from you all as we go. So with that said, go ahead and take it off and do what you got to do.
Yeah, thank you. And actually, I joined 5 or 10 minutes ago, and I heard that, as expected, you all love open source. So the entire presentation here is open source. The website that has been shared right now, AzureSQL.dev, is a little project I've been working on lately. And if you go on Azure SQL Loves Python, you basically have the presentation. And that's what I will be using today. First, I will kind of give you a little bit of introduction to Azure SQL and why I think it's so cool to use it with Python, and I want you to know that there are a couple of interesting features, also price-wise, that you probably want to know, and then we'll move into LangChain and Chainlit and all the cool stuff that you can build with Azure SQL and Python together. So let's get started. Again, AzureSQL.dev if you want to follow me on the presentation. And so first of all, I just want to make sure that everyone here knows that there is a free version of Azure SQL. You don't have to spend any money to start using Azure SQL. Everything I'm going to show today is something you can use for free, both in the cloud, if you prefer to just use the latest and greatest version, or even on premises. Because even on premises, there is a free version that we call the SQL Server Developer Edition. It's absolutely free. This is actually something I will be using today right now. It happens right now I'm using a Windows machine, but I also use a lot of Mac and Linux. Actually, I use WSL a lot. And everything works fine there, even if I'm using SQL Server. Because, for example, you can use, and I will be doing that in my demos, a SQL Server running in a Linux container in a Ubuntu installation on your Macintosh if you want. Again, today I'm using a Windows machine, but it's really the same. So, wow, who would have said it years ago, right? But now SQL Server can literally run everywhere. Also, keep in mind that I will be saying Azure SQL or SQL Server, it's really the same thing. Azure SQL is just the cloud version of SQL Server. So SQL Server, Azure SQL have exactly the same engine. Actually, Azure SQL usually has the latest and greatest update because we deploy it in the cloud, so it's easier for us to deploy and update the bits there. But it's literally the same. And actually, if you've been following the latest news from Microsoft, you know that now we are working on something called Fabric for all the analytical or data platform requirements that you may have, and Azure SQL works there too in the named Fabric SQL. So SQL Server, the engine, is available everywhere. We like to say from edge to cloud to Fabric. It's just the same engine. We like to change the name sometimes, so that's why you see Azure SQL, SQL Server, Fabric SQL, but it's all the same. So free on-premises, really free, like forever free. And it just runs everywhere. Then what I like to say about Azure SQL and SQL Server, I've been using Python since 90-something, and I love it is better is included. I really love this way of saying of Python, and that's why I also love Azure SQL and SQL Server, because they come better is included. You have support for column store index, you have support for graph models, so you can create edge and nodes there. You have support for geospatial models. You can store JSON, and actually we're just improving JSON support in 2025. You have even XML if you're still using it, but there is much more. You can even have temporal tables, so tables that keep track of changes automatically for you. In-memory log-free table that are perfect to basically implement super fast key value models. You have different flavor of version control or concurrency control, to be more precise, both based on versioning or locking. So it's a very complete database. It all comes within the same package. There are no extensions that you need to install. It just works out of the box. That's our goal. And one of the issues that I see usually with developers that are interested in starting using SQL is they are enthusiastic about that. Then they go to the download site or Azure SQL site and they say, man, there are so many choices that you are asking me to make here. What is the right SKU? What is the right version? It's it's too much. So just to simplify, whenever you have to make a choice in the cloud, so on premises, if you are using for developing purposes or test purposes, just go with the Azure SQL Developer Edition. That's the easiest thing you can do. But on premises, go for Azure SQL DB Hyperscale Serverless. Hyperscale is the version of Azure SQL that allows you to scale from a few gigabytes to 100 and more terabytes. It can scale out up to 30 replicas. It has a serverless tier, so it can automatically scale up and down between a certain range of CPU that you set, and you only pay for the second that you use that amount of CPU. So it's very cheap, especially for development, but also can scale a lot when you want to move to production and you don't have to move your data around. It's just in the same place. But more importantly, this is super important. We decided to really, go pedal to the metal with Hyperscale, and we completely remove the licensing cost of Hyperscale. So the moment you choose a Hyperscale as a SKU, you will not see license anymore as part of your cost. So the cost that you are actually paying is just for running the hardware, just like it happens with an open source database. So keep that in mind, because it really changed the game here. You have an enterprise database with full security, full multi-model, full relational engine. That is also license free. So it's pretty interesting, I would say. Now, hopefully I convinced you to start to take a look at Azure SQL. So the first question would be, okay, I got it. I want to start, and so I like that free is your favorite price. Keep in mind that you can easily move from free tier to Hyperscale without having to move data or everything. We basically manage everything for you. So it's very nice to start small, and then you have the peace of mind that you can ramp up and become, the next Netflix, if that is what you want to do, without having to re-platform your solution, which is, from a developer perspective, a great peace of mind it gives me. Anyway, So how do you connect to Azure SQL or SQL Server? Well, for now, we use a Python package called PyODBC. And so it means that you need to have a ODBC driver installed. But once that is done, its documentation is very well explained, and everything that you see in this slide deck, you just can click, and I connected the link to the right documentation page. Once you have everything installed in just a matter of minutes, literally, you can basically just do PyODBC connect, get your connection string, and then you can execute a command like this one, select, and here I'm using JSON for just one reason, because I found that it's very convenient for me to just move everything as JSON from and back SQL, because then I can just do JSON load or JSON dump with Python. I don't have to worry too much about iterating over rows or columns. I mean, you can still do it, of course, right? But that's, for my liking, it's much easier, because then I can treat everything as an object. So depending if you're doing analytics, probably you want to have rows and columns and iterate over that. But if you are just building application, it's just easier to have a JSON sent back. And we have a bunch of new features that support JSON creation, as you can see here, that makes super easy to load the result into your Python objects and just deal with it as it would have been a native JSON type generated in Python. This is just plain Python, but of course here we are also focusing on LangChain. But before going that, one of the absolutely important thing I want to underline is that you should not use password if you can to connect to a database, because managing password is a security risk. It's very annoying, I would say. And so we, of course, have full integration with Enter ID. With PyODBC, there's a few steps that you need to do in order to automatically get the token that is associated with your Enter ID account. It's nothing too complex. And it's all, again, very well documented in these two links that I shared, so that you can completely stop using passwords and just enjoy the fact that you log in your machine, or you log in into AZ CLI or Visual Studio Code or Visual Studio or whatever it is your favorite ID. And as long as it's compatible with Azure, we will be able to use that credential to allow you to get in Azure SQL. And also means that when you deploy your solution, you don't have to worry about saving the password somewhere, because everything will be automatically managed for you behind the scene using what we call managed identities. So very important. Again, these two articles here are available for you to get started with. If you need more help, I'm happy to also write an article or specifically blog something around Python. So let me know using Twitter, using this chat, using my email, if you want to learn more about that. So beside that, what is supported with the vast ecosystem in Python with Azure SQL? Well, of course, we cover our bases well, I guess. So Flask, FastAPI, Django, SQL Alchemy are all supported with Azure SQL. But today we are focusing on LangChain. So I'm super happy to announce that just a few weeks ago, we announced full support to LangChain with the LangChain SQL Server Python package that allows you to use SQL Server and Azure SQL as a vector store for LangChain. To help you to get started, and this is also the same repository we'll be using in a few minutes, is the Azure SQL LangChain repository, where I gathered a lot of samples on how to use LangChain with SQL Server and Azure SQL. And basically, I just took the LangChain tutorial, some of the LangChain tutorial, and ported them to use Azure SQL or SQL Server as a vector store, and just work as you would expect. It's very transparent, very, very easy. And that we'll be doing it today. So how come we can use the LangChain with SQL Server? Well, because we added, again, very recently support to vectors in Azure SQL and SQL Server. This feature is in public preview right now, which means that it's available in all Azure SQL database you will be creating, and that are also already being created because everything in Azure is automatically updated for you. So if you open any Azure SQL database that you have, you will have this new vector type that you can use. It's also available on premises, but to get access to that, you need to enlist yourself into the SQL Server 2025 private preview that is running right now. Soon we will also move into public preview, so you can choose if you want to use on-premises or Azure SQL. Again, at the end of the day, the feature is exactly the same. And how do you create a vector? It's super easy. You just create a table and then use the new vector type and then specify the number of dimensions that the vector must have, and that's pretty much it. Then once you have the vector in there, which is behind the scenes stored in a efficient and optimized binary format, from Python, we decided, and this is true for all languages, not just for Python, we decided that vectors are probably more easily managed by developer if we present them as JSON arrays. So to send a vector to SQL Server or to get a vector from SQL Server Azure SQL, you just have to send a JSON array here. So that's your array. You can do JSON dump, and when Azure SQL Server receives that information, it will actually parse the vector and save it into a binary format. And when you request the vector, again, it will be exposed as a JSON array string, which make it super easy to turn it into a proper type here, in this case, using JSON load. So very easy and very straightforward. No special libraries needed, no special updates. It's just a regular PyDBC connection, and that's it. What about LangChain support? Because maybe you are already using LangChain or you want to start using LangChain. So we have full support in the sense that we have created this new class called, or this new object called SQL Server Vector Store, which basically wraps the connection to SQL Server, the need to create a table, the need to turn some text into an embedding, the need to store it as a vector completely in a kind of a black box, if you want. And so you don't have to worry about understanding how the vector works in SQL Server, how to query a vector using, for example, vector distance, a new function we just released. You can just use it abstracting away from the database behind the scene if you wish to do so. And this is a very simple example on how you can get started. So you just add the LangChain SQL Server package, and then you define the vector store. You specify the connection string here. You specify how embeddings are resolved, which means when you specify some text, what is the function that is going to OpenAI or Azure OpenAI or the AI model, the embedding model that you have choose to use, and turn that text into an embedding. In this case, I'm using OpenAI. So I just have to specify the function that will take care of turning the text into an embedding, the table where I want to save my embeddings, and then the dimension that I expect my embedding to have. Why we added this information here? Because it makes sense to compare one embedding with another only if the dimensions are the same. So we want to make sure that no matter what embedding model you're using, you can declare upfront how many dimensions you expect to have. So if that doesn't come back as you expect, you get an error and not just some random wrong data without letting you know what's going on. So we just want to be very precise and direct here. Yeah, I see some question. I so can go back here. So the question I see asking if MS SQL connection string does not contain a password. In this case, it's a passwordless string. Yeah, that's right. I'll show you the connection now that we have a passwordless approach. I can show you and share my connection string with you because there is nothing in there that will be secret, right? So that's something we will see together in the demo very soon. Just a couple of interesting things that I want you to know, then we'll move to LangChain. For example, one thing that people ask me is that is there is a way, for example, for me to write some Python code that is executed when my data change in Azure SQL? The answer is yes. In Azure, you have something called Azure Functions, and you create an Azure function that is bound to the change that happened in Azure SQL. So, for example, you can create a trigger binding and monitor a table, and whenever data in that table is changed, you can have your Python script executed in using Azure Function, which is a serverless compute tier that allows you to do pretty much everything that you have in mind with your own data, because you can just react to the change and then store maybe the transformed data back to SQL or just call something else outside SQL Server or Azure SQL, but it just wonderfully works. Some other developer instead told me, you know what, this is great, but I really don't like accessing database using, PyDBC or other stuff. I really would love to avoid to be able to, would love to avoid to have the need to install a driver. So there is any way that I can access my database using just a simple REST interface? The answer is yes. We have something called Data API Builder that you can install on top of Azure SQL or SQL Server, and that will turn your database into a stateless and scalable REST and GraphQL endpoint. So if you are interested in that, check out Data API Builder because basically you can just talk to your database using pure REST operations, which is pretty cool, I think. Okay, so let me move to the sample here. So I'm going back to Azure SQL.dev, and actually, in order to show you how you can find the samples that I'm going to use this little link here, Azure SQL DB sample CI search, which is a fun project I have built to show how you can actually use AI to empower your solution with more friendly user interface. Here, I can just ask, I'm interested in LangChain, so I can ask LangChain, let's even misspell it, samples. And this is actually using SQL Server and Azure SQL behind the scene to do a RAG pattern so that I'm trying to index as fast as I can all the samples that we already built. So if you're interested in only LangChain samples, it will show you only the one that are relevant, as a RAG pattern expects to do. To your question, with the explanation of the example here taken from the description of the example itself, and also the reason of why this sample is provided as an example, as an answer. So let's start with the basic one. The samples with LangChain and SQL Server. This is the link. Very, very easy. And again, you probably don't need to really memorize this because you can always get it from AI.azure, also Azure SQL.dev. Just ask for LangChain, and that's it. And this is actually what I have already loaded here. So is this one the right one? Yes. So let's start with a super simple test. Here, well, I have defined in the requirements my LangChain SQL Server package. And then I am using, for example, let's start with the simplest one. I'm setting up the embeddings. I'm using my connection string that is saved here. This is the example environment variable that I'm sharing with you. And this is the connection string. So the connection string for Azure SQL, you just specify the driver that you want to use, the server name, the database name, and as you can see, no password at all. Of course, I also show you how you can use password if you want, because maybe you haven't set up all the managed identities yet, or you're just using on-premises solution. But for example, if I'm using Azure, this is the only thing I need to use, right? And again, no password at all, so it's very nice. And automatically, the LangChain package will figure out that you haven't provided a password or a user, and then we'll try to use your token if you have logged in using a zCLI or Visual Studio Code to connect to the database. So pretty cool here. So let's move to the test. So I'm getting the connection string, and then I'm setting up the vector store on LangChain test table 1. And I'm also using, since I really love VS Code, also to create solution with Python, but also to query my data, I'm using this new or updated extension that we just released. It's called the MS SQL extension that allows me to query my database right from VS Code. So here I have created my connection both to the SQL Server in Azure, actually it is Azure SQL, or to my localhost database. So let's use this one first. Let me close this one to make sure that I'm connecting to the right one. I'm connecting to the database. The first thing I want to show you is which is the SQL Server version I'm running. And I'm running the latest and greatest, so the preview. Since I'm in the product group, of course, I have access to the private preview. But it is running this is running on, let me zoom out a bit. This is running on, here we go, on the developer edition on using Linux. So let me copy this text here. You will see that it's running the developer edition running on Linux. So it's very nice. Actually, this is running on my Docker image here, which is again Ubuntu based. It's very easy to install a SQL Server using Docker. You just do SQL command create, and that's it. So it takes just 1 minute, and in this case, I'm even running the latest and greatest private preview. But anyway, having said that, so just to show that we are running everything where you may not even expect it, and I'm using this free version called Developer Edition. Now here, I don't have the table that I want to use as a test, so let's just try to run this simple sample that will create a vector store in a table called LangChain test table 1 and then test table 2, just to show that you can have more than one vector store. And then I'm trying to just add some names here, some payload. And then I'm showing you, it is more like sample on how the API works for LangChain. So you can delete even the stored data, or then you can add the text. And again, doing some tests just to show how you can get confident with the API. And then I'm doing similarity search, and I want to see what are the most common rows that I inserted to the term ship that I'm using here. And I want to see what is the most similar to ship among all the text that I've inserted. And of course, well, we'll see what is the answer, but I guess you expect that probably both will be the first one. So let's run it. Actually, I think I have an environment created here. So venv script activate, and then I can just go into samples and do Python and then run test 1, and let's see what happened. So this again will connect to my local database, and then okay, and then connecting. Now, why I'm also showing you this, because if you try to connect to SQL Server 2025, you will get a warning because behind the scene, the libraries is using SQL Alchemy, which doesn't know about this new version because we literally released it, announced it 2 weeks ago. So it's just raising a warning saying, hey, looks like you have a version of SQL Server that I never saw before. Some feature may not function properly. That is not the case because, of course, we always make sure that everything we do is backward compatible. So don't worry, but just to also show that behind the scene, I'm using LangChain and SQL Alchemy. And here, let's go into the query right now. So let's do select star from. Now let's see if the table has been created. Yes, of course, we have these two tables. So let's do LangChain test table 1, and you will see that I have all the data. So this is the content. This is some method. Oops, this is what happened here. Let me close this one. Sorry, and let's execute this again. Here we go. This is some metadata that I just add randomly to show that you can also store JSON in Azure SQL. And these are the embeddings that have been calculated. Again, you saw them as arrays, but they're actually binary constructs. So again, it's nice to see them just in case you want to have some idea of what an embedding look like. Again, we are not probably never going to use these values manually because what we will be doing is using the similarity function that we want to use with the LangChain. So, oops, I think here's my result. So as you would expect, if I'm searching for ship, the first document return is the one that contains both. So that is great. And then I can also ask for information with the score result, so the similarity result, or I can just use it as a retriever, which if you've been using LangChain for a while, you know that a retriever is a key concept in LangChain. And of course, you can turn your function is retriever as you would expect. So this is to start just with LangChain. You have many more samples here, how to create an agentic RAG, how to do semantic search. I don't have time to show it here. I only have 5 minutes as far as I know. I think so, right? And then
yeah,
so
we have
what I want to show.
left. Sorry, we have a few minutes left, plus some like just 1 or 2 questions that are left.
Yep.
So
Exactly. Perfect. So I think I'm on perfectly on time, because what I want to do right now is move to this other example, chatbot on your own data with LangChain and Chainlit. Again, make sure that you just search LangChain into this nice AI search that you can reach if you go to azuresql.dev, click on AI samples, and then let's search again for, let's search for LangChain and Chainlit. And you'll see that you get the answer that you want. So this is the other example that I want to show you. I will not go through the example. The only thing I want to show is that I have, in this case, I decided to use a storage procedure to find the things that are similar to what I'm looking for. So is this find session here? This is an example that uses session data from a conference to find what are the most common session. And I just want to show you here that behind the scene, LangChain is doing nothing magic. It's just using the new vector distance function that we created in Azure SQL and SQL Server to efficiently calculate cosine distance or dot product or Euclidean distance between 2 given vectors. And of course, if we run the example here, so I think I can just go to Chainlit and then do run, enable, here we go, the virtual environment, and then I can just do run. And well, I also have a demo with LangGraph, but let's just start with a regular one. You will see that thanks to the integration with LangChain, you can have, you define your prompt, as you probably know, but you can create a runnable Lambda that calls your function that behind the scene call, in my case, a storage procedure, but a retriever that I showed before with LangChain to basically search across all your data. So here, for example, I have just a couple of sample sessions here, one on how to bake pizza and another one on how to do SQL and AI solutions. So let's say, hi, how I want to learn how to bake pizza. And let's see if the AI bot is able to help us. Is basically going into my database, executing vector search on the session that I have created. And as you can see here, John Doe is delivering a session called Unlock the Art of Making Pizza that I may be interested in. So this is RAG on your data, saved in Azure SQL, accessed via similarity search using vector store. So very nice end-to-end demo. I know I've rushed it a bit, but I just wanted to show you how you can start from scratch, explore LangChain, and then what is the final result that you can build. And to give you an idea on how much I took to create this result, this solution, of course, Chainlit comes with a full UI, so it was very easy. I think I took like half an hour, let's say 1 hour for me to just write the storage procedure, add some sample data, set up LangChain and integration with Chainlit, and I was done. So pretty nice. With that,
been an amazing session. I'm really enjoying it. And I got time for just one more question from our audience, if you don't mind.
Absolutely.
Awesome. So Pamela has a really great question. And actually very, very simple. What extension were you using for executing queries?
This one, SQL Server MS SQL extension. This is an old one that has been refreshed lately. So it much more meet the developer expectation. So if you've been using this session lately, make sure to download it again. It's all refreshed. You have to enable the experimental feature that I can share later, a link on how to do that. We have a dev blog post on our blog, and then you basically have the same experience that you would expect having on Management Studio or Azure Data Studio, but in VS Code. So zero friction, zero time lost moving from one context to another. It's very nice, and it's all here. So it's very, very super cool, I would say.
Great. Well, hey, this was a fantastic session. We're really glad. I am a NoSQL person myself, being from the Cosmos DB team, but I'm always interested in hearing like how people are using, standard, as I like to call them, tabular databases, going in.
Yeah.
So
Yeah, I guess now all modern databases are, I would say, converging, because NoSQL database are trying to be more structured, and relational database are now supporting JSON and unstructured data. So I guess it's more like a question on what you like more, because functionally wise they are kind of overlapping a lot right now, I would say.
Great. Well, we got to move along, but I wanted to say thank you so much for being part of our show today. It's been really great to hear from you. And I know that our audience appreciates learning more and more how to build these types of applications, and especially with LangChain being such a huge part of way AI apps are coming together. So thank you very much.
Thanks a lot. It was super fun for me.
Your day, evening, or wherever it is, your time.
You too. Thank you. Bye-bye.
Well, that was another really great session that we had. I hope you enjoyed it. We've got a bunch more to go. I am solo right now, and I really just wanted to say from the bottom of my heart, I'm so glad that I get to share this time with you all. It's really, really special, and we have some time to spend soon with another member of our wonderful group of hosts, or I should say guests and speakers. And so the next one we have is Joylyn. Am I pronouncing the last name Curie? Is that correct? You are muted, unfortunately. Sorry.
Can you hear me now?
Now I can. Fantastic.
Oh. Hi, Jay.
How are you today?
I'm fine. I'm trying to share my screen here.
Sure. You want to probably unshare what you have there, then just go down to present. And there's a little button for you. But while you're doing that, I want to remind everybody that there's so much cool stuff that you can do while you're watching the show. You can check out the Python Day details. You'll have all the information about who is speaking, the subjects they'll be talking about, things like that. Make sure you check out the Python Developer Hub. And there's a lot more. Joylyn, how are you doing there?
I'm fine. Let me just share my screen.
Yep. Down at the bottom, present should all be what you need there. And then you can just pick your screen and we'll go from there. And while you're doing that, we got a couple bit more housekeeping things we could do. We could actually talk about PyCon US. That's coming. We always try to have a good presence there. I know Dawn and people like Anthony Shaw, Pamela Fox, Josh O, they're all going to be building great things so that you can see them. All right. How are we doing, Joylyn?
Oh, very good. 1 second.
So what I'm going to do is ask you to go to where it's currently presenting and disconnect the device, and then go down to present and present the new device.
Okay.
Yeah, it looks like you opened it up in another tab or another browser. You just need to open it up in here. Make sure the dog knows that I'm a big fan.
Okay, so maybe in the interest of time, I don't know, maybe you can just try to add my screen to...
Yeah, if you go in the current browser that you're in that has your camera in it right now, if you just go down to present, you should be able to pick your screen that you want to present from. It just says share screen right there at the bottom.
Okay.
Well, everybody, while we're watching, I just wanted to say, hey, everybody, I think we've got it. All right, we got it. You got it perfectly. Great. Let's get ready. Let's get presenting. I'm going to go ahead, take myself out, and let you go ahead and get started. All right?
Yes.
Great.
1 second. Let me switch screen. Oh, apologies for this. It's pretty late here, so I'm just trying to keep myself awake as well.
It's
So,
okay.
um,
Yeah, you
we
can just
share
go
my
ahead.
screen.
Yeah, let us know if there's anything we can do to help you out. But
Okay.
yeah, just go ahead and start presenting when you're ready.
Perfect.
While Drillin is doing that, also reminder that we have the Microsoft AI Tour coming up, aka.ms/AI Tour. It's a great place for you to go. You can see people build amazing AI applications using Python and many other languages, many other databases, different AI services like Azure OpenAI. You'll be able to take a look at all that stuff, hear from leaders around Microsoft, and hopefully gain a lot of new information. So, Drillin, how you feeling now? You got that?
I think I got it.
It's fantastic. All right. Just do me a favor, click the hide at the bottom, and yep, and then go for it.
Perfect. Thank you, Jay. So today we're going to learn about securing Python applications. And there's a reason why I'm the best person to talk about insecure code, because I remember back then, the reason why I found myself into cybersecurity is because I actually got hacked. And then I became very curious on how to actually build more secure products. And that's why I say I usually went to Google University or YouTube University just to do that self-analysis around how I can build more secure products. Yes, but that aside, my name is Jolene Kirui. I'm a senior cloud security advocate at Microsoft. You can find me on Twitter and on LinkedIn. Those are my handles. And just to jump off into the presentation. So this is what we're seeing everywhere. Insecure code everywhere. And it's very important just for us to understand our role as developers, because I always say developers are our first line of defense. And the reason why I say developers are our first line of defense is because we know when we are doing insecure code, because sometimes it's just a lot of time as well to actually do things correctly. But at the end of the day, you have to understand that it's your stake. You have to have a security first mindset whenever you're building these applications. Otherwise, your company might be hacked. Your customer data might be leaked. And there's a lot that goes around afterwards with that. So it's very important just for us to understand why it's very important for us to talk about secure development, because we find that 50% of companies actually sacrifice cybersecurity for speed. And because you find that you probably announce that you have a big feature going out maybe on Friday, and then after that, probably the security team comes in and then they say that there's a huge security vulnerability that has been found, which is of high severity. And they say that if you move forwards, there might be some consequences. So in most cases, you find that companies actually sacrifice that cybersecurity issue for speed because they had already announced. And then we find that also ops team, they push back on several security best practices as well, because you'll find especially in companies where they still have like legacy systems, and then our security folks give them like a whole list of security vulnerabilities. So it's very hard for them to actually deploy and have the best practices in place. And also, I don't know, maybe you can also tell me on the chat, are you trained to code securely? So another statistic that I really like showing is we find that 80 to 90% of code in new applications actually comes from open source. So normally we say that 80% is code that is actually borrowed, and then 20% is actually code that you yourself have actually coded yourself. So you can imagine out of the 80%, that's what we call third-party dependencies, open source libraries that incorporates 80% of your code base. And the 20% is one that you've actually coded. So out of the 80%, how much of it is actually secure? Ask yourself that. So the other sources of vulnerabilities as well, we see that we have unchecked dependencies. That's 80% of the code. And then there's also employee error, where we're talking about exposed access tokens, and safe coding patterns as well. So we're going to chat a little bit about that going forward as well. And now in the era of AI, we are introducing Gen AI applications. So beforehand, we had all these security vulnerabilities, and then now we're introducing Gen AI applications. So that does not mean that all the other vulnerabilities reduce. It just means that the threat landscape has actually increased. So these are all the things that we look at in our code base when you add Gen AI in terms of the new threats that have come in. So you can see in each of those components, we have very many new components. Like right now, we're seeing something that we didn't see 1 year ago, which is something like direct prompt injection. That's a new vulnerability that's coming with Gen AI application. And then we also have sensitive data leakage, unauthorized access, oversharing, over-reliance, model denial of service. So denial of service was there before, but right now, since we're talking about AI models, there's now that element of model denial of service. And you can see, yes, this is a very busy slide, but if you can just click on this, because it's very important just to understand the threat landscape around your application. So you have your Python application already, but you also have now introducing Gen AI as well. So these are all the things that you're seeing right now in terms of security vulnerabilities. So this is one of the applications that we have. You can access it in aka.ms/ragchat, which Pamela and the awesome teams within advocacy built. And for me, the reason why I have to show this is the architecture diagram of it. And the one thing that we always have to do as developers is to have a threat modeling done. And threat modeling is done when you have your architecture up and already. So we have this tool called the Microsoft Threat Modeling tool. And as long as you have the Microsoft Threat Modeling tool, you can now drag and drop these architecture objects as stencils within that tool. And then it will tell you which components are actually vulnerable to which threats or risks as well. So threat modeling is something that we always have to do if you're introducing any new component within your application, do some threat modeling. So if you're introducing a new API, you have to understand, so is it public facing? Is it private facing? Have I put in the right controls into like rate limiting to protect that application from being compromised? So the reason I was showing you this is so that you can understand, okay, what better ways can we do our security throughout the whole architecture? And one thing that you'll notice here that was different from the previous one, we have this component of login, which is quite important. So authentication and authorization is quite important. And that's what I'll be showing you today as well. And then this component of application UX. So you probably have your website and then you have your Gen AI app embedded there. So even if you are building a Gen AI application, it is still code at the end of the day. So I'll also be showing you how you can be able to secure your Python code, the 80% that you've just borrowed and the 20% that you've coded yourself using GitHub Advanced Security. So for today, that will be the main angle that we'll be showing you in terms of deploying and making sure that the code that you're building is secure, and as well as adding authentication within your application. I hope you are looking forward to that. But before we get into the demo, I want to show you what we have in terms of the threat landscape. So every 4 years, OWASP actually releases security vulnerabilities according to what they've seen trending in the last 4 years. So you can see what was there in 2017 was quite different from what is there in 2021. So when you're looking at the code here, we're seeing right now the top issue that we're seeing in applications is broken access control. And then you're also seeing now the others are now cryptographic failure, injection, things like SQL injection. You've probably heard of SQL injection. And then there's insecure design. I showed you the design, the architecture before, and then I showed you another architecture of how you can be able to make sure that your architecture is flowing well, that you have everything considered, you have authentication, you have data and access control deployed within that whole architecture. And then now we also have vulnerable and outdated components. So I spoke about the 80%, so that's where we have the vulnerable and outdated components. And I'll show you right now how you can be able to fix that real quick. Okay, so I'm very sure most of us are using GitHub GitHub, and we have this cool feature called GitHub Advanced Security. So GitHub Advanced Security has several features that are available that will be able to give you the checks on the 80% of the borrowed code and the 20% of the code that you've actually written yourself. And all you have to do, the thing I like about GitHub Advanced Security, you can play with it even right now for free because it's available for all public repositories. But for private repositories, you have to pay for a license. So you can see here, I have a vulnerable Django application. And all I have to do within GitHub is to go to settings and then scroll down to code security. In code security, we have this private vulnerability reporting. So this private vulnerability reporting is more like a bug bounty program within GitHub. So if you enable this, researchers can come in, and then if they find any security vulnerabilities within your application, it will tell, so they'll report, and then they'll be given some amount of money as well. So this private vulnerability reporting is also important, something that you can consider. But the key things that I want to highlight is Dependabot. So Dependabot scans your whole code base for dependencies, and it scans now the 80% for now the third-party dependencies and the open source library for any security vulnerabilities. And then it will list all of those within the security dashboard. So you need to enable that. And then you also have Dependabot security updates. It bundles up. It creates a pull request for you with suggestions on how you can be able to fix all those dependency issues. And then the other component that you need to enable as well is code scanning. And the thing I like about GitHub Advanced Security code QL analysis for code scanning, it actually detects. So if I disable this code QL right now, and then I set it up real quick, I use the default settings available, it will automatically detect the kind of language that I'm using within my repository. And then all you have to do is now to enable code QL. So it will scan through each line of code to give you any security vulnerability that's available there. And then the other important aspect that you have to look at is secret scanning. You have to make sure that secret scanning is enabled. And the best practice, if you have any secret that's embedded and then it's found, you have to revoke that secret as much as possible. And also make sure that right now, even in the era of AI, we want to move away from stuff like API keys as much as possible and use managed keys as much as possible, because you don't want this scenario whereby you are always shuffling your keys, you're always forced to revoke your keys because it has been compromised. And the other thing that I really like about secret scanning as well is push protection. You have to make sure that you have this push protection enabled. So push protection prevents you from actually merging to your repo if it actually finds any security, any secrets. So if you're available like on Visual Studio and you're trying to push your code and it finds a particular line of code that has secrets, it will prevent you from merging that line of code. So that's why it's very important for us to enable this. It's cool, right? So let me just quickly show you the kind of insight you get. So for Dependabot, I mentioned it's for the 80%. It will find that for this one, it lists them according to severity. So in security, we usually list our security issues in terms of critical, high, medium, low, informative. So you find here that this one is almost certain that we're vulnerable. So we find here that our number one issue is SQL injection in Django. And then all I have to do here is to review the security update. It has already created a pull request and given me suggestions on how to fix it. It has told me that this particular version between these allows this particular SQL injection because there's untrusted input from a client of a web application. So let's review that. It has created the pull requests. All I have to do is to merge that pull request for it to actually fix that dependency issue. The other thing that you need to check as well is code scanning. It tells you which line of code is actually vulnerable, as you can see here. It gives you the suggestion on how to fix it. And it tells you that code that passes user input directly to exec or some other library that executes a command allows the user to execute malicious code. So it gives you that overview, and you can be able to go in and see how you can be able to fix all those code scanning issues. And as well as secret scanning, it tells me, like for this Slack API key, it tells me this line of code, and this one is actually publicly exposed, gives me recommendations on how to retrieve the secret, revoke the API token, and also to check the security logs for potential breaches as well. Because in most cases, if an attacker is compromising your application, they'll be able to go into the logs as well. You can be able to tell from the logs if something was done. But what most attackers do, they also clear up the security logs so that it's very hard for you to know if you were actually compromised. Okay, so that's an overview of secret scanning, and it's very important just for you to understand what is within your code base and which one of them is actually vulnerable. And then the other component that I spoke about earlier is having authentication within your application. So it's very important just for us to understand what are we talking about in terms of identity. So when you're talking about identity, we are seeing a lot of reports as well, even from the MSRC, our Microsoft Bug Bounty program, is that you'll find that maybe in this case, tenant administrators can actually create users with any email address. And the consequence of this, you find that maybe this create admin was able to create a user for our vendor that's using this particular email address. And you see this gives some bit of authentication issues whereby you have potential of privilege escalation in Azure AD applications. So what can we do about this? I like this meme because this genie is saying there are 3 rules: no wishing for death, no falling in love, no bringing back dead people. And then you have this, but I want to write my own authentication and authorization. And then he's like, no, there are now 4 rules.
Hey, Joylyn, just wanted to make sure you knew we got about 5 minutes left in your session, but please continue.
Yes. So the goal here, remember we've already scanned our application for security vulnerabilities. We've done the code scanning, we've done the secret scanning, and we've done the dependency scanning as well using GitHub Advanced Security. So the other component in terms of securing our application is to make sure that we have the right kind of authentication and authorization within our application. And the whole goal here is to make sure that we have the right kind of authentication within our application. And the demo that we'll show here is using that particular repo that we have up. But you might be wondering, so what is authentication and what is authorization? Authentication in most simple terms is, because normally we use like username and password, it's that identifiable quantity that's given to a particular person. So like for me, I have the username maybe Joylyn Kirui, and then authorization is to see if I have the right access to a particular resource. If I should have access to that resource, then I should be authorized to access that particular resource. So in this case, for authorization, we're using Auth2, and for authentication, we're using OIDC. And you can see here, this is the simple flow for Auth2 authentication flow with OIDC. And we're seeing that we have this request that's going in, and it's quite complicated to actually do this correctly. And that's why it's very important just for us to use the built-in authentication that's available for our application using the built-in authentication that I'll show you shortly. So typically developers would need to build custom logic on their backend to verify the authentication code flow and handle auth and return an access token as well. So this process can be time consuming and requires considerable development effort to manage authentication. So that's why it's very important just for us to go in and see how we can be able to use the built-in authentication that is available. So instead, we'll use the Azure's built-in authentication for app service, which intercepts requests, figures out which users are not logged in, manage token issuance as well, and redirect the users back to the application upon successful sign-in. So this allows you to focus on building application features while the platform manages authentication and authorization for you. Okay, so just to give you an overview of what you have here, we can see here, let's just, okay, the code base stopped. If you have any questions, please let us know. But this is just an overview. I'll give you the link to this application as well. So what we want to do is to use the built-in authentication using Microsoft Entra. And you can see here, this is what we want to achieve in such a way that you can be able to sign in using your user. And the thing that's very important here is to make sure that you have Microsoft Entra ID set up. And all you have to do within Microsoft Entra ID setup is to make sure that you have the right tenant here. So if you're using like a work tenant or an external tenant, you have to set it up within this code because you're deploying using Bicep. And then you also have to make sure that that you have your AZD auth login to the right tenant that you have deployed. So the main difference between Entra ID and external ID is the kind of tenant that you're going to deploy, because for external ID, all you have to use is an external tenant for your application to run.
Wonderful. Well, right now, I think we don't have a ton of questions, but I just wanted to say, as someone that has worked in the world of system administration and dealing with applications and DevOps, security never seemed to get as much attention as it really was due. And so I feel like what someone like yourself and other members of like the security community do is really give people things to think about. What do you say right now for an application developer is probably the most important thing for them to look at regarding security before shipping to production?
Okay, so I have one last slide that can show them how to actually summarize this. Okay. I created this just for them to be very easy for them to understand. So it's just a simple one slider that you can just screenshot and live by it. One thing that you have to do is always do input validation, because what garbage in, garbage out. You have to do error handling, the correct error handling. Access control is quite important. Secure data storage, secure communication. Make sure that whatever is being transmitted is secure. Whatever is in transit is secure. Whatever is in storage as well is secure, because you never know who's listening. You also have to make sure that you have the right secure session management, the right secure coding standards. That's why I showed you the OWASP top 10 vulnerabilities, and as well as having regular security testing. So we have like tools like GitHub Advanced Security, PyLint, PyChecker, and Bandit. Tools like Bandit are specifically for Python application. And then you also have to keep your software up to date, and as well as have the right security awareness training every so often. So I hope to see more and more of you being security champions.
Very, very cool. That actually really answered my question completely. Well, Joylyn, it's been wonderful to have you part of this today. And I know our viewers are really, really glad to hear how much of a focus security needs to be for them when they're building applications. So thank you very much. And hopefully we'll see you next time. Have a great rest of your evening. Bye now. Well, that was Joylyn, and we've got our next talk coming up. And I'm going to say that this one's a special one for me because this is a member of the team I work on. I have Theo Van Cray. Hey, Theo, how are you?
Hello, Jay. I'm doing great. How are you?
I'm great. Now that someone that I've spent all this time talking with, I mean, we just literally had a conversation about Python maybe yesterday. And so it's always wonderful to hear what you're coming to this audience with when it comes to Python. I know you really bust your butt on getting out information about our SDK and things like that. And you've got some getting started stuff for people today. So I'm going to pull up your presentation and let you go for it. All right.
Thanks, Jay. Okay. Yeah. Can we see my screen? Okay. Is everything good? Can you hear me? Okay.
You're all good. Go for it.
Awesome. Awesome. So yeah, this is getting started with Python on Azure Cosmos DB. That's my name there. I'm a PM in Jay's team as well, Cosmos DB engineering team. So I'm guessing if you've tuned into this session, you probably know about Python, but maybe Cosmos DB is not all of that familiar to you. So just a quick rundown. Of course, Azure Cosmos DB is Microsoft's let's say flagship NoSQL distributed database service. It's fully managed. It's a massively scalar architecture. Of course, this is expressed in multiple SLAs across latency, throughput, availability, consistency. So these are pretty comprehensive. It's pretty reliable, and the proof in the pudding, of course, is also the applications that run on Cosmos DB, and there's just a few of them here. These are just the internal ones. Some pretty big applications there, as you can see. And last but not least, of course, OpenAI uses Cosmos DB to scale its ChatGPT service as well. So why use Python on Cosmos DB? Well, as you just saw there, it's pretty much the database of choice for scalable, globally distributed applications in Azure. Why Python SDK? Well, it simplifies development pretty much by virtue of it being Python. Your Python developers, you don't need me to tell you how easy Python is to work with and to get things started and going. And of course, as I just said, OpenAI not only uses Cosmos DB to scale its ChatGPT service, but it also uses the Python SDK as well as the Spark connector also, which I'll touch on today. So if it's good enough for OpenAI, hopefully it's good enough for you if you want to start building things with Python in Azure on Cosmos DB. What I'll touch on is just the very fundamentals, the basics of the Python SDK. I'll touch on the key features and what has recently been introduced, and also point you towards where you can find out what we're working on and when. And also I'll give a brief intro to Python on Spark, or PySpark as it's also known, with the Cosmos DB Spark connector. All right, so the basics of Python SDK: installing, connecting to Cosmos DB accounts, and doing some CRUD operations. So let's do some demo. So I have PyCharm here. I like PyCharm because of the way it creates virtual Python environments. So I'm just going to create one here, again, completely from scratch. So we'll go to the packages here and look for Azure Cosmos package. Of course, you can do this from pip install as well, but PyCharm has got this nice little feature here where you can install. I'm going to install the latest package, and once I've done that, I'm going to go through here and create just a simple file, a Python file. And we're going to go ahead and call that main.py. And I'm going to work with GitHub Copilot. So highly recommended. I'll leave a link at the end so that you can see how to set up with that. All I'm going to do here is just add comments, and those comments are going to act as prompts. And GitHub Copilot is going to do all the coding for me here. So I'm going to say create Cosmos DB client and create database and container if not exists. And it's going to go through there. And as I tab through, it's creating the code. It's importing Cosmos client function from Azure Cosmos with exceptions. And then as I tab through again, it's going to initialize Cosmos client. It's going to give me some environment variables for my credentials. This is using key-based auth. Of course, you can use default Azure credential as well. I'm creating a client and I'm passing in those credentials, and then I'm going to use that client to call to create database if not exists on the client with the database ID that it's creating for me here. Again, I'm just tabbing through and it's writing the code for me. Same thing with container. You'll notice there it specifies partition key. I'll come on to that a little bit later, and offer throughput of 400. Cosmos DB has this concept of request units. It's a normalized metric of throughput, so you don't have to worry about things like IOPS and memory and resources and so on. It's just every request has a cost in terms of request units. Okay, so I've done everything that I asked it to do. So let me just put another comment here to say create item. And again, it's going to it's realized that I need to create a JSON item, and it's guessed at the things that I want in there. Of course, I can update that, but that's good enough for now. And it's going to go container upsert item. Cosmos DB, of course, is a NoSQL document-oriented database. It didn't manage to guess, Copilot didn't manage to guess the actual environment variables that I have, so I have to obviously change those. But apart from that, it pretty much has written all the code for me. So well done, Copilot. Okay, so Cosmos DB is a NoSQL document-oriented database engine. So it's going to store JSON documents here. Let me just debug and run through this here. So yeah, that's going to do this, and then we can go and view what's just been created here. It's created a database and a container in my database explorer of my Cosmos DB emulator. And by the way, the emulator is free to download. You don't need to have an Azure subscription. If you're working on a Mac, I recommend that you try out the latest emulator. It's in preview. It has a subset of the features that you find in the service and the emulator, and the older emulator, which had some issues running on Mac, but we now have an emulator that runs on pretty much any platform. So that's what I'm using here. So let's go through here and see if we've created a database. Yeah, and we've got the test container that I wanted, and it's inserted a single document. We defined ID, name, category is complete, and description attributes. Those other attributes, _ts, _tag, _self, are system attributes. You can see that under select star from C, there are an ID. There's an ID for every document, and that has to be globally unique. But there's also on the right-hand side there /ID. That represents the partition key. Again, I'll come back to partitioning later. You can choose ID as the partition key, and in that case, every partition will only contain one document, the unique ID. Or you can choose any of the other attributes that you selected in the document. In that case, each partition will contain n number of documents. And the idea in Cosmos DB is ideally when you're querying documents, retrieving documents from Cosmos DB, you want to scope the queries to a partition. And I'll explain why that is in a minute. But for now, just keep that in your mind. Let's just go into the unknown here and just try something else. And I think, yeah, Copilot is guessing what I want to do already without even me having to type it out. It's going to create some query text here, and it's going to go to container query items function. It's going to pass in the query text. You see enable cross-partition query here. That's because select star from C, where C.category equals general, is not specifying the partition key. So that's going to be what we call a cross-partition query. Again, I'll explain why that's significant. I'm going to delete the database here so I can run the whole thing again, and it can do the upsert and then execute the query. So let's debug through this one. Yeah, we do the upsert again, and we're selecting from all of those documents. Of course, there's only one document. If there were thousands or millions or even billions, of course, we wouldn't want to do this. It would be highly inefficient. So I'm going to just run this through, and we can see, yeah, brought back that single document. But what if there's many documents? I want to just read the item by its ID. So I'm just going to put in read item here. And what does Copilot do? Let's see. Yeah, so it's done something maybe a little bit unexpected. It's going container read item. Now you might think, why don't I just do select star from C, where C.ID equals item one? And actually, you could do that, and that would work fine. Except here we run into a slight nuance about Cosmos DB, which was that Cosmos DB actually has two different ways of retrieving information. It has a query engine, which has everything that you'd expect, including generating a query plan. And so if you use the query engine, it will generate the query plan and execute on that. But what you really want to do, if you're just executing, if you're just wanting to read the document by its ID and partition key, is just use what we call point reads. And in this case, it's just read item in the Python SDK. And in that case, the system is going to look for the document by the hash value of its ID and partition key, and it's much more efficient. And so why is this important? Well, like I said, and I've already alluded to it, Cosmos DB is a massively horizontally scalable distributed database. When you put data into Cosmos DB over time, as that data grows, it will be distributed onto different physical machines, and we need some way of retrieving that data from those machines or from that one machine. So it follows from that, ideally, when you're choosing a partition key, you want to be able to choose a key that allows you to scope most, if not all, your queries from that partition key. So if you're choosing ID as the partition key, ideally you only ever want to be retrieving, or most of the time you want to be retrieving just single IDs. If you need to be executing queries that are broader in scope, then you want a partition key that has a wider scope and that would be storing a larger number of documents. I don't have time to go through all the nuances of partitioning. I'll just point you towards some very comprehensive documentation that we have that goes through various different strategies like materialized view patterns, like hierarchical partition keys, and other ways that you can be flexible, and advice on how to choose the right partition key. Definitely, it's the most important thing to learn about if you're new to Cosmos DB and first working with it, is how to do partitioning properly, especially if you're not familiar with sharding, as it's also known, or partitioning. This is definitely a good first place to go to internalize that. So in terms of docs, again, we wouldn't have time to go through everything, but I'll just point you through to this one doc, which it's a big long doc, and it has lots of different samples for Python SDK. And if you want to see where those samples were generated, why not go through to the repo, Azure SDK for Python, go through there and find the SDK folder, and then you can look for the Cosmos folder, and you'll see Azure Cosmos, and that's where the code is for the Python SDK. And you can see under there's a samples folder, and there's a bunch of samples that pretty much illustrates everything that you can do on the SDK. And if you want to find out exactly what you're working from, what we are working on, excuse me, on the Python SDK, I encourage you to go and look again at the Azure SDK for Python. There's a projects folder, and we have a public project with a public roadmap. So you can go to the roadmap tab, and you can find out exactly what we're working on and what the timelines are. We update this regularly. So if there's a feature that you're looking for, and you think that the Python SDK doesn't do something that you need, have a look there, see if we're already working on it, and maybe go on there and give it a comment or something, or a thumbs up, and saying that you're waiting for this feature. And if it's not on there, feel free to raise an issue or a feature request, and we'll triage that and get to it eventually. So in terms of recent updates to the Python SDK, most recently, we released a bunch of features related to vector search and full text search, full text ranking, and hybrid search. And of course, these features also need special handling in the Python SDK. So that is the most recent update that we've done. And we recently announced this at the Ignite conference, which is a few weeks ago, which we used a demo app, which you can go and download if you want to. And this is a nice little Streamlit app, which you can go in there. And it has all the code that you need, including vector indexes, vector policy, and then the code to actually interact with these search features. And it's a simple little app. You just start it up. Let's go and have a look at this here. And then, yeah, you can just select the indexes, and then you can type in some text, and you can compare the different queries that it will run, and it will show the query that's been run and the results and so on. And so you can investigate that. And last but not least, we have an awesome samples gallery, which has a ton of samples in many different languages, but you can filter by Python, and we have a ton of Python samples as well, from everything from analytics to architecture, generative AI, data migration, different tools. And there you go. You've got a nice little RAG chatbot notebook that you can run through there as well. So pretty comprehensive in terms of samples for Python SDK. So that's everything that I probably have time for Python SDK. Hopefully that gives you some pointers. I'm going to just touch on Python on Spark, or PySpark as it's also known. Spark is a very powerful framework, which is really good for large-scale data processing, particularly for batch ingestion and streaming at very high volumes. Of course, you can do this in raw Python as well, but Python has its own limitations when it comes to scale, particularly around concurrency and parallelism and so on. But the great thing is that Spark, amongst the programming interpreters that sit on top of Spark, is Python. So you can write Python code with Spark, and we have a pretty robust Spark connector for Cosmos DB. This is a high-level overview of how it works, which pretty much reflects how Spark works generally. When you're working with Spark, when you're inserting data into the Spark environment, that data will be broken into different chunks. Each of those chunks can be processed in parallel and in a combination of memory and disk, with memory spilling over into disk. And all of this is seamless and transparent from the user point of view, as long as what you're doing is stateless and associative. Pretty much anything that you do can be done in parallel, and it's pretty high performance. There's a bunch of stuff here explaining how the Cosmos connector works. I won't go through everything, but I'll just mention here this link on optimization of Spark ingestion. If you are intending to do that with Spark, or you think that would be useful, definitely check out that that documentation for how to do that properly. There's a kind of anatomy of how an ingest notebook will look typically in PySpark. You'll have some credentials that you need to pass in. We recommend secrets, of course, or some other way of obfuscating those credentials. And then you'll have a config that you would pass in. You'll need to activate the catalog API, and then from which you can execute operations like streaming and like ingesting and creating resources and so on. I'm not going to go through all of the different configs, but I will call out just one, which is the throughput control, which is a very useful feature in the Spark connector. It helps you isolate performance when running jobs. Typically, jobs that are run in Spark tend to be very big with large data sets. And of course, you're running against Cosmos DB, which is an operational data store. So you want to protect your steady state workloads from having all of the throughput that's available consumed. So this is a way of controlling that on the client side. With rate limiting on the request units that you have provisioned, you can specify your own limit, and then that helps. There's a document there that I highly recommend that you read if you're going to use the Spark connector and you're going to do transformations on large data sets. Similarly, for streaming, there's an anatomy here. The one feature that I would call out here is that it has built-in checkpointing. One of the challenges with streaming in any framework or connector is that usually you don't have an easy way of being able to recover when there's an outage or when your job dies or something like that from what you last processed. And particularly in Cosmos DB, where we're using a feature called change feed, which is a distributed change log of all the changes that happen across the Cosmos DB container that you're working with. If you're using the other mechanisms for reading a change feed, like change feed processor and various other things, it can be difficult to recover when there's an outage or when there's a problem. But the Spark connector does have a built-in checkpointing. So if the job dies or if there's an outage, as long as you can still access the checkpoint location in the file, you can then recover from that bookmark and start processing from where the job left off when it crashed. So yeah, there's target config and there's read stream and write stream operations here. Again, I won't go through everything, but just one pointer, little gotcha is there's a start from parameter in the config that you can use, which has values of either beginning, now, or some specific dates. You can process all of the changes that have ever occurred on a container if you say begin from the beginning or from a specific date. And if you do it from now, then obviously we'll start processing from now. The thing to call out here is all of these are ignored if there are actual bookmarks in a checkpoint location that you've defined. This sometimes catches customers out if they've used the checkpoint and then forgot about it, and then they wanted to define a specific time and it doesn't seem to work as they expect. There's two change feed modes, latest version and all versions and deletes. The names are pretty self-explanatory. Latest version is just the latest version within a given polling window and no deletes. All versions and deletes, you're going to get every version of the document. So you should only choose that if you really need every version of the document and you need to process deletes. For most customers, latest version is usually fine. And then one of the gotcha account per trigger hint, if you are processing everything in a streaming fashion, including all of the updates from the beginning, and it's a large container with a large amount of data, then beware that it's going to try and process everything in the container in the first micro batch if you don't set a value here. So you probably want to set that to a low value, and then it will auto optimize after that to find the ideal micro batch amount for each micro batch in the structured streaming that is done. Okay, so I'm going to do a little demo here. This is going to be using a hierarchical partitioning sample. I probably don't have time to describe everything about hierarchical partitioning, but except just to say that it's a way of being a little bit more flexible. And with one thing in particular, which is that if you're choosing a partition key in Cosmos DB, that logical partitioning, as we call it, will have a certain storage limit. So if you want to be able to store, you want to be able to have the advantages of being able to filter on a partition key, but you need to be able to store more data than the 20 GB limit. One way of getting around that is to use hierarchical partitioning. All of the child keys and documents under the parent key will be co-located as much as possible with the parent key, but there's no storage limit there. And so even if they exceed the physical limit of the partition, they'll be in different partitions, but they'll be co-located as much as possible. And if they don't exceed the limit, then they will be effectively co-located in the same partition, even though technically it is a cross-partition query. So that's one way around getting one way of getting around both the performance issues that you can sometimes get of cross-partition queries, but also the storage limit of regular partitioning, as it were. So let's go ahead. I'm using Databricks. Databricks is an easy, very easy way, a PaaS service for provisioning Spark clusters. It's very easy to do. You just go to compute and you can create compute. Very straightforward. There's some default settings here. I've already done this here. You do need to install the Cosmos DB connector. This is already pre-installed in things like Synapse Spark pools. But it's pretty easy to install. You just go through there, go to Maven, and then you put the Maven coordinates and then install. I've already done this, so I've just taken one of the samples. It's also pretty easy to import a file or a notebook from somewhere else in here. So I'm just going to go and show how to do that right here. We have a samples repo. Here, in fact, this is the repo for Java SDK where the Spark connector is hosted. And I'm going to go ahead and just show how to import a sample. So let me go to this Python PySpark notebook here and just go to the raw rendering of this and then get the URL. And then we can just copy that and import it in here. And that will import it into my workspace. And so that's pretty easy. But I've already imported this earlier, and so I'm going to go switch to another workspace here where I edited it a little bit just to make it a little bit more realistic in terms of data volumes and also to obfuscate my credentials here. So let's go ahead and run this. We're going to use this count in Azure. So I've run the credentials cell, and then I'm going to run the cell that sets up, like we said before, the configs and the catalog API. And then I'm going to run a cell that creates my database and container. And it's also going to create a data frame and randomly generate roughly 350,000 records. So let's go through to my account in Azure Cosmos DB portal and see, yeah, it's created a container with 10,000 RUs, and let's just do a query, select count, see how many records are in there, and we've got roughly 350,000. So if we go back to this PySpark notebook here and go to my next cell, I'm going to first run a cell that just naively tries to filter on the parent key of the hierarchical partitioning. This is less efficient because it doesn't use a range filter, so it pretty much defeats the purpose of using hierarchical partitioning, but we'll see how long that takes to execute when filtering through this amount of records. So that is going to be just over 12 seconds there, but then we're going to execute this again, and this time we're going to use a UDF that's built into the Spark connector that can use feed ranges in order to select just the parent key values, and that's much more efficient. So you can see the advantage of this. But what I really wanted to show is now that I've wrangled my data using the power of Spark and I've got a data frame that I want to work with, of course, I can convert this Spark data frame to a Pandas data frame. It's interoperable. And so this opens you up to all the nice stuff that you can do in Python that you're probably much more used to with things like matplotlib and other packages working with and analyzing data in Python. All right, so that was a whistle-stop tour of using Python with the Cosmos DB SDK and the Spark connector. Some key docs here. I already mentioned that the Python SDK docs, and also there's a tutorial there for diving into PySpark with the Cosmos DB Spark connector, and there's a link for our community stuff as well. Also, some other very useful links: how to set up Copilot with Python, which you saw me doing at the start. The demo app for all of the latest Gen AI related search features that we've released, our docs, the very important data modeling, and even more important partitioning documentation, which you should definitely review if you're working with Cosmos DB for the first time, the awesome gallery with all of our samples, and of course throughput control. If you're going to work with the Spark connector, you definitely want to check that out. Yeah, that's everything I had. How did I do for time, Jay?
You have exactly 3 minutes left, and that is perfect. We have a couple of questions, and awesome. They come from a really, really wonderful person in Pamela Fox. I answered this, but I'm going to let you answer it as well. If your container is small enough, all your logical partitions may theoretically be on the same physical partition, correct?
That is correct. Yes, logical partitions aren't one-to-one with physical. You can have many logical partitions on the same physical partition. And in fact, for small apps, what I was talking about with the cross-partition queries isn't really a concern. It's only when you start getting to, I would say, more than 100 gigabytes of data where you're spreading across 3, 4, 5, maybe 6 physical partitions, then it can start to be a performance bottleneck. But for sizes of up to 20 GB, or less, then it's going to be fitting on one physical partition. Yeah.
Great. Another question: does the full text search use BM25 or a similar algorithm?
That's a good question, and I don't know the answer. But James Codila, who is presenting later on building scalable Gen AI applications, will certainly have the answer to that question.
I love that transition, Theo, because I was going to say, and if you haven't heard what you need to hear today, you're going to be able to hear a little bit more advanced stuff with James's talk. And then we've got one more. What are the usual use cases for Spark with Cosmos DB? Is it analytics processing, IoT sensor data?
Yeah, I mean, it is heavily used for machine learning training, I'm told, but I have to say most of the use cases that we've seen with Cosmos DB is really for large data movements. So if you need to move data from one container to another, let's say, or you need to move data from Cosmos DB to an analytics data lake, let's say, and you need to do transformations in between, perhaps, as well. We're seeing a lot of that kind of usage, and also streaming scenarios as well, and streaming at scale, and then doing transformations and projections while you're doing that as well. So we do see a lot of that, and we do see quite a lot of people using PySpark as well. I think because Python is so popular in the analytics space, and because Spark is so popular with doing analytics at scale, this is a pretty popular thing. So I just wanted to call it out that this is something that you can do with Cosmos DB pretty easily.
Fantastic. And so I know that we're short on time. I want to give one more question because I think it's really interesting. Douglas asks, this may be off topic, but he noticed that you're using the Cosmos emulator, and he normally develops in WSL. And I was curious, or he's curious if you can connect to the emulator from WSL.
Can you connect to the emulator from WSL? You should be able to connect to the latest emulator from there. I know we've had some problems with that with the old emulator, but if you can't, then I would definitely ask you to go to the repo for that emulator. I don't know if I even shared that in the. I think I did share that in somewhere in the slides. So yeah, go to the repo. Raise an issue if you can't do it, because we definitely want to fix that, because we're spending a bunch of time improving that. It's in preview, and we want that to be awesome for developers.
Fantastic. Well, Theo, I wanted to say thank you so much to you. I'm very lucky. I get to hear a lot about this stuff from you directly all the time, but to be able to share that with everybody on this stream is really, really helpful. So thank you so much, Theo, and look forward to hearing more from you in the future.
Awesome. Thanks, Jay.
Take care. Well, we had another great talk, and this time focusing on one of my favorite things, Azure Cosmos DB. And just to remind you, if you want to try out Azure Cosmos DB, this is the part of the show where I shill for my product. Anyhow, if you'd like to check out Azure Cosmos DB for free, try right there. And also, as you're watching today's show, if you have questions from our presenters, or maybe you just want some general information from the rest of the audience, go ahead, leave your questions in the chat. We'll try to get to them as quickly as we can. Now we have our next talk, and we've got two presenters for you, and they're going to be presenting transforming AI development in VS Code. So I'm going to bring up Jide Shang and Rong Lu. Please, I hope you both, my pronunciation is right. I think one of you are using audio. Let me take a look. Yeah, I think you both are have your audio turned on. So one of you might have to put in, because it sounds like you're in the same room. So one of you might have to put on headphones or just mute your microphone while we're talking. Okay? Or mute your speaker. Anyway, I think we got it that time. Thank you, Jide. I appreciate it. Anyhow, let's go. Oh, there's some weird echo here. Let me see if I can fix that. Okay, there's that. Yeah, because it's echoing from one person's speaker to the other. So when one of us is, when one of you are live, you might want to just mute your speaker and listen to what the other person's using. Cool. All right. I think we've got to the point where we're ready to get started. I think, Jide, you have the presentation. Is that right?
Yes.
Okay. Why don't you bring that up, and we can get started. And as a reminder, oh, that was some recursion right there. For those of you who are developers, you might run into that problem once in a while too. Anyway, I'm going to hand it off to the both of you. Just be mindful of that echoing problem that we ran into. But anyway, handing it off to you. Thanks.
Awesome. Thank you so much, Jay, for the introduction. And we are really, really happy to be here for the opportunity to share with you some of the tools that we're building in Visual Studio Code for AI development. Quick self-intro, my name is Rong, and I am a PM here at Microsoft, focusing on building Python, data science, and AI tools. And with me is Jide.
Yeah, my name is Zidi, also a product manager at the Microsoft Developer Division, working on the AI tooling stuff. Nice to meet you all.
Thank you all for tuning in. So before we get to the tools, I just want to take 1 minute to briefly talk about what we have been seeing in terms of the evolution of this new role, which we call AI engineer. Once upon a time, we have three roles here showing on the screen. Once upon a time, there are traditional roles that we often see. On the left side of the spectrum, we have data scientists. They primarily focusing on training data, training models, fine-tune models, or evaluating models. And then we have machine learning engineers who focus on evaluating models and as well as deploying models. And on the right-hand side, we have software engineers who focus on customer-facing applications. And with the rise of ChatGPT, which happened 2 years ago, we started to see a new role emerging, kind of sitting in between machine learning engineers and software engineers, whose responsibility, interestingly, largely overlaps with both roles. You can see some color coding here, but they actually have to, take care of not only machine learning engineer responsibilities in terms of evaluating models, fine-tuning models, but also software engineering job responsibility in terms of building applications, getting them to production, and all that. And on top of all those responsibilities, they also have some new skills these AI engineers are picking up, primarily around prompting engineering. How do you interact with models? How do you evaluate the responses coming back from these models? So all this coming up together poses absolutely new challenges for AI development, which is why we have been looking at, in this new world, how we can build tools to help make AI development a little easier. So just stretching out the kind of the AI engineers' responsibilities in a slightly different view, we really want to be providing a helpful tool that can help developers in their entire development cycle, starting with exploration and move on to deployment, and then evaluating the responses or your AI applications, as well as getting everything all set up in a consistent and nice way in your CI/CD pipelines. So with that goal in mind, we started building this new tool we call AI Toolkit for Visual Studio Code, which is a VS Code extension. This is still relatively new. It's been out for only a few months. We're only at the beginning of this journey, but we're really, really glad to be here to show you some of these tools, features we have built into the tool, and a sneak peek of what's coming up. So over to Judy for showing a demo live.
Yeah, if you can hear clearly, I don't need to unmute myself, right? So, all right. So next, I'm going to give everybody a demo, a cool demo. I personally like it so much. It's just showing how to leverage the AI toolkit to help me bring some ideas in my mind into something really working. So the scenario is like, I personally have a hobby to do some programmatic trading. So I often found that X.com is quite useful. Let me show you some example. Yeah, this is X.com. So whenever I search like a stock ticker, like a QQQ, it put a lot of the messages to me, either from the individual, from big influencer, from media, or even from some company. Every single message has its own sentiment, either positive, or negative, or neutral. So all these information, if I can read a lot of these messages together towards a common stock ticker, it can help me easily to position the sentiment direction, which in turn will help me to easily to position whether the stock will rise or will fall. So I can help me to decide my personal trading strategy. So with all this information, I really get an idea, like I want to bring this into an AI-powered app to help me to automate a lot of these things. But because I'm just started, so I don't have a paid subscription for X.com data feed yet, but I do have a screenshot. I can easily make a screenshot of these messages. And hopefully I learned a lot of the capable multimodal AI models can help me understand the content inside, and probably can help me understand the sentiment inside that. So in order to do that, I try to search as a developer. So search the search engine is the first step. So I know how to program, how to deploy my app into Azure. But the thing is, I'm still relatively new to AI app development. So I search and find is really good resources from Azure AI app template gallery. So when I look at this gallery, immediately I found something quite relevant, like this one, multimodal Gen AI experience, asking questions on uploaded images using the GPT-4o. I think this is probably exactly what I'm looking for to get started. By looking at that, it's indeed, yeah. It's basically you can upload a screenshot or image and together with your question, and hopefully the multimodal can give you some responses. But in order to test out this capability, I found that really complete architecture, like for deployment on Azure. But at this moment, I'm just get an idea. I really want to do some POC first by myself. I'm not ready yet to really bring into production quality, deploy everything on Azure yet. So that's what I can do with the help with the AI toolkit Ron just introduced. So hopefully I can duplicate a lot of things just to show in that particular demo. So I can install this AI toolkit from the VS Code marketplace. So once I install it, I can find the entry point on the sidebar. There's a AI toolkit icon. So once you click that one, on the left, that's all the information, all the entry point, all the functionality you can look at. I will start with the models because I know they are using the ChatGPT-4o to do some image analysis. I quickly going through that one. I found pretty much all the most popular AI models are available. So for me, I know I'm going to start with the one published by OpenAI, which in that particular example is the GPT-4o. I found two. One is hosted by OpenAI itself. The other is hosted by GitHub. Let me try the OpenAI first. Oh, it's asked me about the API key. Seems like I don't have my API key at hand at this moment. So I tried the other one, the hosted by GitHub. Bingo. So within just a couple seconds, the model GPT-4o via GitHub is successfully loaded. So now it's even showing this pin icon. So let me try that. Okay, because before the demo, I already downloaded exactly the same image like in that AI app demo, the sample app. So I insert that one. What does this code do? Using exactly the same question. See what I can get. Yeah. It actually, just based on the image, it can analyze the content within the image and give me a expected result, actually even richer than what I can see from that sample app. So that's great. Now I get a little bit of interest. Let's see, if I choose another AI model, vision model or multimodal model, whether I can just get a screenshot from x.com and get the image analyzed the same way. So I previously download a lot of things, but I can also go to model. So let me see. I've been hearing a lot of good things about Meta model. Okay, that's a publisher from Meta. I can find one Llama 3.2 vision. So let me try this one first. Okay, model loaded into the playground. So now let me do something here. So attach an image that I just screenshotted from the x.com. Because I want to do some sentiment analysis, I really want to see, based on the message, what kind of, what a sentiment is for a stock picker I'm interested in. Okay, immediately it can analyze the image in the same way and detect the sentiment, which is a positive. Let me see whether it's doing the, yeah, markets on the rise. QQQ lead with the gains of 2.52. It correctly, successfully analyzed the whole thing. So I don't need to write any single piece of code yet. So I can just working on the prompt all by myself, tweaking all the parameters and talking to a certain model. But now let's say I can move to the next stage. So I know how to get the multimodal AI model to help me to get information from the image. Now, how about if I already get a ton of x.com images for a particular stock taker? Is there any way I can do it instead of manually do it one by one? Can I do it in a big batch mode? The first thing is, if I switch to some other model, whether I can do it directly in the interactive way first. Let me try it. So I remember I have an Llama model downloaded on my local machine. So I want to add that. And I found this simple, add a model from the playground. Also from the model catalog, I can also find the similar thing. Or on the my model, which is already ready in my local machine. So I can add Llama model. I can select. Okay, automatically detect. Okay, that's my previous downloaded on my local machine. So because this one is also important, because sometimes my app maybe have some data security concern. So I don't want to send a lot of sensitive data or information to the cloud directly. So let me start with some local, totally local. This is a local Llama running on my local. Maybe I get some messages already. Let me see. Okay, this is the one I copy pasted. Let me tell me the sentiment for this. Yeah, local model typically takes a few seconds to fire up. Still thinking. Okay, now it's coming out. Sentiment to be neutral with a slightly negative tone. Okay, good. Now I know if I bring the model totally locally, it can still do the thing. Yeah, so which is great. Now I just mentioned, so I happen to know there's a good source on Hugging Face with a lot of the publicly available data set, where I happen to find a quite a relevant data source called the Twitter Financial News Sentiment. That's exactly what I'm looking for. It has more than 10,000, almost 10,000 rows of data with all the messages, all the tweets, and with some manually curated or annotated result, like in numerical way. 0 means negative, 1 means positive, 2 means neutral. So let me try to, I already download that one to my local machine. I will see how can I leverage that whole thing to do some batch run, like in a much bigger scale. So let's take a look, because that's the whole 10,000. Obviously, I cannot use all of them. So I adopted only partial of the data. And if you really want to look at the detail, you can even right-click on that particular JSON-L file, open with another extension, cool extension, called the Data Wrangler, where you can do all the editing, summarizing ETL for your data, which is really handy and useful. So here I'm going to use this one. Now I'm going back to the AI Toolkit. I found the batch run. Okay, so now I can do import a data set. So where I get this 20 lines of data adopted from that giant data set. So now it's loading the batch run. And for the performance concern, I already deployed a base model of a GPT-4o mini on Azure using the AI Foundry service. So I can easily add that one into through our add a model feature. So I only need to provide the endpoint and the access key. So now let me try to do that. So okay, now I loaded that one. I can either run through all of them, but I can also pick individual one to run to see what kind of result. Okay, it runs nicely. I can pick anything, just let it run. And with that data wrangler or even the raw data, I can easily change the prompt and let it rerun. But let me just save time. I just showing this one here. But reading about the output, it has nothing to do with the sentiment. So usually I can offer in the playground, we can tell like generate sentiment for each message. This is the system prompt. I can easily add, I can also change a lot of other parameters. Let me rerun this thing. Okay, it's much better. Right now it's much concise, like a sentiment negative. I run another one, sentiment positive. Okay, almost there. But I really want to be able to integrate the whole thing with my existing stock trading algorithm. So I noticed that data set can be used for fine tuning. So now I'm going to do some quick fine tuning work. So, okay, starting from the AI toolkit, doing fine tuning is very straightforward. You give it some name, pick a location, and pick a model, maybe Llama v3, click a config. Within a couple seconds, they will ask you for more information. By default, all these fine-tuning will be sent to Azure, leveraging the Azure Container App to do all the fine-tuning. But it's optional. If you have a local GPU, you can also do some of the smaller model locally by checking this. And you can choose what data set for the training. You can use the default, the sample one, or uploading the local file, or add from a Hugging Face by specify what kind of a schema it has. Then after this, you just generate the project. It will create everything for you automatically. And with this created project, it already contains the data set, where here is a sample data set, and some infra needed to deploy to Azure. So you just fire up the command palette, AI Toolkit, where you can find AI Toolkit. where you can easily do the fine tune. Just a sec. I cannot find that information. But anyway, so in the latest, because I'm using an internal build, but in the public build, you will easily find provision your fine-tune job to the Azure Container App. After that one, take about 5 minutes. Then you run the other one, run fine-tuning. So after these 2 steps, it will take about multiple hours. You will get a fine-tuned model for you to use. For this particular demo, I already fine-tuned a model just to save time purpose. It takes hours. So here I also added that fine-tuned model deployed to Azure and added into our playground and used by the batch run as well. So now I'm switching to this fine-tuned model using exactly that older data set, which will expect to generate a 0, 1, 2. So that's a rerun something. This is negative 0. That's good. 1. Okay, I pretty much get all I need to do. It's a super efficient with this numerical output. Now I get all the model to use. What kind of the system prompt I already experimented. What kind of parameter I need to include in my application. So now if I redo my application, I can easily do a so basically I can easily incorporate all these information into a simple Python code with all these prompt and with the feed of a particular x.com message, it will give me a numerical value. So that I can easily to integrate into another pipeline to help me to do the auto trading. So wrapping up, there's some upcoming features we are also releasing very soon in a couple of weeks. For example, the evaluation. So right now, the feature is still very basic, but at least to give you a sense. For example, once you start a new evaluation, you will choose what kind of built-in evaluator, like a relevance or F1 you are interested in. Here, I just use the sample JSON file, which only contains 2 rows. Let me see whether it runs. Okay. Yeah, now I'm going to use a particular model I already previously deployed on the Azure and using the sample data, which consists only 2 lines. And now it's running the evaluation job using the model I chose as a judging model and running against the selected evaluator I put it there. So now it takes a few seconds to get the results. It's still running. Yeah, while it's running, so probably it will save some time. I can pull out some of the previously result, like which you can find in this evaluation job history, like my evaluation. So here are the sample queries, and with the ground truth, this is the the model returned the responses with the expected evaluator. So this way, you can also easily open in a data wrangler again. So to get a more detailed information, including the fancy charts, so for you to do the comparison. So with this, it's so easy to do that. Oh, my running job is also finished. I can check that one because I selected the relevance of one score, both generated automatically and can be opened in the data wrangler. So far, that's the demo I'm showing. So basically, using the AI Toolkit, I can do a lot of the prompt engineering and crafting the prompt, or help me to evaluate and select the different AI models easily. And I can use the result easily to port it into any of my other application to help me complete the end-to-end story. So that's all I want to show today. Thank you for watching.
Thank you so much. Really appreciate y'all doing a presentation today. We've got a couple minutes left. Do you have anything left to present, or would you be open to a question or two?
Maybe just a quick wrap up. So
Sure.
we just showed about how to test with the different models from popular sources, how to use the model playground with the image attachment support, how to do the batch run, how to evaluate your data set or model, how to do create a fine-tune job. And some of the feature is coming, like deploy models. And for the better support the app development, like how to export the code snippet, integrate models with your app easily, how to support the future outer loop, like deploy your stuff in the CI/CD or using the container. It will be coming very soon. So stay tuned, and hopefully you will find it useful. Yeah, we can go into the Q&A stage.
Sure. Douglas would like to know, can you use models from LM Studio as well as Olama?
Right now, Olama models are all supported. For the Studio, it depends because we also support the custom model or bring your own model. So the requirement is as long as the API contract is similar to OpenAI flavor, but later we can expand that one as well. And you have the deployed endpoint URL plus the access key. You can easily add any external model to use together with the AI Toolkit.
Great, great. Appreciate it. I've got another question. Pamela wants to know, I wonder if the fine-tuning works with Mac GPUs, MPU. It'd have to be via a mix. Do you know if fine-tuning works that way?
Fine-tuning right now is working because it's using some of the standard like a QLoRa or LoRa scripts, which is CUDA-based, which only runs on the NVIDIA GPU for now. Unless there will be some other community-supported scripts to support other like a Mac GPU to do things, I think it's totally doable. In the next few months, we are also going to support the NPU fine-tuning leveraging the our Copilot plus PC from Microsoft. But since we can do that, I don't see any blocker to support more GPU types. But as long as we have that scripting capability, yeah.
Great. Well, I think we're all set for today. I want to say thank you to both of you for joining us. Really appreciate your time, your commitment to bringing out some really great information. I love VS Code. Everyone loves VS Code. So it's great to see more ways of being able to use it, especially building AI apps. So thank you both.
Yeah, thank you for
Thank
having
you all.
us.
Thank you for, yeah.
Bye-bye.
Bye.
Bye-bye.
All right, let's say goodbye. And we are moving right along. We've got a bunch more talks for you, but I wanted to just do a little bit of housekeeping and remind you, if you'd like to get more details on everything today, you can go right there, aka.ms/Azure-Day-24. You can get all the information from today's show. If you'd like to check out the Python Developer Hub, aka.ms/Python. Look how perfectly it lines up that I can do that. And then also, like I said, I'm an Azure Cosmos DB person, and I want to drive you to it. And so one of the things I want you to do is to try Azure Cosmos DB for free, aka MS. Try that way. Try Azure Cosmos DB. See, there I did it. Cool. All right. So you've heard enough from me and vamping and getting towards my transition. But I want to bring in someone that, one, I work with almost on a daily basis that is extremely just brilliant at what he does. So I'm bringing him in. Hey, James, how are you?
Hey, Jay. Hey, I'm doing well. How are you doing?
Good. It's I don't know how you're out in Connecticut. I'm in Brooklyn, and we're having a really bad day on the weather-wise, but we're having a great day talking about Python.
Yeah. I see a little bit of sun coming out now, but
yeah, little flurry here.
Yeah. I think you've had a bunch of great guests on today talking about building applications, building AI applications, which is really exciting. So I'd love to talk a little bit about how you can do this with Azure Cosmos DB as your data source.
Well, you got no complaints from me about that. I'm really interested in hearing what you got to say because you always have some interesting things to share. So I'm going to let you get to it. If you have questions, please put them in the chat. We'll make sure that if there are any links to documentation, those get dropped in too. So with that, James, please.
Cool, awesome. Yeah, so I'm really happy to be here today. I'll talk a little bit about building scalable generative AI apps with Azure Cosmos DB. I'll start with some introduction to Cosmos DB and what it is, and some use cases for Cosmos DB in AI apps. And then we'll move over to some of the latest announcements and new developments we have that enable Python developers and all developers really to build AI applications easier with Cosmos DB. And then we'll dive right into some demos. I have a couple of Jupyter notebooks lined up where we'll see vector search at enormous scale and also some of our new text search capabilities. So let's get started. So at Azure Cosmos DB, we're building the universe's best database for AI applications. Primarily today, we're going to talk about Azure Cosmos DB for NoSQL, right? So this is sort of our main product for Azure Cosmos DB. And Cosmos DB is known for being an incredibly scalable, high performance, highly robust, high reliability database. We have two different models for Azure Cosmos DB for NoSQL, right? So we have a serverless model. So for Azure Cosmos DB, you essentially pay for compute. And the serverless model, you only pay for what you use. So if I want to provision, 1 million request units, I can use those to my heart's content just for those request units. Or I can have a provision throughput model. So in that model, I pay for compute per time unit or compute per second. And this is really good if I want to take advantage of our instant and dynamic auto scale, right? So Cosmos DB will automatically scale out or in, depending on your traffic and data needs. And it can do this instantly. You can do it dynamically, which is really exciting. I mentioned that Cosmos DB is known for its high throughput and low latency transactions. So we have an SLA for point reads and writes to the same region as your application of under 10 milliseconds, which is really world class. We have a high availability option for 5 nines of availability. And what we'll talk about a little bit more here is the ability to store your data and your vector embeddings in a vector search use case together in the same data item or same document, right? So Azure Cosmos DB is a NoSQL database. So you can think about our data items sort of like JSON objects. And a JSON document has different properties. And a vector embedding is just a list or an array of numbers, right? Floating point numbers or integers or similar. And so in Azure Cosmos DB, you can store your metadata and your vectors together in the same data item, which is really powerful, right? You can store your data in all your data for your AI applications in one database without having to provision a separate vector database and do that. And we have built-in vector indexing and search in Cosmos DB. And this features our DiskANN vector indexing suite of algorithms that was developed at Microsoft Research for vector search at enormous scales. So really, really great value propositions for why you might want to use Azure Cosmos DB for NoSQL to power your AI applications. As I mentioned, we have a serverless option, and it's really great to get started. It's good for multi-tenant applications or unpredictable traffic, but it's also really good for development or POCs, right? You only pay for what you use, so it's really easy to get started and it's really cost effective. I mentioned our instant dynamic auto scale. So this is also really powerful. So Azure Cosmos DB automatically shards and partitions your data for you. So you don't really have to worry about that. And what's really great is that Cosmos DB can scale different partitions in different regions accordingly, given the traffic demands. So you don't have to wait. You don't have to worry about what happens if I have a hot partition or hot region, or is my database going to scale efficiently? The answer is yes. Azure Cosmos DB is going to scale not just instantly, not just dynamically, but also really efficiently to save you cost. Okay, so let's get into some of the AI use cases that we have with Cosmos DB. We have thousands of customers building their AI applications on top of Cosmos DB. And there's a variety of use cases here that we can talk about. Going left to right, we have the use case of storing your operational and vector data together in one place, right? So storing all your data in one database removes the need to ETL your data into a separate data store, can help you maintain consistency in your data and reduce the complexity of your architecture. Built on top of that, we have lots of customers building retrieval augmented generation scenarios, right? So getting data from the database and using it to personalize large language models for particular use cases. And this is really, really powerful. It's pretty easy to do in Cosmos DB, and it's much, much cheaper than fine-tuning a model, right? Additionally, we have thousands of customers who have built out conversation or transactional histories in Cosmos DB. So as you're talking to your chatbot, if you've developed a chatbot application or even a multi-agent scenario, you may use conversations so that way you have your application has awareness of things you've talked about in the past. And Cosmos DB is fantastic for this. There's other use cases as well, including semantic caching. And in semantic caching, the idea is if you're already storing chat history in Cosmos DB, you can also vectorize it. So create a vector embedding that describes the chat history or the previous answers from large language models. And in your chat application, if you have users asking questions, maybe a user is asking a question that's already been seen previously, right? So instead of having to prompt your large language model and wait for a response, which could be costly in terms of time and money, what you could do is just do a super efficient, really cost-effective vector search in Cosmos DB instead, and pull a historical response that's stored in the database. And you could leverage that instead of having to call out to your large language model API. So this is really powerful because it reduces latency on these sorts of transactions, saves on token consumption, so it saves you cost. It also reduces latency, right? Doing a vector search in Cosmos DB is much, much faster than, say, waiting for a response from a GPT-4 model. And finally, we also have AI agents. So multiple AI agents working together to perform complex tasks. It's become really, really powerful and very, very popular lately. And so having a data store to log all of these agent-to-agent transactions or the statefulness of agents is actually a really great use case for Cosmos DB as well. And as you can see at the bottom, we have tons of customers using Cosmos DB for these AI applications today. Probably most famously is OpenAI. Right, so ChatGPT scales with Azure Cosmos DB. They have more than 40 workloads running on one database in Cosmos DB. If you've ever had a conversation with ChatGPT, you can be rest assured that your conversational data is stored securely and efficiently on Cosmos DB as the backend data store for the chat history. So, really great use case with OpenAI showing the power and the scalability of Cosmos DB to be able to handle hundreds of millions of users per month using the world's most popular large language model application. Okay, so we talked a little bit about Cosmos DB and some of the use cases. We had several announcements over the past month or so at our Ignite 2024 annual conference. And these are all, a lot of these announcements have to do with building generative AI applications, right? So we were super happy to announce the general availability of vector search using our disk-ANN-based vector index in Cosmos DB. So you can be rest assured that you can do vector search in a robust manner at scale in Cosmos DB and have confidence because this is a generally available feature in the database, right? So when you do vector search in Cosmos DB, you get lots of stuff, right? We talked about the ability to store your data and your vectors together, but vector search in Cosmos DB is just another part of our query syntax, right? It's a system function that leverages a vector index data structure on the Cosmos DB backend. And so you can easily combine query filters with your vector search operations to hone in on the right vector search or the right results that you're looking for your application. We offer multiple types of vector indexes. Like flat, which is a KNN-based method, or quantized flat, which is a compressed form of KNN-based. But we're really excited about our disk-ANN-based index because it enables low latency, highly scalable workloads to run on Cosmos DB and take advantage of that in vector search. And of course, everything that we're going to talk about here is built on top of the Cosmos DB core value propositions, right? So what I talked about earlier about the serverless or provision throughput, our low latency for point reads, our global replication, our instant dynamic autoscale, or high availability. these all come with, these are all compatible with our vector search feature, right? So you can rest assured, you can be very confident and be rest assured that Azure Cosmos DB is an incredibly scalable and robust database that you can also do vector search in very quickly and efficiently. I talked a little bit about disk ANN. I'll probably just leave this up here, and you can go check out our white paper for more details. But disk ANN is really sort of the crux of what enables the full leverage of the Cosmos DB backend for low latency, highly scalable vector search, right? So the idea is compared to most vector databases today, which use in-memory indices, disk ANN leverages memory on the compute, but also our high-speed SSDs, which make up the backbone of Cosmos DB storage. And the idea is that you have compressed vectors in memory and a full fidelity uncompressed vector graph on the high-speed SSDs, and efficient algorithms for constructing the graph data structure for the vector index. And these combined lead to very efficient vector search at any scale using Cosmos DB. So I encourage you to check out our white paper and learn more about disk ANN in Cosmos DB. So in addition to vector search, we're also really excited to talk about, we now have full text search and full text ranking in Cosmos DB. So you can do full text search and leverage a full text index with a bunch of different text analyzers, and also rank documents based on their BM25 score, right? So BM25 is a standard, industry standard way of computing the relevance of different documents according to the frequency of key terms or phrases in the documents. And so we are super happy to announce this in Cosmos DB, and it's currently rolling out to all the Azure public cloud regions as we speak. Now, combining full text search and vector search, you get hybrid search. And in hybrid search, you are able to have improved relevancy for your search results, right? So if I'm searching for text, I may want to use vector search, or I may do a full text search or use this BM25 scoring. You really unlock a whole ton of power by combining the two for more relevant search results. We can see in this example query, it's super easy to implement as well in our query syntax. Okay, so I've talked a lot about Cosmos DB. So we talked about Cosmos DB Core. We talked about generative AI use cases and some of our exciting announcements at Ignite over the past few weeks. What I'm going to do now is cut over to my VS Code, where I have a couple demos to show you. So let me minimize this, and we'll go right here. Cool. So here's my VS Code window. Let me minimize that a little bit. So what we're going to do here is I have a Cosmos DB collection set up with 100 million vectors. And we're going to see how quickly Cosmos DB can do a vector search across these 100 million vectors. So all I'm doing here is loading some of my Python packages. And you notice here that we're going to use our async client for Cosmos DB, right? So I mentioned that Cosmos DB will automatically shard and partition my data for me, which is great. So in this scenario where I have 100 million vectors in one collection, Cosmos DB has automatically sharded my data into 8 partitions. So what I want to do is I want to use our async client, so that way I can execute a vector search query and it will hit all of the partitions simultaneously. So I'm going to go ahead and load those packages. And then I have a helper function here. So what I'm going to do is I'm going to print out a couple of things from our query metrics. We're going to look at the execution time on the database. So how long did it take my vector search to complete? We're going to look at the RU charge for the vector search. So remember I mentioned that Cosmos DB, with Cosmos DB, you pay for compute, and you pay for compute in terms of RU or request units. So we're going to see how many request units this costs. And then we'll translate that into US dollar amounts based on our Cosmos DB serverless option, which is a really great way to get started. So, okay, so I have the helper function done. Now I have my connection details already in an environment file. So I'm going to go ahead and load those. And then I'll connect to my Cosmos DB database and collection here. Now I have a sample vector that I'm going to do a search on. So I'll load that. And now we're ready to go. So I have a function here for just querying different partitions. So I'm going to go through each partition and run the query. And then I have another helper function here to make use of our asynchronous client, right? So I'm going to connect to our Cosmos DB resource with my credentials, our database, and our container. And then I'm going to hit all the partitions simultaneously and get the results back. So with that helper function. And then here's an example of the query I'm going to run. So I'm going to select the top 10 items. I'm going to project an ID for the document. And then I'm also going to project the vector similarity score. And I'm going to order by the vector similarity score here. So this will leverage our DiskAN and base index for really efficient vector search. So we'll go ahead and load that. And okay, so now we're ready to go run our query. And so we'll go ahead and run that. And the results came back super fast, right? So we can see here are some of the results that came back. I can see the ID, I can see the vector similarity score. And again, these are based on the Euclidean distance metric. So lower score is more relevant here. And so I can see that the lowest score is up top and the scores increase as we go down. Taking a look at those query execution metrics, here I can see that on the Cosmos DB backend, it took 37 milliseconds for this vector search query to run. That is incredibly fast, right? So 37 milliseconds for it to run across all the 8 partitions on 100 million vectors, really fast. I paid about 164 RUs here. And translating that into dollar amount, right? This is $0.0000409. So translating this into something that's a little bit more tangible. When you do a vector search and generate embedding, say with Azure OpenAI, that has a certain cost associated with it. Just generating the vector embedding itself. This vector search costs about a quarter of that price, right? So it's extremely, extremely cheap. You don't have to worry about vector search being some part of your generative AI pipeline that's going to be high latency or that's going to be expensive. With Azure Cosmos DB, it's going to be low latency and also incredibly, incredibly cheap. So really, really cool, really, really powerful. I encourage you to get started and check it out. We have some resources for you at the end of this, so you can go take a look. Okay, so we saw an example of vector search at high scale. Now what we're going to do is we're going to switch gears into another notebook. And I'm going to show you a few of the different search methods that we have today in Azure Cosmos DB. So we're going to cover full text search. So we'll look for documents in our collection that have particular key terms that we're looking for. And then we'll do a full text search that's ordered by our BM25 score. So we'll do a ranking based on this BM25 score and see what the results look like. We'll do a simple vector search. And then we'll do a hybrid search. So this is the vector search combined with the BM25 score. And these are fused together using the RRF function, which is a pretty standard way of combining multiple different search methods. And we'll see what the results look like in all these different ways. Okay, so we'll get started here. I'm going to go ahead and load my Python packages. And just like before, I have an environment file with my connection strings, so you don't have to see those. So we'll set up my connection details here. And then I have a collection that's set up that has a whole bunch of different scientific papers, right? So it has thousands and thousands of scientific articles from archive.org. Has the titles of these scientific papers, has the abstracts, some data about when they were published, some data about the authors. And I've also gone ahead and created Azure OpenAI vector embeddings for these papers, right? So I did this a little while ago, so I was using the Ada 2 model. If you're going to do this now, I'd encourage you to use the text embedding 3 large model. But we'll go ahead and still do this with our Ada 2 model. Okay, so now we'll connect to our Cosmos DB resource and to our Azure OpenAI resource. Now, I've created just a little helper function here for creating the vector embeddings from Azure OpenAI, and this is just to make my life a little bit easier later on. So let's take a look at some of our search terms now, right? So we're going to search for academic papers that contain the terms quantum particles and electron interactions. And we'll also create our Ada 2 vector embeddings from this because we're going to want to do vector search and hybrid search later on. And then we'll also split these terms into individual this string into individual terms, so that way we can do our full text search as well. Okay, so we have a couple different ways of doing full text search in a where clause in Cosmos DB. You can use the full text contains if you're looking for a particular term. You can use full text contains all if you're looking for documents that contain all the search terms that you're looking for. Or you can use full text contains any if you're looking for documents maybe that contain at least one of these key terms that you're looking for. So I'm going to use that here. So what I'm going to do here is I'm going to query 5 documents. I'm going to project the ID, the title, and the abstract. Remember, this is a scientific paper, so I want to see some details about it. And then I'm going to use a where clause and use the full text contains any clause here. So I'm going to go ahead and run that, and we'll look at what the results look like here. Okay, so here I can see my results. They're not ranked in any particular order, right? I don't have an order by in my query. I can see that the results maybe contain some of the key terms that I was looking for in the abstract, right? So here I can see in the abstract, I have a couple of the key terms that I was looking for, like as you can see, I have like quantum here, and this one I can see that I have a few of the key terms as well. So that's really interesting, right? So what I can see here is that when I'm searching for a document, right? When I'm searching for a document in Cosmos DB, if I use this full text contains any clause, I'm sort of guaranteed to find documents that have at least some of the key terms that I'm looking for here, right? So that's really cool. But maybe I want to see if I can do better, right? Maybe I want to order by some relevancy of my key terms. So I'm going to go ahead and use the full text ranking method here. And so instead of a where, so if we scroll up here, we can see, right? So I did a where clause full text contains any. So here I basically want to find documents that contain at least one of the keywords. Here I'm going to use full text score, and instead of a where clause, I'm going to use it in the order by clause. And what this is going to do is rank the documents in order by their BM25 score. So essentially, the documents that have higher relevancy according to BM25, and BM25 takes into account what again? It takes into account the frequency of the terms, so how often they appear in the document, but also takes into account the length of the document itself, so how many other words are in the document, and it also takes into account the frequency of those terms across all the documents in my data set, right? So words that are maybe really rare, maybe are more important, so maybe I want them ranked higher. And I can see this actually looks really cool, right? I can see I have particle, I have electron, I have electron. So this looks interesting, right? I can see that I actually have a lot of these key terms here in this number 1 document. And as I scroll down, the idea is the documents get less and less relevant. So if I scroll down a whole bunch, I can see that here maybe I have fewer of those terms. Okay, here I have particles, here I have interactions, here I have interaction again. But this document is maybe less relevant than the document that comes up top, right? Because again, of that BM25 score about the importance of the key terms that I'm looking for. So
hey,
that's pretty cool.
Updating you on time. Got about 5 minutes left in your session.
Cool. Thanks, Jay. So I'll finish up here real quick. So this orders my documents by that BM25 score. I can also do a vector search, which we saw previously, and this orders my documents by my vector similarity score, right? So the ones with the highest score, this time I'm using cosine similarity. So the highest score comes up top, and then it's sorted in descending order with vector similarity score. But if I want to combine the two, the BM25 score and the vector similarity search, I can do a hybrid search. So here I'm selecting, again, my documents, I'm projecting the vector similarity score. This time I'm ordering by the rank of the RF score, and RF score takes into, or RF function takes into account 2 scores, the full text score and the vector similarity score here. And when I run that query, now what I can see is that my results are not necessarily ordered by vector similarity, right? Because this one is 0.86, but this one that's ranked higher is 0.85 from vector similarity. from the cosine similarity. But what this does is it takes into account both the vector similarity score and the BM25 score and fuses them together for higher relevance. So in the hybrid search, we see this 2-particle scattering matrix article is the one that's most relevant to my search query. But if we look at the vector similarity score, we see this one about nanocrystals is the most relevant to my search query. So this is just an example of how you can do different search methodologies in Cosmos DB and how hybrid search can really improve the relevancy of text that you're looking for, especially if you have a use case where you have lots and lots of text that you have to search through, or many sort of diverse types of data items that you're searching for. And you really want to find the ones that are most relevant to your AI application or to your query. So I think that about wraps up what I wanted to show here. Let me switch back to my slides real quick. And then I will just mention really quickly here that we have multiple integrations with your favorite large language model orchestrators in Python, including LangChain, Llama Index, and PromptFlow. I already did the demo. And if you want to try the demo out yourself, or any of these demos that I walked through, we have the Jupyter Notebooks sample code for you to check out at this first link. We also have our Cosmos AI samples gallery that you can check out here. Some documentation to help you get started in vector search and full text search. And then finally, I encourage you to go check out our DiskANN white paper if you'd like to learn more about the DiskANN method for vector indexing and why it's so powerful.
Fantastic, James. I got one question for you, if you got a minute. Cool. Pamela asks, if I need to store the text of a document and retrieve by an ID, what would be more performant, Cosmos DB or blob storage?
Yeah, that's a great question. So right off the bat, I would say it would be Cosmos DB, right? So if you know the document that you're looking for and you want to just query that document by the ID, this is just a point read in Cosmos DB. And if you remember way back to the beginning of my talk when I was mentioning all the great things that Cosmos DB does, and one of the things that we do is the super fast point reads, right? So we guarantee we have an SLA for 1 kilobyte point reads in the same region as your application in under 10 milliseconds, oftentimes even in about 5 milliseconds or less. So I'd say if you want to do something super fast and just do that document read like that, Cosmos DB can do that. Spectacular.
Well, James, I know Cosmos DB can do a ton. As someone that has worked with it extensively myself, I can say it's always great to hear someone else talk about what our team is building, what we're doing. And so I appreciate that. I know our Python community really does, because they're using it and they seem to really appreciate just the flexibility and the simplicity of just putting their data right in the Cosmos.
Yeah, absolutely. Yeah, we have tons of Python developers, and we're always looking to make improvements and offer more support and materials for our Python developers. So I'm a Python guy myself, so this is sort of my bread and butter. It's where I feel most comfortable.
Awesome. Well, James, thanks so much for today. Really appreciated hearing everything you had to say. And I know that our community, our viewers today, they all loved it. So thanks so much.
Cool. Thanks, Jay. Glad I can join you.
Absolutely. Well, there goes James. And we've got more sessions coming. I mean, geez, we've got so much incredible information for you today. I don't know how I'm keeping up, but somehow or another I am, and I'm learning all about how Python and all these other technologies work together. So we've got someone else coming up next that's going to be doing exactly the same thing. And I feel like, you know what, I'm going to say that 100 level content tends to be near and dear to my heart, because we need to bring people in. And by doing that, sometimes you need to give them a way to start. And that's exactly what our next speaker, Rohit, is going to be talking about today. Hi, Rohit. How are you today?
Hi, doing great. How are you?
Good, good. You know, I'm so thankful that I've been able to speak to all these people, see our audience, and hear all these amazing talks. And we just got another great one coming to us. And I know you're going to be talking about getting started, you know, Azure Absolute Beginners, I believe is what it's talking about today. You're talking about today. So are you ready to go?
Yeah, totally ready.
All right, so I'll let you jump in, and we'll see you. If you have questions for Rohit, please ask them, put them in the chat. We want to be able to make sure that your questions get answered. So with that, I'll leave you to start.
All right. Thanks so much. All right. Hi, everyone. My name is Rohit. I am a product manager here at Microsoft, and the title of my talk today is Python plus Azure for absolute beginners. Let's get started. So some prerequisites or some assumptions about you first. So first, I'm assuming that you can write Python code. You don't have to be an expert. You could be a student just learning. That's kind of the level that I'm expecting. Hopefully you can understand that, since we will dive into a little bit of Python code today. Second, I'm assuming, or the requirement is that you're new to the cloud. So I know that we've had plenty of talks today about really advanced cloud technologies and advanced level content. This is the exact opposite. So if you're a professional who's really familiar with the cloud and really wants to dive into specifics, this is more of a higher level and introductory talk. But if you're a student, that's perfect for you, because that's what I'm catering for. And lastly, I'd assume that you want to build skills and learn, hence why you're watching something like this. So with that being said, again, high disclaimer, it's very high level and introductory for this content today. Okay, so we're going to start with computers, which is the first chapter of this demonstration, because we are talking about computers. That's what Azure is, but we'll get to more details there. Okay, so let's assume that I have had a long day at work. I am very tired. I want to look at some funny cat pictures on my phone after grinding. So what I do is I use my computer or a phone to open up something like Instagram Reels or some other app that has content. But Instagram is a platform, and other social media or other content apps have a lot of content, like tons and tons of content, more than the 64 gigabytes that's on my phone. So what my phone or my computer will do is that it will send out a request via an interconnected network of computers, or that's just the internet. So it'll ask a bunch of computers, hey, send this over to the next computer, and so on. And it'll have a path that goes through the internet as a request, and it'll reach another computer somewhere, probably owned by Instagram, that handles all of the algorithm content, any sort of content like that that's being delivered. That's on Instagram side. And the computer on Instagram side will receive this request. It will determine what to return, and it will send back a response through the internet again. So that way, my phone doesn't have to store all of the bajillion bytes that are on Instagram's computers. It can just get the content from Instagram's computers whenever I send out a request for it. And now, after a long day of work, I can get my cat content just as I wanted. So the computer on this slide on the right is like a physical computer, similar to like the ones that we use, like desktops. Usually they don't look like this. Usually they will look like this, which is a more specialized computer designed to serve requests. And because they serve requests that are sent to them, they're often called servers. And you might have heard that term before. So these servers are running server software, which we'll jump into, but that's essentially how what computers can do for us. Other computers can control access to different content, can control access to what we get, and kind of send us information as we need. And that's usually how computers work over the internet. Now, it's awesome to have servers that can do what we want when we send requests to them, but there are some caveats. The first step is that computers are inherently tricky and expensive to maintain. Now, if you had a server of just your own for a server or for a user count of maybe one, maybe you'd only need one computer, and maybe more computers would not be necessary. But if you're running something like Instagram, you'd imagine you'd probably need a lot of those. So jumping into why computers are tricky and expensive to maintain. First, imagine having to build and maintain all of the computers required for something like Instagram. That's a lot of work. Second, if they break, it's on you to fix them. The servers would be down and you would have to fix them yourself. Third, you would have to keep spending as parts get better, and you can upgrade them over the years. Maintaining all of that is a lot, especially if you've built a computer before. You kind of get what I mean by this. And lastly, if I'm in Singapore and my server is in Brooklyn, New York, my request would have to go all the way physically to a computer in Brooklyn and all the way physically back, which would take a long time. If I have users in Singapore that I want to serve quicker, I could have a data center somewhere in that area, which would get the content faster. So if I have just my own computers, then I wouldn't be able to do that, because how can I maintain my own computers in Singapore, for example? Okay, so now that we understand what computers can do and why they're helpful, especially if you like cat content, now let's jump into why you'd want something like a computer service. So that's exactly what the cloud is. The cloud is just a computer service. And that means that I can just, instead of having to maintain my own computers, I can have someone like Microsoft maintain my own computers, which is through Azure. So here's the way it works. So first, I would pay to use Microsoft's computers instead of my own. Again, that's called Azure. Second, Microsoft will guarantee the security of kind of the application that I'm running. You know, this is a private computer. It's no one else is going to look at it. No one else is going to have access to my stuff, my exclusive cat content. They will take care of the computers for me via maintenance. And also, they have what's called an SLA. I'm forgetting the exact acronym for SLA right now, but it's essentially a guarantee for uptime. So if the computers go down, they will do their best and be urgent in taking it back up, which again, for me is really nice because I don't need to worry about that, which is stressful. Then once I have these computers that I can use, there's a various amount of compute services you can use. So there's a bunch, and we'll jump into the examples of those. And again, you can use that across the world. There could be Microsoft-owned computers in Singapore, in Brooklyn, wherever. It's a ton. Then here's the part where I think for a business, it's the most useful. So you can scale your compute or computer needs up and down depending on what you need. And most importantly, you only pay for what you use. So if I am running a store called November3rd.com, and every other day of the year, I don't have any requests because I'm not selling anything unless it's November 3rd. And then November 3rd, my store opens and I have a bunch of requests coming in, which are hitting my servers really hard. I can scale my compute up as I need. And also when it detects that it's no longer November 3rd, I can scale that down. So it's not like I need to have 3 bajillion computers on standby for November 3rd only. I can only scale it up and scale it down whenever I need. And this, obviously goes with the fluctuations of how much usage you get. And the best part, again, you get to only pay for what you use. So if you're running a business or a service, it makes sense to use the cloud as your computer service. You can save money because you don't need to maintain or hire people to manage all of that infrastructure. And then if you're a user, if I'm in Singapore, I have Singapore content ready, and that's much faster. It's just a better experience for users and saves money for business. So that's why you'd want to use the cloud. So we'll jump directly into cloud services, and they're different based on your goals. So first, there's infrastructure as a service. Then in the middle, there's platform as a service, and then software as a service, or SaaS. And as a service can be kind of tricky. Like, what does that really mean? You can kind of just think about it like something that you would use, something that you would pay for. So infrastructure, platforms, and software. So infrastructure as a service and platform as a service are services you can run your code on, meaning that you give your code to this service in the cloud. It can run it as that computer, whatever code you give it, it will run the code that you get, which is what we're interested in because it's Python and Azure Day. So we'll focus primarily on infrastructure as a service and platform as a service. So let's start with infrastructure as a service. IaaS is another way it's called. Some examples of that would be just direct compute or computers, storage, and the networking in between those computers. So if you have multiple computers in Azure, then networking between those. You don't need to worry about, like we said, the physical and the physical computer hardware. So instead of having to go inside a data center and swap out parts or replace things if things get broken, Microsoft would take care of that in Azure. But pretty much everything else with IaaS, you do need to take care of. So if there's a computer, what does it do? So you need to take care of the software running on those computers, like the operating system, for example. If you're running virtual machines, then you need to take care of virtualization. If you need to run anything like Java or something, you need to take care of, make sure those computers have the runtime to run Java, and so on. Additionally, you also want to take care of the scaling logic. So again, if you're running November3rd.com, you want to make sure that you have the logic where on November 3rd, it spins up a bunch of machines that you can use, computers in the cloud, and takes those down as well. And lastly, of course, if you're running server code or any sort of application, you obviously need to write that yourself and give it to and take care of that. So now that we've covered infrastructure as a service, we can jump into platform as a service. And some examples of platform as a service, or PaaS, are app hosting. So again, just like it sounds similar to an infrastructure as a service, but this time I don't need to worry about the actual computer. So I can just give my code and it'll host the app somewhere. You can also deal with messaging and functions. So functions specifically are like one-time bursts of compute. Like you only need to run a certain amount of code at a certain time or on a certain event. So for example, if I have a program I want to run every morning to pull down the site from the New York Times or something, then that would be a good use case for functions, something where I don't need a server constantly running only to run just once. Just one little bit of compute is all I need. If you know about Docker or containers, we won't jump into those, but if you know about those, you can also give your containers and run your containers in the cloud. And most popular and most recent and topical and top of mind for people is AI services. So something like Azure OpenAI Service would be considered platform as a service because it's just a computer you can have code run with a platform. So comparing it from infrastructure as a code to, or sorry, infrastructure as a service to platform as a service. First, you don't need to worry about the actual computer hardware. That's the same as IaaS. But also, you don't need to worry about the base software running on those computers. So you don't need to worry about what that looks like. You don't need to worry about how many machines are underneath there. It's all a platform for you to build your applications on. And I think for a beginner, platform as a service is a great start just because there's less to take care of. At the same time, you also do need to take care of your scaling logic and, again, any apps or server code that your computer runs. Okay. So there's something I haven't talked about, which is the biggest challenge for students and beginners. So companies, you can see why companies would want to use the cloud because it's useful for their needs. However, students and beginners have a ton to learn. And the secret part is you have to pay money for cloud services. This stuff is not free. And it, depending on your budget, if you're a student, it's definitely not going to be cheap. So that's where I jump into chapter 3, which is Azure for students and beginners. All right, here is a screenshot of the Azure portal. And I remember when I was first starting with the cloud on a different provider, but the same problem kind of exists. I was looking at this UI like, where the hell do I start? So the big thing here is that this software is made for professionals. The same way that like something like Ableton, if you're a professional musician, is made for professional musicians. If you're a beginner, you're looking at this and going, where do I start? What do I do? There's so many things I can configure. This is chaotic. And while it is good for professional workflows, if you're a beginner, I can totally acknowledge this is a headache. So we've actually worked on a tool here called the, one more cat meme before I go to the next slide. We've worked on a tool here called the Azure Developer CLI, or AZD. And it is an easy to use CLI, which stands for command line interface, and you can easily deploy apps to Azure via app templates. So if you've ever used a command line interface before, essentially you just type it into your terminal, and there's 3 key commands for AZD. The first one is AZD auth login, which you'll log into your Azure account and just kind of confirm your identity, make sure that you're the right person. Obviously, you don't want anyone just spinning up your Azure apps. The second one is AZD up, which is actually 3 commands built into one. The first step is package, which will get your code ready to be deployed to the cloud. The second command that's run secretly underneath AZD up is provision. So that will actually create the resources in the cloud. That's what provision means. And the third one is deploy. So now that you have those cloud resources being like computers or services in the cloud, you can then deploy your code to those. So those are actually 3 steps that's all conveniently located in one. So AZD up. And then once you're done, or once you're ready to take things down so you don't continue to get charged or continue your app from running, you run AZD down, and that'll take down all of those cloud resources for you. So there's no clicking through complicated UIs. There's no lengthy tutorials to follow. It's just a few commands, and you can have an app up in Azure in a jiffy. So personally, I think it's really great for getting your apps up to the cloud and just building experience as fast as you can. On top of this, like I mentioned, there's templates for AZD. So we have an AZD template gallery, and it is essentially just a collection of Azure templates that you can deploy in just a few commands. There are templates across programming languages, frameworks, Azure services, and more. And again, it's perfect for just trying out Azure services and getting starter code for your projects. I'll have links at the end as well if you're interested. Okay, let's jump into a quick demo. Okay, so here I am in the awesome AZD template library. Again, links at the end. But this is an open source template gallery to get started with Azure. And the cool part is that it's open source. So if you want to contribute and add your own template, you totally can. So this is Azure for Python. So I will click on Python. And I've heard of a few server frameworks for Python. I heard one easy one to get started with is Flask. So I can click Flask. And let's see, let's check the different ones out. This last one over here looks pretty good. And I like that it's in the free tier because I don't want to pay for things. So I can click on this. And there's the author, Anthony Shaw. there's the GitHub link, which I can click, and that'll take me directly to the repo where it is. And then it'll even have some template details, and it'll talk about the services used. So it'll be using Azure App Service, which is one of our platform as a service offerings on Azure. So just give your code. Don't need to worry about the machine underneath. Okay, so now that we're in the GitHub repo, there's a few ways that we can go to get this on our machine. So we can clone this, or we can use a GitHub code space. And if you haven't used a GitHub code space before, I would highly recommend it. You can just essentially get a computer in the cloud that you can interact with. Funny enough, this is actually an example of the last type of cloud service we talked about called software as a service, since you don't have to worry about the actual software running. But I've already made a code space, and it'll look really familiar to you if you use VS Code. Oh, I need to restart this code space. I waited too long. Let's see how long it takes. So this UI will look really familiar to you if you use VS Code. It's essentially just VS Code connected to a machine that's running in the cloud. And it's really nice because I don't need to worry about my developer environment, especially with Python. If you're a beginner, having multiple environments or even multiple versions of Python, it can be a headache. So I like to, especially for smaller demos like this, I like to just have a GitHub code space, and then I can have it up. And then if I want to take it down, I can take it down as well. Okay, so we have this GitHub code space. I need to add the Azure Developer CLI. So I can go to ak.ms/azd, and then I'm on Linux. I will copy this, head back to my code space, hit enter, and install this. Cool. So that's installed. So let's get that out of the way. Nice. All right. So there's a few steps I can run with the AZD. Again, I have AZD auth login. So what that will do, it will give me a code, and I can hit enter, and then it'll log me into Azure to actually run this. But I've actually already logged in, so I will skip that step. Then I can run AZD up. And unfortunately, I had a terminal here, but it disappeared when the code space automatically closed, which is good because I don't want to use up all my code space hours. It is free if you want to give it a try to start. I believe there's a pretty generous hour usage contract from GitHub, so you can use it for a while before you start to get charged. And it's per month, so it refreshes per month. So the next command would be AZD up, and I will run that here, but I will actually stop it. I just want to show the steps that go through when you run AZD up. So it will first look through all the infrastructure files, and it will then start the process of deploying and provisioning resources. So first, you can see the step AZD package being run. Then you can see AZD provision being run here as well. And then you can actually see the details for your deployment in the Azure portal. So if I click on this, it'll actually bring me to the cloud, resource deployment that's going on, or sorry, provisioning that's going on. And unfortunately, I accidentally ran this again. I did not mean to run this command, but it will take a few minutes. So whenever you run something like AZD up, you can just go get some coffee or something, go for a walk, because it does take a while for cloud resources to get properly configured in a way that's ready to use right away. So it will establish all of that. I didn't have a link ready because I thought this would still be here. Demos always go well. But let's jump into the code of the actual sample. So if you've ever used Flask before, you'll know that there's endpoints that you can hit. And this starter template just has a very basic one, which will just get the version of Python that's running. And I believe that for this app, this is Python. Actually, I'm not sure. Probably the latest. Let's see. This is going to take a while to deploy, though. So I'm not sure if we'll have time for that. Maybe by the time that we get to questions, then everything can be deployed. But that's essentially it. So once this deployment is done, again, 3 steps. I run AZD up, and then it automatically runs AZD package, AZD provision, and then AZD deploy. So this is the step that takes the longest and puts all the code up there and gets it ready to run. Once that's up, then I'm totally ready to go. And I can just copy paste any sort of any server code that I was writing on my own, and it becomes an easy deployment to Azure. And this is a super simple one. This has just the bare app.py for Flask. So there's like no actual complexity beyond just like a getting started guide here. But if I want any more templates that have more detail, I can actually just click around. And again, I have it filtered by Python and Flask. So I have even more complicated things that are going on. So I can have apps that use something like MySQL or Key Vault if I want to explore that. I have a simple chat with OpenAI. There's plenty of different apps that I can run that use the frameworks I'm looking for. So if I don't want to use something like Flask, I can use something like Fast API. Let's see what this first one is. Containerized React application. Cool. So it's just a starter application that has a bunch of starter code, and then I can swap this out. So it looks like this is a to-do list. And again, it's 3 commands. It's azd auth login, azd up, and then if I want to take it down, azd down. It's that simple. So there's plenty of app starters and templates that you can use to just deploy something to the cloud and start building experience with Azure. All right, let's get back through the the demo or the slide deck. All right. So there is one thing that I didn't talk about, is that all of this stuff, unfortunately, costs money. But good news, I have good news for you. We have the Azure for Students program, which you can go to at aka.ms/Azure for Students. And what this is, it's $100 a year of Azure credits for you to use in your projects. And here's one thing that I got hit with when I started, was I gave my credit card to another cloud provider, and I used a project and I forgot to take it down. So then I got hit with a terrifying bill the next morning, and I had to beg and plead for them not to actually charge me because I was a student with no money. And fortunately for Azure, we have no credit card required. So as long as you have an edu email or you're affiliated with the university, you can just get $100 a year of Azure credits to play around with. And there's no worry of actually getting, charged out of the blue. There's no all those memes about cloud bills won't apply to you. So yeah, in my opinion, Azure for Students and AZD is the easiest path to the cloud. Additionally, on top of the different services available on Azure, there are free service plans. So if you have that $100 per year credit and you don't really want to use it and you want to try out different services, there's plenty. I'd like to shout out Azure Cosmos DB. I'd like to shout out Azure Cosmos DB, App Service, and Functions. I think these are great Azure services for you to play around with. And they're pretty Python friendly too, so you can give it a shot. There's plenty of talks on Python and Cosmos, especially today. So yeah, that's my suggestion. If you're a student looking to build with the cloud, we have AZD templates for you to get started with. We have the Azure for Student plans to get started with. And yeah, that's it. Again, all the links are right here. So again, Azure for Students, that's aka.ms/Azure for Students. The Azure Developer CLI is available at aka.ms/AZD. The template gallery is aka.ms/awesome-azd. And then we also have a set of docs that are kind of designed for developers starting with Azure. So if you're interested in diving deep and learning more about cloud-specific things, beyond just deploying 1 or 2 applications, but actually learning about what it takes to run Azure or work with the cloud in like a business or bigger software service setting, highly recommend the developer starter docs at aka.ms/Azure Dev Starter. That's it for me, unless we have any questions. My name is Rohit. I'm a product manager at Microsoft. And if you're interested in reaching out on LinkedIn or GitHub, my alias there is, for both of them, is Rohit-Ganguly.
Awesome. Thank you so much for chatting with us. And I'm back. And we also had a little guest with Jay.
Let me see. Freedom, here.
Well, while we're waiting for our guests to come back, we can wait for the chat to see if there's any additional questions. I didn't see much in the chat, but I was so pleased with the way that you presented the information. You really connected a lot of dots that took a long time in the beginning of my career to connect. So I appreciate it. And a lot of cat memes. Hi. Thank you so much. And we'll let you go about your day. Thanks, Rohit.
Thank you. Take care, all.
Well, Dawn, it's been really, really fun spending time with you and all of our Pythonistas today. Bye, Frito. Frito's done.
I know where you're going right after this. You're going to go hang out with Frito.
I am. Him and his little Star Trek influenced hoodie that he's wearing, all sorts of spacey stuff.
I love that.
I know you're going to be taking everyone else to Warp Factor 9 with the rest of this show today. So I'm happy to hand it back to you. I want to say to everybody, thank you so much for spending some time with me. And remember, you can always try out Azure Cosmos. I'm going to be shilling till the very end.
Do it again.
At aka.ms/trycosmosdb. Just like you heard in the last talk from Rohit, it's not going to cost you any money by doing this. You don't even have to put in a credit card. Just go ahead, get started, pick an API, start building. But Dawn, thank you so much for having me today. Thank you, Python community, for having this weirdo database guy spend time with you. It's been great.
See you later, Jay.
Bye now. Good luck, Pamela. Have a great talk.
And what a great intro as well. You got a shout out as he left and you came right in. We have Pamela and we also have another friend who just jumped on. Yes. Wasn't sure if we were going to get Chris on as well. Hey, Chris.
Hey, all.
I'll let you all introduce your topic. You're deploying with Azure in a new way that was announced at Ignite, I believe. So take it away.
All right. Hello, everyone. We'll start with some intros. So I am Pamela Fox. I've been having fun in the chat all day, asking lots of questions. So feel free to ask me lots of questions too. I love asking questions because that's how I learn. I am a Python cloud advocate at Microsoft, which means that I try to help Python developers be successful with Microsoft technologies, especially Azure. I have a huge number of sample repos. You already saw some of them today. We'll see another, what I demo. And I really enjoy making those because it helps me learn about the best practices for working with Azure and then for sharing with all of you. And I have a special guest today.
Hey, all. I'm Chris Harris, and I've had the extreme pleasure of working with Pamela and with Dawn for several years now. This has been great. And so I've been the Python end-to-end PM, so kind of looking at that end-to-end experience that a Python developer has when they're working in Azure. And then now I'm also the product manager for GitHub Copilot for Azure, which we're going to be talking about today. So I'm really happy to be here. And as Pamela said, feel free, ask lots of questions. If we don't have the answers, we will work on getting those answers for you. So.
All right, sweet. Thank you, Chris, for joining us. I love having the PMs of the things that I'm demoing, because then if there's a question I don't know, I'll ask the PM, and a lot of times you know. So we are going to be deploying Python apps using GitHub Copilot, and specifically using the new Azure agent, which is what Chris is PM of now. And we're going to try and do as much as possible with GitHub Copilot, and we'll see what it works really well for. And if we run into any issues, that's cool. I'll show you my, debugging strategy when I run into issues with GitHub Copilot. So this is our goal, deploying an AI app to Azure, a Python AI app, since this is Python Day. And yeah, I'm going to spend most of the time in VS Code. So here we are. So I've got my GitHub Copilot chat open. And if I go down here and I do you can actually see all the possible agents that I have, right? So some of these are agents that are built into GitHub Copilot, right? So at Workspace, that's just part of Copilot for VS Code. At Terminal, at VS Code is a new one too. Can help you set up tests and stuff. That's a good one if you're trying to set up PyTest for your Python repo. But the one mostly that we're going to be using today is at Azure. And this first came out actually at GitHub Universe, right? Is when we first announced it.
Yep.
Yeah. So that was a conference in San Francisco, which I went to because I'm in San Francisco. As I mentioned, in the chat, we did have a tsunami warning earlier today. So while I was watching someone else's presentation, instead of the lovely audio from the person, it was just and luckily no more tsunami warning. So hopefully we should be good. But if I suddenly look very wet, just take over.
Hopefully not. Hopefully not.
All right. So we're going to be playing with that Azure today. So so this agent can help us do lots of things. Maybe Chris, you could give an overview of the kind of different functionality it has right now.
Yeah, sure. So there is a lot it can do, and we're adding more all the time. So one of the big things it can help you do is learn about Azure. So you can ask questions if if you don't know what Azure Kubernetes is, you can ask it and it'll give you a description, like what is AKS? And it'll come back and it'll give you a description and maybe provide some links to some additional content where you can go and you can read and you can learn more about, that particular service that we have. It can also help, as Pamela's going to talk about today, doing deployments. You can query for information about your resources. So once she's completed a deployment, she'll have some resources that are out there, and then she can ask, she can say, hey, tell me a little bit more about this resource. What's the endpoint? Which region is it deployed in? Get a lot of information like that. We have the ability to answer questions about more specifically about your AI resources that are deployed. So if you have, GPT models or you have other models that you've deployed, you can find out where those are. You can get some of the detailed information about those. You can even deploy a new model. So if you if you're working on a project and you need an instance of GPT-4o deployed, you can ask it and it'll help. It'll create the resource group if necessary, basically everything leading up to creating and deploying that model. So there's a lot that we can get into. It will also help. One other thing is troubleshooting. So if you run into problems, it has the ability to help you both review some of the information in your logs, as well as perform diagnostics on some of the applications. So app service, function apps, things like that. It'll help you diagnose the problems you have with those, tell you what it's found, and then even provide some examples for what you might be able to do to fix it. So.
All right, that was a great overview, and I live ran some of your suggestions there. So now I'll just start from scratch with the Azure agent and start off with deploying. So I'll say I want to deploy a Python AI chat app to Azure. So let's see what it's going to do now, because this agent has different functionality that it's an agent, so it has different paths it can take, right? So it's actually asking, do you want to use the Azure Developer CLI to deploy your chat? And I am a huge AZD fangirl, as a lot of my colleagues know. So of course I'm going to say yes. And that helps it decide what sort of guidance it's going to give, because there's actually so many different ways that you can deploy an app to Azure. So here it says I'm going to init a project, but I don't even have a project yet, right? So I actually wanted to find a project, like, can you give me a Python AI chat template to deploy to Azure? And here you can see it says searching for templates. So that was actually the functionality that I was looking for, is that I wanted it to actually suggest a template to me, because I'm starting completely from scratch here, right? So there is, I'm in a folder and there is nothing in the folder right now. So the agent has the ability to search our template galleries, the AZD template galleries, and suggest templates that we can use. And it gives me the command here. So it says azinit -- template, and I pass in the repo. So I'm going to go ahead and run that in my terminal. And it says to enter a new environment name. So just PF chat app. All right. Okay. And then I'm saying, okay, so how do I deploy this thing? You can be very casual with LLMs because they were trained on the internet. So they speak Reddit. So we're going to go ahead and run AZD up, as it said to do. And so AZD up is going to help us deploy this to Azure. So first I have to select my subscription. I have quite a few, but this is the only one that works. I'm going to select this one. And then an Azure location. So this is an interesting question, is what location to use. And this I find is actually one of the most annoying aspects of cloud deployment, is having to pick a location. Like, it's like, I don't want to have to think about that. But a lot of times there can be restrictions on locations, especially if you're sharing a tenant with other people. So in this case, this subscription is shared with a bunch of other people, with like Sarah and Anthony and other folks on the team. So I don't want to overlap anybody else. So I'm gonna go ahead and ask Azure, like, in what regions well, first, actually, I want to know, like, what are the resources that this template's going to make? So I'm going to do an at workspace for that. So at workspace is the agent you want to use if you want to ask something that the answer is somewhere in the code for the project, right? And so now actually, if we look at our Explorer, there is a bunch of code. AZD init brought down all that code. So now there's a bunch of code here. There's infra, there's Python code, there's AZD configuration. We've got lots of stuff. So I want to ask Workspace is like, what Azure resources does this project need, right? So I want to know, like, you know, is my subscription going to have capacity for the Azure resources that are required? And what you see is that it says still building the workspace index. So actually for each project you open in GitHub Copilot, it does have to build an index as soon as you start wanting to ask questions about it. So you can actually get different answers depending on the state of that index. Because this is doing a RAG, which means it has to do a search, which means it needs an index. In this case, it's given a really good answer. It says it uses OpenAI service, container apps, container registry, log analytics, and managed identity. Now, I know that there are some constraints in our tenant on container apps. So I'm going to ask, in what regions do I already have container apps, right? Because the safe thing would be to avoid those regions. Now, ideally, Chris, everything would always work with deployments and we would never get location errors. But as Chris knows, basically the most common deployment error is location errors, right?
Yes, that's correct. One of those things, we still want to fix it. There's work going on to make that better, but it is still a challenge.
All right. So in this case, it says that there's no container apps found in any region. So I'm going to go ahead and just go for West US and assume that I'm not going to have capacity issues with it. Now, it's also asking me specifically for an OpenAI location. And the reason it asks specifically for that is because OpenAI resources are only in a certain set of locations because those, you know, data centers have to have, you know, fancy GPUs. So it's a, you know, it's a list of what, 21 locations, right? So I could ask the same question here, like in what regions do I have OpenAI deployments? Because once again, I'm in a tenant that has restricted capacity. So it's probably best if I just avoid any regions that already have OpenAI. So you can see what it's doing. I love to see it thinking because it gives me an idea of what it's doing. It said it was looking and it said it found one. Oh, it didn't find the region. Okay. So if we get response back from the Azure agent that we don't like, what we can do is thumbs down. And when you click thumbs down, you can report an issue. And it's going to say like, didn't specify region for deployment question, right? So I'll go ahead and fill this out. And I'm showing you how to do this because I really want you all to be filing issues about what's not working. Right, Chris?
Yeah, so do I. Yes, please do. Anytime you run into problems, please let us know.
So I'll go ahead. It used to grab the whole conversation history. I don't think it does it now. So I'm just going to like copy and paste it in there. And then I'll click create on GitHub and I can keep editing it there. So it made this issue here.
Yeah, one thing to be conscientious of, it, like Pamela said, it used to grab the whole conversation history, but sometimes there's some personal information or company information in there that you may not want to share. So that's why we don't do that now. But the more information you can provide, if you can tell us what question you asked, the prompt that was entered, what the response was, and what you didn't like about it, what you felt was incorrect, it's super helpful for us to be able to reproduce that situation and come up with a fix.
The other thing, and in addition, when you're doing it, sometimes what I do is I go to, like, this is elite level, but you can go, like here I'm in terminal, right? Go to your output. And then in your output, there's actually logs from all of your extensions. So if you're ever having a bug with any VS Code extension, you can actually find their logs in the output panel. And you just have to select, in this case, Azure. So in this case, you know, I can actually see like received chat. And I'll go ahead and just put this here. So logs from output. But pretty much whenever, like I file bugs with lots of extensions because I'm always breaking things. And they almost always will ask like, hey, can you give us the logs from the output? Okay. Perfect. So I filed that now. So I do encourage you to thumbs down, and bonus is to actually report an issue. So yeah, so it didn't specify the region. So we're just gonna YOLO and go for it. That query did work about 10 times earlier today, but we are dealing with LLMs, and they
Yes, that's one of the fun things of this job is working with LLMs. You get a different response every single time. A lot of times they can be good responses, and occasionally you'll end up with ones that are completely off the rails. So
yeah. Does the question I have is, does the agent use the seed parameter behind the scenes to have more predictable outputs?
It doesn't. So we haven't done anything intentionally for that.
Okay, and can you reveal your temperature values?
Yeah, the temperature is actually a little higher than I would like it to be. Like we've been talking about doing some experimentation with our evaluation platform. Right now we're at 0.7.
0.7. Okay, yeah. So 0.7 is on like the higher side. I think I've been using 0.3 lately for RAG scenarios.
Yeah, I think we're like I said, we're going to do some experimentation. We really want data to back up a decision to make a change like that, because in general, we're getting reasonably good responses. And we don't want to just make a change off of anecdotal, like, hey, 3 of these questions, I got better responses, and then we end up tanking the rest of our responses.
Yeah, Don has a great question. Can you give more context on temperature and seed? And I was actually even looking at the documentation for this today, because this was something that was coming up in our in a channel. So where is it? Okay, there we go. How to generate reproducible output. So there is, when you're sending a request to an OpenAI model, just for OpenAI, not for any of the other models yet, as far as I know. But you can specify temperature, and temperature generally, you can think of it as controlling the probability of what comes next. So if you have a very low temperature, like 0, then it's less creative, and it's much more deterministic about which of the possible next tokens it will predict. But it will still have variability. Even with a temperature of 0, it will still have variability. Now, what they introduced is this parameter called seed, with the idea being that if you set the seed, and if your seed is the same and your temperature is the same, and everything else is the same about your environment, in theory, the response should be the same. Now, I've used it, and it's not always exactly the same, but certainly setting a seed gets you much more predictable output. So you can actually set a seed even with a high temperature. So you could have a temperature of 0.7 and then, a seed of 42. And even then that will give you more predictable outputs, right? So if you've ever done a random number generator in programming, like typically there's a way to set the seed, because of course, no numbers are actually random in the world. But it's basically doing that, right? Is saying like, okay, let's try to make it more predictable which of the tokens are going to get selected next.
Yeah, all right. Great question. Good idea asking that.
Yeah. And when we're doing evaluations, whenever we're developing any sort of AI systems like RAG or agents, we should be doing evaluations. And typically when I do evaluations, I do set the seed during evaluation, at least, in order to make the output more predictable. But in theory, you could also set the seed for your app itself if you just wanted to have more predictability in the outputs.
Yeah, it might not be a bad idea, because then we might be able to reproduce things on our side more easily if there's a known seed. I'm going to have to look into that.
Yeah, I would certainly be very tempted to do that, because it's that's one of the really hard things about developing these apps that have LLMs in it, is the lack of control, right? The unpredictability, and this gives you a little more control. So here we can see what it did is that it provisioned all these resources. So it was able to successfully make everything. So my regions were a good selection. So we've got an OpenAI, we've got a GPT-4o mini in there. We've got a container registry that's actually storing the image, a container apps environment, and a container app itself. Now the container apps environment, I believe, is basically a Kubernetes cluster, right? Like, let's see, does container apps use Kubernetes? Let's see.
Yeah.
Let's see. It says, it uses Kubernetes. So this is great, but they abstract it. So one thing, I still haven't used Kubernetes, but container apps is my way of getting to use the power of Kubernetes, being able to scale up Docker container-based apps. without having to actually use Kubernetes.
Yeah, I think the way I look at it is container apps is the developer-friendly version of Kubernetes, where you can focus on the container and the application and not on managing the infrastructure. Because learning Kubernetes by itself, that's a whole job. There's so much you can do, and it can be so complex.
Yeah, maybe in 2025, but I also want to
There's
find
your first New Year's resolution.
All right, so let's go ahead and try this out, see if it's going to work. I do see the app. Here it is. So we can say, hey, sup. And so it should be sending a request to that GPT-4o mini model. Okay, and that was a little slow the first time. So let's give it another question, like, explain Kubernetes like I'm 5. Yeah. You know, I just realized I have a 5-year-old. I should be like really good at explaining things like I'm 5. Kubernetes is a magical toy organizer that helps you arrange your toys. It knows where each toy is. It can get a new one. Okay. I mean, yeah, maybe my conclusion here is you probably shouldn't even try to explain Kubernetes to a 5-year-old.
I think that's right. Yeah. Maybe 10 would be better. Like, as a target age.
Yeah, that's good. You know how like Wired, I think Wired does the things where they explain it every single letter, every single level. So they're like 5-year-old, middle schooler. So like I'm a middle schooler. We don't even see high schooler because high schoolers are basically grown-ups, right? They're probably all the high schoolers are deploying Kubernetes.
Oh wow.
Wait. If Kubernetes add more lunch boxes. Okay, so they're using. We got like a lunchbox analogy here.
Okay, that's great.
Great, cool. So this is working. You can see the response streaming in, and of course, like if I'm new to this project, I could ask some questions like, where's the Python code for this project? So here I'm asking at workspace. So I'm using these 2 agents because I really want to show like when I would use different agents. So if I'm asking something really specific to this project, I'm going to use that workspace agent. You can see it used 72 references, so it really can bring everything in. I think that can the Azure agent access all of this, or is it limited?
It can, yeah. It can access
now. Okay.
the files in the workspace now, yes.
That's really cool. Okay. So here you can see it actually linked to the thing. So we've got chat.py, and we can see here that it, creates the request and it streams back the responses using a Python generator, which is how we get the word by word effect. We also have a GUnicorn configuration, which shows it how to run using a GUnicorn server. We could also ask like, where's the Docker file? Right? Because this is on container apps. If it's on container apps, there must be a Docker file that tells it how to run. Okay, it linked directly to the Docker file. And then I could, this is actually a interesting Docker file. It's a multi-stage Docker file. And I might be new to Docker files or new to multi-stage Docker files. So I can also ask, workspace to explain this Docker file. And so it could go.
That's very helpful when you're like working with a new file type, or if I'm working with some new framework or something like that, getting the LLM to explain it can really help demystify it for me.
Yeah, definitely. Yeah. I think it can just make new code bases be less intimidating. Okay. And so we got a big, long explanation here. So this is the Docker file that Container Apps is using. You can see that it's setting up a Python 3.11. We might want to change that to a 3.12, like up here in the future. And we could test out changes to that. Okay, now what I want to do is try that logging that you talked about, right? So I am going to purposely cause an error, all right? And the way I do this is by asking, how do I make a bomb? So I apologize for the violent imagery, but this is how I know one way to trigger the Azure OpenAI content safety. So whenever you use Azure OpenAI models, they always have Azure content safety on top of them, which means every single request is checked to see if there are any issues with the prompt or any issues with the response. So there'll be, in this case, it'll say that the prompt had, let's see if I can find it, filtered, violence, filtered true. So see how it says violence filtered true? So it said, okay, the prompt was filtered due to being violent with a severity of medium. And you can actually like configure your content safety levels in the portal, but you cannot turn it off entirely because this is part of our responsible AI. Okay, so I caused an error. Now, here's the question is, can I get Azure to help me find the logs? Because one of the things I find the hardest about Azure is finding my logs. It's different on every service. I feel like it's different on every service. And yeah, I just always have a hard time. So,
and this is one of the areas where we're still refining how this part works. So,
yeah,
we could flip a coin and figure out whether or not Pamela is going to be successful here.
Yes, for sure. I've actually been running this query all morning, and I will tell you our chance of success is low, but that's okay. Like I'm going to try. But they, I was saying like the team knows that, that this is a really useful, functionality. So, if it's not working right now, that's fine. We can expect it to work in the future because this is really early days, right? It's only been out for what, 2 months?
Yeah. And we're still in public preview right now. So we haven't reached GA or the full release. And this is something we definitely want to really get dialed in. So it's more deterministic. All right, come on. We'd like some music here.
Dun, 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 dun,
This is a good start. We need to query the resource.
So yeah, look how it's generating a query. So that's actually one of my favorite things is that it does try to generate a query. In this case, it wasn't able to. We could look at the output and see what it tried to do. So the interesting thing here is it keeps messing up the type. So this should actually be Microsoft.app, not Microsoft.web. And I've already filed this issue earlier today, so I won't file it again. But let me just get it to, I'm still going to get it to help me with KQL. So I'm going to go ahead and open my container app in the portal and open up my logs there and still get some help with log querying syntax. So let's see, container apps, environments to be in here. Okay, and we'll go to a container app and then go to logs. And there we have so these are the 2 logs that we have for container apps. There's console logs and system logs. So system logs is like the meta logs, maybe like the Kubernetes level logs, perhaps. Like it's the stuff that's like starting up the Docker image. Right. And then the console logs are like your apps logs. That's how I think of them.
That's how I think of it too.
Okay, good. So here I can it can get the table name in the editor, but then I'm supposed to use KQL, which maybe is that like Custo QL?
Custo query language, yeah.
Custo query language. I have really never used Custo query language, and I really don't know how to write it. Like I'm actually very good at SQL. Like I literally teach a SQL course on Khan Academy. You can go learn it for free. But KQL is different, and learning new things is hard. So I'm going to go ahead and ask if the Azure agent can help me write a query. So I'm going to say how to query for the, and I put in the table name for error logs, right? Because even something like capitalization, because when I do SQL, I always go like, this, and even that is wrong. Right?
Yeah. I do not like, I grew up in the Windows world where capitalization didn't matter for most things. And so I struggle with some of these languages that are case sensitive.
Yeah, it definitely throws me off. So it looks like we got an answer, and it was based off the Azure documentation. So you could also just think of the Azure agent as being your quickest path to Azure documentation, right? Because search engines don't work that well anymore. I mean, I'm sure Bing works great, but generally search is hard. And obviously, if you're doing if we know we need results from Azure Docs, you're always going to get a better result if you know you need results from Azure Docs. So I'm going to go ahead and try this out. Okay, so here I tape it in, and here's what's cool is that we do get feedback from the editor about anything that's wrong. And in this case, it's just a warning that it says that contains is expensive.
Yeah.
However, this is a Microsoft account, so whatever, I'm just going to use it. But it looks like I can change that to has if I wanted to. So I guess I'll change it since they recommended. But that's a nice thing. This is general best practice. Is if you're using an LLM to generate code, use that generated code in an environment where you have linters to give you immediate feedback about whether that is good code, because sometimes it makes stuff up.
Yes, indeed.
But it's still this is so much better. This would have taken me days to figure this out. There's lets in this language, there's semicolons, this
has,
looks so different.
We don't have has in SQL, so
yeah, it's
like
just
that.
It's so different. All right, so we're gonna run it. Okay, it says no results found. So maybe I'll just get rid of, whenever you're doing SQL like things, it always helps to just remove things. And it says no results. So I'm gonna go back to that contains, because maybe contains would be more successful.
Yeah, you know what I do. I start, anytime I'm not getting enough results, I start removing where clauses.
That's right. Okay, we're gonna go real low because this totally worked early. Okay, we're just gonna look at all. Do we have any logs?
Yeah, I think what we're missing is maybe it messed up on a column name. So there was the log S column.
Yeah, and log S is now I actually thought that looked like the right thing. Maybe it just doesn't have the error yet. Yeah, maybe it just didn't get the error through yet, because that could be the other issue, is that sometimes it takes 5 minutes or something for the error to go to log analytics. It's not supposed to be instant, is what I've been told.
Right. It's not reading it directly from the machine.
Yeah, because here we don't see anything. All right, so I think it's probably just that it's behind. If I keep running on this, oh, I messed up. What did I do? Yeah, so I'm just gonna assume it didn't come, because there's definitely variability in sometimes it feels like the logs come really soon. Sometimes it feels like they take a few minutes. We could try a different one. I just want to see G unicorn logs. I think we had some G unicorns, right? So that worked, right? So it's just that we haven't got our error log yet. So we could go and look at this and see it said starting G unicorn. Okay, so generally you can use the Azure agent to write your KQL for you. The stuff your logs have to actually be up to date for that to work. But I love this, because this was actually doing a lot. And I can even say oh, please modify that KQL to sum up the errors, right? Because I also don't know how do you do some operations, right? It's just completely different than SQL. So here we can see, oh, there's this summarize thing and use this count thing here. So I find that really helpful, and hopefully, it gets easier and easier as you keep improving the agent.
Definitely. That is the plan. And with feedback, if you guys let us know where we aren't doing well, if there's something missing or something broken like this, it'll let us know where we need to spend our time.
Exactly. Yeah. All right. So I showed a lot of what I wanted to show. Let me see any resources I wanted to share here. Right. So GitHub Copilot for Azure. If you have not installed it yet, please go to this akka. Maybe we can get this akka in the chat, akka.ms/get GitHub Copilot for Azure. You can go ahead and grab it and install the extension from there. There's also a blog that talks about it and all the different use cases. And we're also putting out videos all the time that show examples of how you use it. Because the goal is to help you be more productive on Azure, so you can spend more time in your editor getting things done, and not have to have a billion tabs open, figuring out how to do stuff.
Yeah, we should point out too, there's no additional charge for using this. It's if you have Azure already, great. You have a GitHub Copilot license, you're good to go. So there's nothing else you need to spend in order to make this work.
That's a great point. There's also the AI apps templates gallery. We'll share the akka too, akka.ms/AI-apps. I think we've shown it actually a few times to date, but basically the agent is querying this gallery. That's how it found the example that I went through. So it's querying this gallery, I think some other galleries too. But if you are looking for AI app templates that are designed to work with AZD, and that, are just really good templates to get started, do check out that templates gallery. And then, of course, I also use the AZD CLI, and you can learn more about that at aka.ms/AZD.
Awesome.
And there we go.
Hey, Dawn's back.
Oh, yeah. I'm like an omnipotent voice at the moment. Where can people find more about you? Want to continue these conversations, have more questions? Where are you all hanging out?
Yeah, so the best place to find me is in the GitHub repo. So open an issue, and that's the best place that you'll be able to locate me, is there.
Hey, Byron.
Not a social person, other than like.
For me, you can find me on GitHub. You can find me on LinkedIn, Blue Sky, Fosstodon, Twitter, like all the places. I'm basically Pamela Fox everywhere, and you can find it all from pamelafox.org.
All right. Well, I'm going to get you off the screen, and we're going to talk about AI apps in a sidecar. And Byron and Talika from video recording will be helping us with that. So let's
awesome. Thank you, Dawn.
Bye to our friends. And get myself back up there because I'd like to talk to you. You can see me. Hey, Byron.
Hey, Dawn. How's it going?
Great. Thanks so much for joining us today for the questions. We do have a video from your colleague, and it's going to be a short one. So before we get to that, can you just give us a little primer on what we're going to be watching?
Sure. Well, hi, everybody. I'm Byron Tardif. I'm a Principal PM with the Azure App Service team. And today we're going to have Toolkit walk us through a demo of using Azure App Service with Python and using this new feature that was announced GA at Ignite just recently. It's the ability to run sidecars. And we have an interesting scenario, which is running a local LLM as a sidecar next to your app. So Tulika would love to be here, but she's based in India. So right now it's like 3 a.m. for her. So we figured instead of having her falling asleep on her keyboard, let's do a pre-record. And I'm here to answer all the questions about app service in general, or anything specific about this demo. I'll be in the chat and help you with that.
Awesome. Thanks so much, Byron. I'll see you in the chat. And let's cue that video.
Hello, my name is Tulika, and I'm a product manager with the Azure App Service team. I'm here to talk about the new sidecar feature that we announced at Microsoft Ignite 2024 and show you how you can use the feature to integrate AI capabilities into your Python application. To get started, you can create a Python application from the Azure portal. You can go to Create a Resource, and there you will see the option to create a web app. Hitting on the Create button over here will take you to the portal flow to create an application. There are 2 kinds of applications you can create. The first one is a code-based application. Here you give us the runtime stack that you want to use. As you can see, we have all the different supported versions of Python available, and you specify where your code resides. Your code could reside in GitHub, Azure DevOps, or you can choose to deploy your code using zip deploy. The other kind of app that you can create is a container-based application. Here, you give us the Docker image that you've created. So if you go to the Container tab, you can specify where your image resides. It could reside in Azure Container Registry, Docker Hub, or even on a private registry on-premise, and we can pull the image for you. There are certain properties that you specify for the image, like the registry, the image, the tag, and the port. You can also specify an optional startup command, which would be executed every time your application starts up. Moving on to the sidecar feature. Sidecar is an architectural pattern which allows you to add peripheral tasks for your application running in its own containers. These peripheral tasks for a web application could be things like observability, monitoring, caching, or even AI, as we will see very shortly. The fact that you can have these peripheral tasks as different containers makes that your application is easier to maintain, and you can plug and play different components. Let's go to the first example that I have set up for you. I can browse this application, and it's a simple chat application. So I can ask it a question, and hit send, it'll start generating the response. Now, a couple of things that I want to point out about this application. Firstly, I am using a container-based application here, and I have got a front end, which is the UI that you see over here, which has a text box and a button. I have the backend application, which is a sidecar. This sidecar is loading a small language model, or SLM. The specific model that I'm using is a Phi 3 CPU-based model. Small language models are a great alternative, especially when you want to run your application on CPU-based workloads. So here, as I mentioned, that I have my web application, it is running as a container-based app. Sidecar works for both code and container apps. So here I'm showing you a container app. To add a sidecar, you go to the deployment center and you will see that there is a new containers tab which is available for you. You will already see the main container added. The main container is the main application, which is the UI for your application in my case. And you can add one or more sidecars. I've already added my Phi 3 SLM as a sidecar. So to point out certain properties of this sidecar, the first is the name. It could be anything. The type is sidecar. Now, what this really means is that no HTTP requests can directly come from the outside world to the sidecar. Only the main container can talk to the sidecar. You can specify the image source, which could be Azure Container Registry as it is here, or it could be Docker Hub or a private registry. You can specify authentication options. I'm using admin credentials, but you can set it up with managed identity as well. And you specify properties of the image like the registry, the name, the image tag, the port, and even a startup command if you needed to. Now that sets up your application. Let's go ahead and look at the code of the application. As I mentioned earlier, I am using Phi 3 as my model. I'm using the CPU-based model, which is an offline model. So I'm actually referring to the model directly from the file system. That's what you see over here. I create a tokenizer for the model just to ensure that I can pass in the tokens and get a response back. My API has a single method called predict, which accepts a single input, which is the text that we put in the text box. So in this case, the question, what is Azure App Service? I've created a chat template. In my case, the chat template has nothing very specific into it. I'm just passing in the input, which is coming from whatever the function is being called with. I've set up some parameters for the model, for example, the max length for it, some search options, and so on. Most of the work over here is actually happening in this section where I'm generating the response to the question that I've asked. The response is being generated one token at a time, and this token is yielded back to the client so that you get a streaming response. When you start creating AI applications, you will often notice that it takes some time for the full response to be generated, depending on how large the response is. And therefore, we always recommend that you implement a streaming response. So that's what we're doing here. Now, since this is a sidecar, I'm running it as a container. I have a Docker file over here which builds the container. The Docker file is fairly simple. I'm using the Python 3.9 image. Now, since I'm using the offline model, I have to copy the model into my Docker image. And this is the line that is doing that. It's copying it from my local file system into the Docker image. I'm copying the API file that I created, and I'm exposing a single port called 8000. Once I have the image, I can use any kind of Docker tools to build the container and push it into my container registry. Now let's go ahead and look at the front-end application. The front-end application is a simple fast API application. The important thing over here is the API URL. This is the URL of the backend, if you will. In my case, it is the sidecar. The first thing to notice here is that I'm calling the sidecar API on localhost. This is because the main container and the sidecar share the same network namespace. I'm using port 8000, that's the port I had exposed earlier in my Docker file, and I'm using the predict method, which is the single method that I exposed in my API. I have a method called sendMessage, which is going ahead and making a post call to the backend API and returning a response. This response is then being shown onto the browser window one chunk at a time, so you're getting the streaming response. Now, since I created a container-based application, I also have a Docker file over here. This is just a sample Docker file that you would use for any Python application. It is building from Python 3.9, setting the environment variable for Flask, and exposing a port for it. And that makes you set up a simple chat application in Python using the sidecar pattern. Now let's go ahead and move to another example, which is slightly more involved. So here I have another application which is set up. Let's first go ahead and browse this application. Now I'm trying to create a fashion store assistant. I have some products in my database. As you can see, this is the list of products, and I want to ask questions about these list of products. So I can choose anything from here and now ask it a question. Now my database contains two things. One is the name of the product. The other is the description for the product. But I'm going to ask it a question which is not in the database. For example, I'm asking it, how can I pair the blazer? In situations like this, generative AI really shines. So even though this information is not in the database, it can take the context of the product and generate a unique response for the question that I asked. So now it is giving me options on how do I pair the blazer and giving me a list of options over here. Let's go ahead and look at some of the properties of this application. The first property that I want to point out over here is that this is a code-based application. Now you might be surprised to see that the runtime stack over here is .NET Core. That's because I again have the same model that I mentioned earlier. I have a front end and a back end, but in this case my front end is .NET Core. In fact, it's a Blazor application. I could have used Flask application, but I just wanted to show you the cool thing about sidecars, where you can run a front end and a back end using different language frameworks and stacks. So my back end is still Python, but my front end is .NET. Now for a code-based app, to add a sidecar, you do exactly the same thing. You go to the deployment center, and you will see the new containers tab where you can add one or more sidecars. Now, since this is a code-based app, you don't see the main container because you've given us the code, but you do see the ability to add sidecars. I've already added the phi3 sidecar over here. So you see the name and the image source. Here I've pushed the image into Microsoft Container Registry, which is the public registry. So you can see it over here, and you specify things like the registry URL, the name, and the tag, and so on. Now let's go ahead and start looking at the code for this application. Just like before, I am using the CPU-based model and loading it from the file system. That's the line over here. I'm creating the tokenizer again, just as before. I have a single method called predict, which is accepting the input data. But here I'm creating a chat template, which is slightly more involved. I'm specifying what the system should do. So my system message is that it should give me concise information. I want to make sure that it keeps the responses brief and only focuses on key points. Of course, you can change the system message to be anything that you want your assistant to be like. The second change that I have over here is when I'm setting the input prompt, I'm taking the user message, that's the question you asked, but appending it with the product name and description. So this gives the context for the response. In essence, I'm making my model work as a chat completion. So I'm essentially creating a chat completion API over here. We do the same stuff that we have the tokenizer encoding the prompt. I have reduced the max length to be 300 over here. And then all the earlier stuff that I'd mentioned, that we're generating the response one token at a time. As soon as we get a token, we are yielding it back to the client. Again, I have the Docker file. Again, I copied the Docker file I'd used earlier and just over here. So you see the copy statement, which is copying the model from the file system. I'm copying the API file and exposing the port. Now let's go to the front-end application, which in this case is my Blazor.NET application. The first thing is I specify the URL I'm going to talk to the backend. In this case, it is localhost, again, because the main container and the sidecar share the same network namespace. I'm using the port 8000. That's the port we had exposed. The work happens in my home.razor. Here I'm making a HTTP post request to the API that I specified earlier, and then using StreamReader to stream the response back to the browser window. The thing that I want to point out over here is, as far as the front-end application is concerned, whether this is the .NET application or the earlier Python Flask application, it has no AI components. So all it's doing is a HTTP post method. Essentially, it means that you can switch out your backend model to something else, or you can update the model, and your front end is going to remain exactly the same. And that's one of the benefits of using sidecars, that now you can go ahead and update different parts of your application without affecting other parts of your application. If you want to try out this, we have a couple of blogs which has the code repo as well. So this is the first blog which shows you the first chat application that I showed you with the Flask front end and the back end using the SLM. I have another blog which is slightly more involved. This tries to implement a local RAG by using an in-memory vector database. So whenever you ask it a question, it will first search it in the vector database, and depending on the response, it will generate a response for you. We are quite excited that you should try out this feature. Let us know how it goes. We are always open to feedback and improving the product based on your feedback. This brings me to the end of my talk. Thank you for listening to me.
Thanks so much, Toolkit, and we'll bring Byron back on for a farewell and maybe an additional question or so. Byron, that was great. Thanks so much for being here also to answer questions. We didn't get very many in chat, but we did get a thumbs up on the demo and some appreciation and some resources. I'm interested in kind of what's the next steps. I don't know if your roadmap is open. I don't believe so, but what are the next steps and what do you see people using this for, and like maybe where their limitations are ending up?
Right. So you can see the potential power that is opened up by sidecars, and we think of it as a fundamental platform feature. But we do recognize that it might be a lot more work than you can think of, having to, if you're not specifically using containers, having to now think about containers to add a sidecar to a code application, for example. So one of the things that we actually are in like active conversations with people like Datadog and New Relic and the add an APM scenario. And that's an awesome fit for sidecars, right? Because you don't have to modify your code. You could actually even swap those in and out depending on which one you like better. So making it super easy so that you get more click-to-click experience. And now you've added Datadog to your app to collect APM data, and you didn't have to necessarily touch your code. And you also didn't necessarily have to learn about Docker if you don't want to. Right, like if you're leaving Docker containers and you're using app service, you can go and bring your own even custom sidecar with your own handcrafted Docker file, awesome. But if you want the simple experience, we are also looking into that as well.
Interesting. Great. Thank you so much for your time, Baron. I appreciate it. And it's been one.
I just want to give a shout out that we have the App Service Community Stand-Up every month. We literally just had the last one for December, and we talked about availability zones, which, it's an exciting topic. We're going to be on hiatus for January, but we're coming back in February. So if you want to learn more about that, I think we dropped the link to the App Service blog, and you can see every time that we do a community stand-up, there's a blog there. You get the link and you can discover all of that as well.
Perfect. Thanks so much, Byron.
Absolutely. Thanks for having us.
All right. We are rounding out the end of the day. We have 2 more presentations. This next one I am so excited for. We've eaten into a little bit over time, but we're going to be covering a lot. She's going to be covering a lot, and I'm going to be keeping up. I hope you are too. Keep up the energy too. Hey, Renee.
Hello, Dawn. Hello, everybody. Super excited to be here and do, a bunch of stuff, as you said. So, keen to get going.
Yeah, this one's going to be a little bit longer than most of them. There'll be a 45-minute one, but we have a lot of information to cover, and you're such a dynamic speaker. So I'll see you in a minute.
Fantastic. Okay. Get my slides up, hopefully. There we go. Oh, no, they've gone away. Thank you. Then maybe coming back again. There we go. Thank you, behind the scenes team. And I'm super excited to be here today. As Dawn said, I'm Renee Noble. I'm a senior cloud advocate at Microsoft in the Python Cloud Advocacy team. So excited to be here talking about Python and Azure on Python Azure Developer Day as part of this event. And I'm going to help you build your first full stack Python web app, or maybe, your 5th or your 10th, or maybe you just kind of want to come along for the ride and see how I might go about doing a very basic one to show you how to put the pieces together of a Python web app. So let's get started. So what are we going to learn today? We're going to learn how to build a basic, lightweight, toy web app with Python and Flask, as well as front end, and we're going to deploy it and do all the stuff. I say toy because this is just like a fun project that's really good to see how all the bits come together. It's not necessarily a thing that you want to have like 100,000 people going and using this website. Maybe 1,000 might also be pushing the limits of like the practicalities of what we're actually going to implement as part of this project, but we're going to see how all the different bits and pieces come together. That includes how to deploy and store data using Azure Cloud. And I'm going to include a few tips along the way for making your first web app or your 50th web app, for things you might want to consider making it a bit more robust when you actually go and put something out that you want people to use, or just generally for good security practices and things like that along the way. So there's a lot of stuff that goes into making a web app. You might have been like, I don't really know where to start. It's a bit overwhelming, and that is fair, because you can see this list, which I'll go through in a second, of all the bits of technology that it's going to take to make a web app. So is it going to take a lot of tech? Yes, but I'm here to hopefully help you through the hardest part, which is all the glue of sticking it together in the right ways. And then hopefully we'll be comfy using GitHub and CodeSpaces or VS Code, whichever you like. CodeSpaces is a really great way to do it in the browser. Python and Flask. HTML with Ginger 2 templates. So that's the templating engine that's part of Flask. CSS, just a little bit of JavaScript, and then deploying it to Azure App Services and using Azure Storage, some blob storage. So these are the bits we're going to use. You don't need to be super familiar with them. I will note, if you are like, this is super useful, but also that's like a lot of stuff to do in a 45-minute time slot. I do have 4 episodes, 1 hour each, where I go through this more slowly. So if you want to take what you see here and then be like, yeah, that was cool. How do I actually do all the bits and go through it? I live code the whole thing. You can go and watch a series, which I'll give you a link for at the end of this session, where I break it down. But we're going to give the express version today. So firstly, let's say, what is a web app? Because we've been on the internet, but there's different kinds of pages out there. You might go and look at a travel blog or something, for instance. You're like, yeah, someone has put in some information. There's a little story here, but it never changes. That's what we call a static web app. And potentially it doesn't use any other APIs or nifty tricks that pull in new data, and it could always just be the same. Something that can be a web app can just run on the front end. So that could just be like you're getting the HTML, your CSS, and your JavaScript, and it could run the whole thing there. And something like Wordle, which people are probably fairly familiar with, can run on the front end. Of course, there's a server in the back end, or somehow to give you the files that comes over the internet that gets to you, and then your browser is going to compile those bits and pieces together to display the website. And you can interact with a web app. So as opposed to a static page where you can just read the contents, a web app will have some sort of interactivity. So when you're doing Wordle, you're going to put in your guesses. It's going to tell you which letters you got right and ultimately if you got the right answer. So there you've got some interactivity. But sometimes we're going to need a little bit more than the stuff we can just do on the front end. So when front end isn't enough? What are some scenarios for that? And when do we need to talk about a full stack solution? Something that you might want different options for are if you have different views. For instance, you might have your users and you might have administrators. So we're going to need to be delivering 2 different sites depending on if someone is logged in as an administrator. You might have some database information. So you might have a social media profile and you want to go, okay, I'm going to grab the photo for this person's profile and I'm going to grab some information about them. And then we're going to display that. We're going to put it all together. We're going to render a template of what a profile looks like. And we're going to deliver that for the profile that's been asked for. We might also have secret information. So you might be running an exam online and you want to show people the questions, but you don't want to show them the answers that will automatically be marked on the back end. Something like Wordle, at least I haven't looked at the deployment recently, but when it was first created, you could just look into the JavaScript and go, oh, hey, today's answer is start, and then tomorrow's answer is lunch, things like that. So you could just look through that code, and if you wanted to cheat, you could. But if you're running an exam, you don't want people to be able to look up those answers. So we need to have that secret information on the back end, and the marking needs to happen on the back end, not up front on the front end, where people can just go right click, inspect element, and find out all the secrets that you're keeping there. So we can see here in this burger picture, there's a lot of things that could go into a full stack solution. And I've circled just the things that we're going to be using today. You could have a full stack solution that used all of these different bits and pieces, but you don't need to, especially if it's your first time or it's you're early in your full stack journey. So we're going to just be using a few bits and pieces today for the different layers. So we've got our front end technologies. We've got REST, which is how we're going to be sending signals from the back end to the front end. And then we've got Azure, where we're going to deploy all this stuff. Let's now look at how this all fits together. We've got our front end. We've talked a bit about that. We've got a few files there going to get rendered together in the browser so you can see stuff. We've got the back end now, and we've got our web server, and we've got data storage. So our web server, we're going to be running something in Python, and then data storage is where we're going to be storing things. And there's going to be a few different options for that. And then they connect via the internet or some sort of network, not necessarily the internet. Before we go further, let's actually talk about what we're going to be making today, and we can then see how this all relates to this. So, a more tangible example. We're going to be making a party invitation website. It's going to be all right. It's not going to be the best invitation you ever received to a party, but at least the form where you make the invitation doesn't look that great. We're going to be doing some CSS, but the rest of it is an exercise in homework for the user, because we just want to see the bare essentials of how we can get away with making a website, because the rest of it is just doing more of the stuff we've already done. And we don't need to see all of that. Otherwise, it's just like, that's a lot of code. Okay, so here we go. We've got our make our invitations form. That's our first page. Then we're going to have our see invitations page. We're going to view the content that's got, we've got some stuff coming out of this form, like who's coming to the party, what the party is about, when it is. We're going to display that with some different fun themes as we can see we're choosing our styles. Then we also want to be able to see a list of the different events. And finally, we're going to want to see who has responded yes for attending an event. You can actually check this all out if you want to at this link, and you can have a play around with that yourself. So before we get started, let's look at this in halves of what the different technologies we're going to be using. So firstly, let's talk a little bit about the front end. We're not going to actually live code the things today because I do only have 45 minutes. But we will go and look through the code. And firstly, let's talk about HTML. That's going to have our content and our structure. So this might have the words that you want to be displaying on the page. It will also have tags that say, this is a heading, this is a paragraph, this is a container of sorts that groups these bits together. Things like that. Here's an image, this is a link. So we've got that going on there. Then we've got CSS. This is the stuff that makes it look pretty. It controls things like making the font green or big or this style of font. It also controls the flow and the layout of how things appear on the page, and does things like if I hover on a link, then it turns purple. Things like that. You can control all of that in CSS. And it's really cool because you can have the exact same HTML for a website, and CSS can change the flow of it entirely. So these two examples, you would use the same content, but the CSS would be able to change the vibe and how it comes together completely. So you can see that's the same, but quite different. Finally, on the front end, we have JavaScript, or JS for short, not to be confused with Java, which is a different thing. So that's my hot tip for you. Don't get those ones confused. They're quite different languages and used for different stuff. We use JavaScript to add functionality to the elements of the page. So you can actually grab an element and say, hey, this thing, I want to be able to change it dynamically. For instance, if we're playing Wordle, we might enter some letters for our word, and we may make the guess. You're actually going to change the color on the keyboard of things that you've already guessed and how they went in the word. So this, using JavaScript, makes things dynamic, makes them changing. You can use it to get data from the backend. It's a great way to interact with the backend with not using just standard forms and things like that. So that's what we're going to be using it for today. So as part of this project, we're going to use some basic HTML forms, as well as some HTML Ginger 2 templates for creating our invitations and our event lists. We'll also use CSS to make it a little bit prettier, and some JavaScript to actually send through those RSVPs. The back end. Okay, this is going to be our web server. This is how we're actually saying, hey, have some of our website. Here are some files. This is the stuff you need. And it's also going to do the work to work with the data that we've got those RSVPs coming in. So we also need that somewhere to store those RSVPs, and we've got a few different options for what we can do there. So firstly, our web server is saying, okay, I want to go to this page or that page. And it's like, oh, great. Here are the files you need for that page. Here are the files you need for this page. You might also need to fill out a template with some data when you are going to pull that different route. So we're saying, okay, we've got this stuff from the form and I want to create an invitation. I'm going to fill out a template. I'm going to put that data in, and then I'm going to, once it's already complete, send it off to the front end. We're going to use the backend also to access and store data and interact with our data storage solution. And if you want to, on a backend, you can use APIs as well to use other people's data or other services that already exist. A backend just needs to be on the net, I'm going to say. That could be the internet, the World Wide Web, or it could be on a local network. You can run a server off your own computer, and if you just want to serve it up on your LAN, you can do that. So that's different options, but if you wanted to run a server for the whole world off your laptop, you might want to get a really big laptop, and you're going to need to leave that running all the time. So probably use something like the cloud, which we're going to be using today with some Azure web apps, as well as using some Azure storage, which we'll get to in a second. So our web server is going to be made of Python and Flask. Flask is a pretty lightweight web framework for creating little web apps or bigger ones. Some cool big stuff exists on Flask. And we're also going to host that, once we've got it made, on Azure App Service via GitHub, I'm going to say, because we're going to link it up to GitHub. We're going to push our repo to GitHub, and then we're going to have it connected with continuous deployment with Azure App Service. So whenever we make a change and push it to GitHub, it's going to get synced up to Azure App Service. So we're going to get the latest version of our website. Now onto data. we've got a few different options. And when you go, oh, we're making a website, we're going to need a database. And that is probably the solution that most things would be using, an actual database, whether that's a relational database or another structure of database. But there are other things that get used in web app creation. Something like blobs or binary large objects are just a way to shove a bunch of files into a container in the cloud and go, I'll get that back later, thank you, and just a great way to interact with that. So if you were using something like a photo uploading web app, that could be a way that the photos are getting stored, rather than in a database, which is more for structured textual data, or it can link to different things like blob stored files. That's where you'd actually store those photos. You could also, if you were doing a local implementation of something, especially, just using files on your local computer would be a great way to go. But the issue with that, potentially using that on a cloud scale, is we do want to make sure we have what we call persistent storage. And using files, if we're not committing them to our repo and we don't have a way to store those files, such as in a blob, we need to make sure that they have a way of not being volatile and going away when we deploy the latest version of our like if we push a new version of our repo. So we need to consider that when we're choosing our database or data storage solution. So thinking about our project, we just need to store RSVPs. So what does that look like? Well, we've got an invitation. Maybe if you're thinking like a Facebook event, you can say yes, no, or maybe I'm attending this event. And then we have a list of people who are or aren't or potentially are attending. So what would that look like if we went with a relational database? That could look like something like this. We'd have to have a bunch of different tables. So we'd have all the people who are using the site, all the different events that are coming up, and then we've got event responses. So these are going to be linked to the different users and to the different events. And we're okay, every time we create a new RSVP, we create a new line in this table, which have to reflect these two different other existing tables. So that's definitely what you want to do on a big scale of thing, because databases have things built in that mean that multiple users can be putting data in and taking data out at the same time. And that's great when you're using it on a large scale. But if this is your first time making a web app, it might be a little bit more complicated than what you need to do to kind of get the feel of what making a full stack web app is. So does it need to be so hard? Really, what we want to do is get a list of attendees out. Maybe we don't care if people say no, and we're just not going to give people the option to be wishy-washy and say, maybe I'm going to come. You got to commit when you're coming to one of these parties. So you're going to hit that RSVP button, and then you're going to get added to a list of attendees. Then when we have a list, we can just put that in a TXT file. That seems good to me. And then we're going to push that up. So we're going to add an RSVP every time we get someone saying, yes, Jack's going to come to this birthday party. We're going to get that post request when we set up those different routes. We're going to go, hey, web server, Jack wants to come along. Then we're going to go, oh, okay, cool. We're going to make a file or add to the end of an existing file. And then we're going to push that up to Azure storage, to our blob storage. So that's going to be there. And then we can also grab those files whenever we want to use them, update them, or display them. So those are the bits of technology we're going to be using to get started with. So let's get ready to go. You can grab my code from this repo here. I'll chuck it in the chat as well if you want to have a look at it. And then also you can grab the live series, the live web app at, nope, I apparently can't post to the thing. So someone else, if they want to chuck those in the chat, that is up to you. That's fine. But yes, the deployed app, if you want to play around with it and see where we're going with this is at aka.ms/invite-app. So we've got those going, and you can set this up in VS Code or code spaces when you get going. I do say here, this is my finished repo. It definitely has some more work. It could be done before, you would consider it a done project like any more CSS, but that's really up to you in terms of what you want to see with your eyes. And maybe you really like that form that I created. But let's get started. We have, firstly, we're going to talk about setting up our Flask web app. So we're going to have a file called app.py. This file, firstly, we need to import Flask, our web framework. We're going to set up Flask. Let me grab my little pen tool. Here we go. So we're going to import flask here. We're going to then invite people, or sorry, we're going to create this app. So this is creating an object. This is like later we're going to then run the app here. Then that's the basis of what we actually need to have a web server that's running. Currently doesn't do anything because we do need to put the routes in. So let's get on to that. Routes are the kind of part that's the end of the URL. You would have seen these when you look at a URL. Like if we have something like invitationapp.com, you might have /make invite. That is a different route that you want to go, hey, when I go to the make invite thing, I want you to do this function on the back end. And that is likely to give me the web page for that, or it could be something else. You can also include data in your paths here. So I've got view invite, that's the path. And then we've got name equals Renee is the data that we're passing through as what we call a query string. So we've got a bunch of different ways we can interact with our URLs here. Whenever we send something through to a route in the backend, we need to make a request. And there are different kinds of requests. And the one we're going to be using is the GET request the most. The GET request is saying, hey, I want to get this web page. And then we're like, oh, sure, I'm going to give you some HTML, CSS, and JavaScript, and you can go and put that together yourself on the front end. But one we will be needing is the post request, and this is a way to send data to the server. Finally, I'll note there's a few other things to make sure you're always safe and only give the permissions that you need to a route. When you only want to be saying, hey, people can get a web page from here, only let them do that by saying, yeah, this is a GET request. If you want to add post because you expect to receive data there, that's great. But if you have delete, patch, or put, you are going to let people delete or change data potentially when you're not expecting it. So make sure you're aware of what you're setting up with your different requests types there. So we're going to make our first route. This one is going to be what we call the index, which is just the slash. It's just, invite app / nothing else. So when you go to the home page, you might say you're going to get the form.html, and this is going to show us that beautiful form we saw earlier. But let's check out that HTML as well as the live web page to see what it's doing. So jumping over to, let's see that route first. This beautiful route is right here. That's all we've got. And then we can go over to, we're going to say render the template. We have to grab that template. They live in the templates folder. That's just the Flask structure that you should use because it will automatically know where to look for the template set. Also, if you use the name app.py, when we deploy it to Azure Apps Service, then it's automatically going to go, that is the server file that we need to look for. So let's go into form.html. It's a really basic form. And we can see it's a form. We've got a few different labels and fields. So this is our drop-down menu with our different styles. And we've taken in some different data for the event name, who we're sending it to, the date and the time, and who it is from. And finally, we're going to have that button to make the invitation. Beautiful. Then we can also go and have a look. So you can actually run this locally. Let's go back to our end file here, and we can just hit run in the file. And then if you're using it in code spaces, it does all this magic where it's just like, cool, you can just open that in your browser right now. You can also just do that from VS Code. It's all really great. And then you now have this beautiful form where you can start doing stuff. Terrific. So we've got a form there, which is terrific. But what's going to happen when we submit that form? We're going to get something we call a query string. You might have seen this when you do like a Bing search and you say, hey, I want to see some pictures of cats. Then it's going to, okay, rather than just putting the words pictures of cats somewhere into the internet, we need to put it right into our query string so it's held onto right there. So you get this Q, that's the name of it, which is short for query in this context, but you can put the name of whatever like name of that variable you want to put there. And then ultimately you get pictures of cats. These are my cats, so being very cuddly there. So let's have a look at actually what comes out when we are submitting this form. Okay, so we've got a beautiful invitation here, but don't worry about that for now. We can actually see in here We've got view, which is going to be the next route we put together. But we've got a bunch of different information that's come through from that form saying the style is kids. I know this is really small, so I'll read it out. The event name is birthday party. We're sending it to friend. The event is on 37th of October at 3 p.m. and the sender is from Renee. So we've got all that going on. How do we actually get that out? Where is that getting used? Because it's actually not getting rendered here on the front end. We can have a look here. If I go inspect element, we can see that birthday party on 37th of October, it's actually already in there. And this is not getting compiled on the front end. This is actually getting templated and put into on the back end and getting sent through. So let's have a look at how we get that data out. We're going to have a look right here. So when you start making your routes, you might want to go, okay, I want to practice before actually getting the data out. I'm just going to send through some dummy data that I've hard coded in. So you could do that. But once you are ready to send data that you're getting from the form, you're going to want to start doing something like this. So we can say, okay, cool. We want to get the request and get the arguments. So those are those different query parameters there. We're going to grab those. I'm going to get the one that was labeled to or labeled event or date or sender. We can grab those out. Then we can process them however we like. Maybe we want to make them all caps or we want to like remove all of the vowels, whatever you want to do. Potentially you want to create an event ID like I'm doing here so I can identify that the event ID is the sender and the event name. And then you can send those through. I'm also saying, okay, cool. I'm going to grab the style and I'm going to grab the appropriate template for that because we do have slightly different templates for our different event graphics and how they fit onto the different graphics. And then we go render template and we need to pass all of that information in. So right here, I've gone and I'm going to show you the template in a second, but we're going to pass all this information in because we want to show it on the invite when we send it out and any other information that we might need to store in the back end or just have on hand. So we've got that there. You can also put this into a singular object like a dictionary, and then you can access that on the front. But for now, we're doing a pretty basic thing. So I'm just going to dump it in as individual variables. So where does that go? It's going to go into a template. Let's see how that looks. It can do things like put variables in. It can do if statements or it can do loops. So to start with a basic example, we could have a dear name. Thank you for your kind donation of amount. And then tell you some other things about the next event and say the sender's name. So it's a standard template that you're going to fill out, and that's going to get done on the back end when we pass in that information. We just need to know how to structure it so that that all gets done right. So let's go and see how our template for our invitation is working there. So we've already seen our beautiful kids style invitation. So let's go and have a look at that one. So we can firstly say we've got our CSS coming in at the top here in our head section. So we've got different style sheets for the different ones because that's making them have those different aesthetics. And then we have some text, and this is where we get to use our variables. So we've got our to, so whoever the recipient is going to be is labeled in the to variable. We've got the date and the time and the sender, and these are, and we've also got the event name here, and these are all in curly brackets, these double curly brackets here. And that's going to slot in the different variables we've passed in when we render the template. While we're in here, I'll also point out a couple other things that are not templated in here, but we will need to know about them for when we get to the RSVPs in a second. So at the bottom here, we can see we've brought in this script. That's going to bring in the JavaScript RSVP function that we're going to want to use whenever the button on the bottom gets clicked that currently says, I'll be there. That's our button, our RSVP button has that text. And then whenever that gets clicked, we're going to call the function that's set on click. This is going to happen. We're going, okay, cool. We're going to send RSVP and we're going to provide the value of the person who is RSVPing and the event ID, because we need to be able to look up the file, the correct file for the correct event, and then add the name of the person who's just RSVP'd. We'll also, once that's done, we're going to want to show something that says, great, we'll see you there. And we're also going to disable the button. So we can see this is currently set to hidden is true. So we're not going to see that until we change it using JavaScript to make it apparent when we have actually RSVP'd. So those are what we have going on in our template at the moment. Okay, so how does this actually all come together and look pretty? We said earlier it's going to be the CSS. So let's take a quick look at the CSS to see what it's doing to make this look a lot better, or at least a bit better than our form does, which doesn't have any CSS currently. So let's take a look. It's going to be in the static file where we put things like CSS or JavaScript, which aren't getting changed, which aren't getting rendered. They come into here. And we're going to go to our kids style here. And we can see that there's not that much going on. This is the whole file for how wonderful it looks. It's actually not that much CSS, I'm going to say. And what's going on here is just some colors and font selection is going on here. So we want some pink font. We want different sizes for our headers and for our paragraphs. And then we want to have this fun background image, which has all these colorful bubbles and stuff. And we're going to set the size of it and make sure we have some padding because we don't want it to get all cluttered and filled up with text. White space, or in this case, colorful space, is important to make something aesthetically pleasing. So that's all that's getting done in our CSS. We do have a few different ones, and we do have a different background image for each of those. So that's how we're actually getting that image in there. It's not coming through in our HTML. It's coming through in this CSS here. Okay, so we've now had a look at that. But what else do we need to do? We need to add that RSVP functionality with the JavaScript. So let's quickly take a look at the JavaScript code as well. That is also in the static folder in rsvp.js. So this is all the JavaScript we have for this website. That's all we need. What is it doing? As I said, we can grab an element. So we can say, hey, I want that RSVP button once it's been clicked, because this function is only getting called when that button gets clicked. Then I'm going to disable the button because you can't RSVP more than once because we just don't want to be adding your name over and over again. And then we're going to get the see you there text, as I said, that was currently hidden. We're going to now say that it's no longer hidden. And finally, we're going to send that data. As we said, it was the event ID as well as the name of the person who is RSVPing is going to get sent back to the backend. And we're going to do that by making a post request to the web server and sending that through as some JSON. So it's a bit different than when we submitted our data as a form before, but it's not too different and it's pretty easy to get this data out. The great thing about using JavaScript for this is it means we can stay on the same page and we can just update the page to reflect that we have RSVP'd without leaving to go to a different new page. So that is the benefit there, as opposed to the form where we submitted it and then we moved on to the next page where we had the form that had the form data had gone into our invitation that had been rendered. So two different workflows for data passing there. So that's what we've got going on there. And let us see how we go about setting up this post route for receiving that data before we get to storing that data. So let's jump across to the code. That is in our app.py file again. So this is just going to be another route. As I said, we do have routes for all of our pages, but we also have routes for, this is like an API call. So we say, okay, I want to call some functionality, but I don't want to go to a new page. So we're going to set up our post request route here. And we can also get back any data from this as well. So ultimately, firstly, we want to start by receiving the data. First thing. Then we are going to split out the data because we have currently in there, we've got both the event ID as well as the name of the person. And we're going to assign those to two different variables, which we're going to use. And then we're going to start getting to the part where we store the data. So that part here is all we needed to do to set up our post request. And maybe you just want to print out in the console who's RSVP'd, and that's all you want to do for some reason. That could be it, but we do want to store our data. So we're going to need to get to what are we going to do with this data now that we have it, but we have already set up our post request and got our data out. As easy as that, which is pretty great. We just need to, use the request.json library there to get it out. So let's take a look at how we're going to set up storing this data. And if you were storing this locally, you could just store it in a file, which we will be using in a second. And you'll see that I have a bunch of different files in here. for people who have RSVP'd to things. And if you were just doing it locally, you wouldn't need to go and store all of this stuff on the cloud at this point. You could just like, I'm going to go and make a file, just open file name, and then write a new line to my file, append to the file that already exists or something like that. But because we are doing it a different way, let's jump into what we're going to do with that. I'm just going to close up some of these windows because we have had our time in those files. Okay, so jumping back to here, what are we going to be doing? We're going to set up an Azure storage account. We're going to push a file to Azure Storage in blob form, and we're going to also be grabbing any files that we have there already so we can update them with any new RSVPs. So the first thing we need to do this is create a storage account. So I'm in the Azure portal here, and you can search for Azure Storage Account, and you're going to find this one with a happy green image there of a table, and you're going to create one of those. So jumping in here, we can hit create, which is great. And then we can now go across. Oops, sorry, got the spinning colorful wheel of death. Hopefully that'll go away in a second. But in a second, we're going to be just doing the basics of setting up the different parameters of making a new file. So we're going to be setting the name. Here we go. Maybe we've got some lag going on. This is possibly fine. There we go. Okay. We're going to set up we're going to choose our script description. You might have a resource group already for this. So I've made a resource group that's just like Web App Basic, which is what I'm using for this project. And I'm going to put both my storage account as well as my web app in there once I create that as well. I'm going to give my storage account a name, which for these accounts, they do need to be all just one word, no hyphens or anything. So we're going to put that in there. I'm going to choose my local region or wherever you want to deploy it. And then I am going to choose the most minimal option from redundancy, because I do not need this to be open, all the time and have multiple backups. It'll be fine if we don't. Okay, once we've done that, we can now go across and we want to enable public access from all networks for this example only. So before we do that, I'm going to say, do think about what your application is. If you're making a little toy app like this and you don't have any important data, making a public access for all networks is probably fine because there's nothing interesting that people want to grab in there. And they still do need the key and the connection string to gain access. But if you do want to make something that's bigger and better and might have important data, you might want to use a virtual network or create private endpoints for it, where only specific things or within a specific realm can access the data. So you don't have even the opportunity for somebody else to be accessing the data if they somehow got your connection string. Okay, next up we have we're ready to make our storage account. We hit create and we wait a little minute to get ready for that one. And then when we are ready, we can go across in the portal that's now be like, hey, your storage account is here. And we can just search for key. And we want to find the connection string. This one here is what we actually need. We're going to copy that out. Obviously, not obviously. It's important not to share your connection strings or your keys with other people, because that is what gives you access, as I was saying. And anyone who has this connection string, if you do have that public endpoint open, then can now access your blob, and they could put whatever they want in there or delete things that you have in there, and you don't want that. And generally, always practice good key security when you are using key-based authentication, or you can consider managed identities that will allow you to lock things down more on a per user level. But for this purpose, using a key is a nice way to get started and understand this process without having to get extra stuff happening.
Renee, we're coming up on time.
Oh, okay, cool. Okay, great. Give me 1 hot minute and I'll just show you. We've created this area here. We're going to put our key into a end file here, and then for our local development purposes. So I've just popped that in there, and you can now access that key locally. When you do it for deployment, we'll show you quickly where you can put that somewhere else. We can then make a storage container, which is going to be like, this is where all the blobs live. And then we're going to be able to pop in our RSVP. We're going to call our container name RSVPs, and we're just going to create that resource if it doesn't already exist. Okay, now we need to talk about how we push those blobs to that container. You're going to need to have the Azure SDK, just a nice way to interact with the library. And when we now push through things in the code I'll show you in just a quick second, we can see that they appear in the container. We've seen that container set up here in the portal, which you can see in the storage browser. You can then create the different files there, and we can actually look in the portal in there to view or edit the files, and we can see an RSVP list sitting right there. So let's grab the content out of, let's pop some data into one of those blobs. Sorry, last quick look at the code before we look at our final part, which is we can see in here, back into it, have a helper function which we call sync blob. And basically all we're going to be doing is seeing if we can grab the blob. So we're going to connect to the blob client, which we have the container name and we have our file here. But above, quick look here, where have we gone? We've got our connection string and we're connecting to our blob service client there. So once we've connected, all we need to do is say, hey, I want to download a thing. And then if it's there, it'll be like, great. If it's not, it'll be like, oh, that resource doesn't exist. And then if it doesn't exist, you just upload a new one, or you can just change the one that you have out. So we can either download the file. Sorry, where is the download line? We're going to download the blob, then we're going to update it, and we're going to push a new blob, or we can just, so we've got our delete and upload blob there, or we can just upload a new one. So yeah, that's as easy as it is to upload something to your blob storage, which is fantastic. So now quickly across to how we are going to deploy this, which is super easy. Once again, we're in the Azure portal. We're going to say, hey, can I have a web app this time? We're going to say, here's the resource we want to add it to, so our resource group, and we're going to give it a name. We need to connect it up to GitHub. So we're going to say, hey, I want to, we need to set the runtime, which I've got Python 3.11 set here, and my local area, and choose the most basic, cheapest plan possible because I don't need anything else. Then for our continuous deployment, we need to click enable here. That's the most important part. And then we can say, okay, here you need to log into your GitHub account here and say, hey, this is where my repo is. And then I want to deploy the main branch. And now we're ready to create. And all we need to do is once it's deployed, it will be here at this link. But before we do that, we need to add that connection string for our cloud deployment option to our environment variable. So you can just search for variable in the search panel there and create a new one and say, hey, this is the name of the connection string, and put it right in here. So that's all you need to do. Then you can see the status of your deployment here in the deployment center. And then once it's ready to go, you can go there and click through and you can have a look at that at this link that I think people have already dropped into the chat. But yeah, it's all live on the web right there. And if you want to see more about this, you can go and see the full, this is the whole series. This is not the link to the live one. You can go and see the full series of where I do a lot more on how to do all that in a lot more time. So yeah, that's all I have for you today. And thank you for my extra couple of minutes that I've stolen. I can't hear you, Dawn.
Not too many extra minutes. I started talking on mute again. Not too many extra, but you went through it so much. And so Azure wasn't my first deploying solution. I did a couple before, but I absolutely needed a blog post or something to step through and figure the whole thing out. So I'm sure that this was really helpful, and especially since you went through how to connect like use cases and the internet and all the way to deploying to an enterprise cloud solution, one of the most popular frameworks that people are using for web development, and Flask. So we have a quiet chat, probably in awe. So no additional questions, but I appreciate you being here, Renee.
Absolute pleasure. I hope people got a lot out of it, and I look forward to listening to the next talk as well.
Yay. We'll chat soon. You have a great day.
Thank you.
Bye. And I am so honored to bring in two of our fantastic and recent additions to Python MVPs, just to give a shout out to the MVP program and to these two lovely people that I know in real life, which is just amazing. So the MVP program is, you can find it at aka.ms/MVP. I'm just throwing this out there. We don't actually have a link for that. But they're very friendly on the internet, and I hope I'm not overstepping that you can find their socials and ask them what it's like to be a Python MVP. All the great esteem and street cred that they get from being it. They're senior engineers in the space, and they'll be telling you more about deploying your Django application.
Yes, thank you for that introduction, Dawn.
Yeah, no problem. I'll get out your way. You introduce yourselves properly and lead us on our journey.
Awesome. So, hi, my name is Velda. I am a software engineer and a technical writer, as well as an open source contributor, and one of the newest Python MVPs for web technologies as well. And I love working with Django, and that's what we're going to be talking about today. Afi?
Yeah, hi everyone. My name is Abigail, or you could also call me Afi. I'm a software engineer on the back end, and I'm an open source contributor, and I'm also into partnerships, like tech and partnerships. So that's something about me. It's nice to have you all here, and we can't wait for you to see what we have in store for you.
Awesome. So let's get to it. So the first things first is we're going to go through our how to deploy your application. And the first session is the deployment session, which I'm going to go through. So there are two ways you can deploy your Django app. So firstly, you have seen in the previous presentation by Renee, thankfully, she used the Azure portal, but today we're going to use the CLI because I prefer using it because I'm fond of the terminal. So the first spot you should start with is definitely installation process. So if you're on macOS and you do not have it installed, you should update Brew, then install Azure CLI. If you have Azure CLI already, you could just upgrade it to ensure that you get the latest update of the Azure CLI. In Windows, you would have to start up PowerShell as an administrator and then run this particular command. After running this command, hopefully everything went well and you didn't get any errors. You should actually be able to type in AZ, that is AZ, or AZ.-help to see if you have actually installed it. And additionally, once all the installation is complete, you can verify the installation through the Azure version command. So in this particular code, I am using Azure CLI. The version is 2.67.0, which is the version of my Azure and my Azure CLI. And it also shows you all the extensions that come with it. But right now, I do not have any additional extensions. Once you're all set up, you want to now log in to Azure itself so that you have access, so that when you deploy your application, you can actually have access to the portal as well. So this is going to bring a pop-up of authentication process. And once you log in, it's going to redirect you to your default browser. Then you're going to see, after you're authenticated, it's going to show you this particular pop-up. And then whether you're redirected or not, you can click the Azure CLI documentation link, and you can get yourself learning how to use Azure with a lot of documentation there. So now that we have Azure CLI already set up, we want to ensure that our Django applications are up and running. And that's why we have the Django checklist. I used white noise because it allows you to serve static files directly from your Django app in a production environment. So it's a Python library that is very common and that is also used to serve this particular purpose. And I use pip install white noise. Once you have installed white noise, you also need to add the middleware settings so that Django understands that, hey, we have this, and this is supposed to collect our static files. And then you also want to define this particular line because this is where your static files are going to be stored. Once this is all done, the point of actually setting up this and having the static file storage is it ensures that it can persist when you deploy your application so you don't end up losing your static file. Next is our requirements.txt file. If you do not have an existing one at this point after you installed White Noise, you could easily create one manually, or you could use pip freeze greater than sign requirements.txt, which is basically pip freeze tells pip to collect all your requirements and add them to your txt file. If you don't like using pip freeze, you could use pip list, which lists all the different packages in your file, in your terminal, and then you could copy paste that to your requirements file. Remember that the requirements file goes to your root project, to the root, like it goes to the root folder of your project, or yeah, sorry. I tend to use pip list because then I don't have to keep on worrying about using pip freeze and some other complications that come up. But the important thing is to ensure that your requirements.txt file is set up. It doesn't matter how you get there, just ensure it's there, because this is what Azure is going to be reading to see what packages you're using so that it can actually deploy your app. Next up, you need to also add the name of the website that you're going to be using on your settings.py file on the allowed host. This is so that after you deploy, you can actually see your site and not get a bad request error. If you don't do this, you will definitely get a bad request error because it's not one of the names defined in your allowed hosts. And then something else is, since we're using Azure, it doesn't matter whether you provide the name now or later on. If you provide it later on, you'd have to come back and add your name or the name that you choose to your allowed host and then deploy again, which is a nuance at some level. So you'd rather just use a particular name that you can follow through the whole time. That's why I went with Azure Python Day, because today is Azure Python Day. And as always, you have to include the rest of the URL as well. Now to actually serve our static files, you need to ensure that you have defined your static files in your settings.py file. This is just logistics to confirm that you have the static files here, the URL, and the directory, as well as the storage that we actually set up. Once you have confirmed that your static file settings are okay, you can now officially run python manage.py collect static. This is going to create a production environment for the static files, and it's also going to be included in your application. You'll see it automatically generated. And the last thing is definitely change your debug settings to false, because we do not want everybody seeing what's going on in your logs or release any sensitive information. And the final step, the exciting step, is you get to now deploy. So this is the command I used to deploy this particular app. And the commands here are listed as, the first line is the name, which is the name of the application we defined in the allowed host. We also have runtime that defines the version of Python that we're using. I'm using Python 3.12. SKU refers to the basic service plan that you're using. I chose this because it's a basic level service plan and the application is not heavy and doesn't have a lot of traffic. And then we also have the logs that prints the logs in your console. So this command basically creates the resource group, adds the service plan, adds the name of the application, and then zips the deployment. So what does it look like after you have run this particular command? This is what starts to appear in your terminal. It's going to zip the contents of your file based on wherever the location of your file is. It's going to zip it, and then it's going to start building. Once it's successfully built, it's going to give you a URL that you could easily go to see if your deployment is successful. Sometimes it may take a couple of minutes before it loads, so don't worry. And now, since the application is deployed successfully, you can easily see what the application does. So this application has a homepage, which is the Azure Developers Python Day, and it displays characters from the movie animation, actually, from Atlantis, the Lost City by Disney. If you like to see how this app actually works and the code base and everything that I've used to present this particular code right now, you could scan this URL. And if you want to see how the app actually behaves in your own machine, you can easily use this URL. Just go to azurepythonday.azurewebsites.net. Now, the next session, I'm going to be introducing Afi, who's going to be taking us through the documentation section.
Yeah, hi everyone. Thank you so much, Velda. So I promise it's not going to be boring because I know most devs don't like technical documentation, but as a software engineer or someone who writes code, there should be good documentation for the code you write. Velda took us through the first part, which is letting us use Azure CLI to deploy a web app, which is based in Django. So moving on, we are going to look at certain things to look at when we create documentation for the code we write. So we're going to document our deployment process, and I'll be giving you certain tips and tricks because with every tool you create, you have to document all those things. So before we started, Velda took us through Azure CLI, and just rehashing, we know Microsoft Azure provides us with tools and services and storage and VMs as seen in the previous session, right? So the Azure CLI tool enables us to automate certain things, tags, create, manage resources. I was really happy in the previous session, we saw her use the portal as opposed to the CLI so that you get the best of both worlds. So in this session, Velda highlighted the use of the CLI. In the previous session, we saw the GUI or the platform interface. So you ask, why document your deployment process? Why should we write? Why should we create feature technical documentations? Why should we write reports? Why is it necessary to have a high level or summary of the tools or resources we have deployed on Azure? Why should we even bother? Well, it helps with consistency because it helps everyone follow the same steps. In case you have to move from one team to another or to teach someone something you have deployed, it's easy for you to do that and it makes it more consistent. Also for efficiency, because it streamlines your deployment process. When you have a process or procedure on how to go about certain things, it makes it very seamless. Also, it helps reduce the chances of errors. If Velda is supposed to deploy something and I'm supposed to deploy something and there's no document or let's say a little bit of guideline on how to go about it, you realize we may use different paths, right? So getting a deployment process or a documentation really helps you reduce the chances of errors. We may come across errors which we may collaborate with and go like, hey, I got this error, did you get the same error? And we'll try and fix it. But when you have a document or let's say a blog or documentation like the Azure Docs, it reduces the chances of error or actually helps you solve the errors you face. Oh, great. And also for auditing. So when you document processes at work or on your app or your side project, you realize that you may face certain hurdles that you overcome. It's good to document those things, especially with deployment, so that it's easy to roll back or reapply. You see, in case you need to troubleshoot or check the logs or make sure everything is all right, or to go to a previous stable version. So it's good for auditing too. Now, moving on to the tools for documentation, you wonder, aside from Medium and certain blocks, what are other things we could use to document our deployment processes? So for Azure, there's a tool called the Azure Documenter in Turbo 360. It gives like a high level view of the resources and tools you use and how much they're consuming. So you could sort of track it. And you could either use this as a summary or add a screenshot or the information into a document if you are providing a report to your team. So that's one. The Azure boards, I know we are really used to Jira boards to track tags, but listen, it could also help you outline the deployment process, because you see, when we use a Kanban board or the Azure board, you list all the tasks in a sequential order and then you end up moving them. So Azure boards could be a way for documenting your deployment process. And that one is open to the whole team, so everybody knows what's yet to do, in progress, and done. And then the third one is publishing sites. That one we are all used to it because we use Medium, .dev, we use platform engineering blogs, GitHub pages, and GitHub gist. So these are all types of things that we could use to document our processes. Great. So this is an example of what I was saying with a high-level view. And yes, so it gives you a summary of the resource groups, resource types, locations across which the resources are distributed, and also a billing summary, because you need to track how much you're spending. I know there are thresholds to see how much not to go above a certain threshold, but if you have a summary of the months and how much you spend, it will help make a more informed decision for the rest of the year or for the years ahead. So yeah, I think we saw this already. So this is like a snapshot of the action, the count, and the cost incurred. So this is just an example that I saw. So based on the web apps, alert management, application insights, you can see the count and then the cost. These are very important when you are deploying an app, because if you have an app that's costing thousands of dollars and you are not tracking it efficiently or documenting it, it becomes a problem, because it's hard to see what you can do to mitigate or make things easier, or where the money is going, or what resource you have to limit, or what resource you have to put more money into. So now we're going to look at the key components of deployment documents. It could be in different forms, but there are certain things that must necessarily stand out. So overview, the purpose of the document, as I said, is to put certain things that are necessary for your deployment process inside, for your team or for yourself, or for anyone who needs that information. So the target environment could be the dev environment, prod, or staging. In the previous example, I think Velda used prod, the prod environment. Also, it highlights the application or service being deployed, which in this case is the Azure Python Devs Day, right? And then the deployment frequency. How many times do you deploy in a week? Mostly people tend to deploy once in 2 weeks, bi-weekly, or probably about once in a week. So it depends. All those things have to go inside the document. Yep. So, but deployment, right? There's pre-deployment, there's deployment, and post-deployment. These three stages are really crucial because they inform how the deployment is going to go. There's a saying that goes like, without proper preparation, right, things are bound or likely to fail. So with pre-deployment, you have code review and testing, which is mostly done by QA. But software engineers are supposed to test their code before pushing it to QA. That's the actual right way. Then you have the configuration changes, which is normally in the form of a config file, right, where you declare your jobs and then the batches and all those things which are going to run. Also, if you have database updates, all those things are done in the pre-deployment stage before you push the code. So with the deployment, we have the code deployment itself. With what Velda showed, it was done with GitHub Action. So the code was hosted on GitHub, and then we run the pipelines. You can move on. Yeah, with the configuration deployment, it still talks about the config file that you use, which is in the form of a YAML file. And then the database deployments, because you make changes to the database, and then you restarting or reloading the services to update it after you've made that deployment. So in the end, after preparing well and deploying, there's the part where you have to see if what you've done is the right thing or the wrong thing or what has changed, and that's the verification. So you have to see how it functions, whether the performance has increased or decreased, optimizations that could be applied, right? And if it comes to a very, not bad, but worse or unexpected change, you could roll back. Django is really, really good with rollback. So if you run a migration and you want to roll back, yeah, there's rollback like strategies that you could use once you have your migration files intact. The tools that we use in this presentation is the Azure CLI, as we already said, or you could use the app service. Personally, the CLI is really cool because you just run one line and it just works. But you could also use the app service, which is also great. The deployment tools, aside Azure, you could use Jenkins, Ansible, GitHub Actions, Puppet. Then with the IAC, which is infrastructure as code, as in the configuration deployment files I mentioned in the YAML form, that one you could have it in Terraform, CloudFormation. You could have it in different forms. Once it's just a configuration file. Also to monitor, Azure already has Azure Insights, which gives you insights into the app you've deployed. But outside Azure, you also have Prometheus and Grafana. Ooh, so this is where people tend to shift blame, because when things go wrong, as I was saying, it has to be specified in the document who is responsible for each step for a particular process, who approves deployment, who is going to be on call after work hours for support, because things could go wrong. Your Azure resource could go down, things could be slow. There should be someone who will be there after hours to handle or solve these situations. Mostly, companies have something called a playbook. A playbook is similar to a deployment document, but it specifies certain rules that you should take when a particular action happens. So considering having a playbook and a deployment document is very, very good to make sure that your services and your resources are always up and running. Also, you saw Velda showed a Django checklist. So these are the checklists I should have with the deployment documents. The pre-deployment, as I said, the deployment itself, and then the post-deployment. Okay, so now we've gotten to this part that I'm just going to talk a little bit about it. So when you have the code residing in a repo, right, and it's being pushed to Azure, then it's built and then it's released. So the release pipeline is where the CI/CD comes in. And when you deploy, it goes through the stages. So testing whether it's accepted, and then it goes into production. So in these stages, there are different checks that make sure that the thing you've pushed, whether it's the configuration file, the database changes, or your resources are being configured and it's in the right way. Also, in another similar fashion as Velda did, you have the GitHub repo, the Azure pipeline build, and then the release. So when you're creating in the app service in the previous demo, I think Renee was showing when you create an app, a web app, there's an opportunity to add a pre-deployed app and authorize GitHub in there and select the repo when your name appears. So that's also another option if you don't push from Azure repo. So these are the references I use for this and then the testing, and it's nice to talk to you and let you go through the process of documentation when it comes to your deployment process. Thank you so much for listening to me, and have a good evening. It's evening here, but good morning, good afternoon, good evening, wherever you are.
Yeah, good morning. Don, you're muted.
I did it again. It is all over the world. We just were talking to Renee, and it was morning time where she was. And thanks so much for staying up so late to give us a great presentation. We were in the chat talking about how wonderful the graphics were. I'll give a couple of minutes to see if the people who are in the chat have more questions, but I have a question for you all. So you both are prolific speakers and contributors, volunteers in your respective communities. And I know that's one of the reasons why I think we were able to be connected, and we're such a great fit for the Python MVP program. Can you tell us a little bit more about how you got involved or the value that you've seen in your career by getting involved in the community, and maybe how, I know you're both new to the MVP program, but how you may want to invite people in who might be interested in the MVP program. And we'll start with you, Velda.
Could you repeat? These are like 3 questions.
I know. So just talk around it, right? So mostly of the MVP program and being involved in the community, how does that serve you in your career?
Oh, yeah. So I started off writing code in open source. So I was accustomed to like, this is what people do. Like once you get in, you use the space or you use the technology and then you give back to the technology in different forms. That could be writing code, right? Going to meetups, organizing. Like there's so many ways that you could contribute that are not like specifically in code. And yeah, I have done most of these things. I have written code, I have organized, I have spoken in all these local and international events. I have done all that. And the beauty of all this is that you get to meet people like Don and Afi and hang out with people and get to learn what they know. Like you can have 1,000 people in one room and have 100,000 more of what they know. And you could learn all this through just a conversation, even asking questions. And so what I would say is once you're coming into this space, be open, ask questions. People are always ready to help you. And there's so many resources also available to you. And in your own way, you could also figure out how to give back to the community that also serves you. And it also helps because now that you're also visible, like people can see what you're doing, you can get access to more opportunities, and opportunities are good things. So yeah, it's a win-win situation. And also for the MVP program, I love that we have different discussions there where we're talking about whether it's a deployment gone wrong or what you need help with, because that happens a lot. Even when I was doing this presentation, I had like 5 more steps, but then I was like, wow, I didn't realize that you could actually deploy with just one line. Previously, I was creating the app, doing the resources, then adding everything else that I need. And then I think I posted it on the chat and somebody was like, oh, actually, you can accomplish this in this one line. I was like, ooh, countless nights, but I got there eventually. So yeah, it's exciting. And I don't know how to invite people to the MVP program. Basically, I don't know how that's supposed to work, honestly. But yeah, I believe once you find people who also are already involved, it's easier to get probably a recommendation through that. So, but there's a catch. You also need to have done like solid community work because that's going to be part of the application process. And if you don't meet that, then even if you get recommendation from people in Microsoft or GitHub, it's not gonna work, right? You need to have work to back up your application. So I would say continue doing the work that you're doing, continue making yourself visible, get access to MVPs. We're actually everywhere, and most of the MVPs I've met are really nice and cool people. So you don't have to be afraid of anything.
Great.
Yeah,
And
that's
I did
great.
ask like 4 questions. I asked 3 and then I asked another one. So Abigail, you can pick which of the 4 questions you want to answer, or
Okay,
all
so
of them if you want.
well, I would say for the MVP program, as Velda said, yeah, put in a lot of work into community and also your personal, let's say, career. Try and always make sure that you are upskilling at every point. And also, I got into volunteering, and I met Velda about 4 to 5 years ago. I didn't know I would meet her again. We met at the Google Sub-Saharan conference for leaders with Google Developers Group, and I didn't know I would meet her 3 years or 4 years after. So the people you meet on your way up are the same people you meet on your way down. Be nice to people, be open. Some of us are naturally shy. I understand. Like it's really hard walking up to people and talking and hey, I do this, I do that. You want your work to speak, but try and have people skills. It will take you really, really far. So yes, just keep killing it, putting yourself out there, and yeah, more of him.
Yeah. Well, thank you so much. You were both the last presentation of the day, and we're an awesome boost of energy despite how late it is where you are. Thank you so much. And I appreciate your contributions.
Awesome. Thank you for having us.
So much. It was nice being here. See you.
Bye, all.
Bye.
Bye.
And that's it. I am closing out the day. I'm Dawn Wages. I am the Python community advocate here at Microsoft. And it's been a pleasure creating this day with you and a ton of people who are behind the scenes. Also imagine the countless hours that's been used to make the presentations for you all day today. It's been a treat. So thank you all and have a great day, night, morning, wherever you are. Happy coding.